That's so cool.
It's okay.
It's going to be amazing. Yes. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool.
It's okay. It's okay.
That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
It's going to be amazing.
It's okay.
Yes. That's so cool.
That's probably enough drinks for tonight.
Hey, my name is Max. I am an independent database consultant researcher and big fan of SQL. And today we're going to talk about databases code, not only migrations. We will discuss what is it, is a databases code in real life, in wildlife, and we will see that migration scripts are just the very beginning of the hard road to database as code. Let's go. And we will start with everything as code things. Everything as code, as we know, is a philosophy where any IT area might be represented as a plain code. And we can work with it using standard tools and technologies like editors, control version systems, static analysis, etc. And yes, indeed, there are many everything as code realizations for many areas. For example, GitLab CI, Ansible, Markdown, and much more. And we can get all the benefits of working with code. You have no more monstrous GUI where you're afraid to click something wrong. You can use full version control for all your changes. You can put your code to the CI/CD pipeline, and everybody in your team is coding and using the same tools. We're used to the everything as code things, and we love it. But how about database as code? It was a very exotic combination of words, but then North, in his talk, Aren't We Forgetting Someone, proposed 4 simple rules for creating a database like code. All database changes are scripted and automated. All database changes are under version control, ability to release on demand at any time, and DBA should be integrated with dev and ops people. It's been 6 years, and nowadays it's hard to find a project that doesn't follow these rules, at least the first 3. There are a lot of different database migration tools and different ways to integrate it with your version control system and your CI/CD pipeline. For example, Flyway, GitHub Online migration tool, Sketch, Schema, and of course, Liquibase. And it's really great. But we know database is not only schema, is not only DDL operations. First of all, database is data and queries to data. DML for data and metadata. Also, database needs administration like space management and memory management, monitoring like metrics, gathering and performance troubleshooting, documentation, and all the stuff. And there is special language for all these things. And of course, it is SQL. SQL is a universal language for data and metadata. And SQL, first of all, was made by humans for humans, not for machines. But on the other hand, we have some problems with SQL. I call it SQL hell, like jar hell or DLL hell. Our SQL queries scattered everywhere. Our applications generate tons of dynamic queries. Many static queries are injected directly to the code of another program, like Java, Python, or something else, or place it in configuration files like YAML, JSON, or TOML, and we can't control, test, and trust these tons of SQL. But how about that simple idea? Keep all SQL queries as normal code. Why not? And I have prepared some additional database as code rules. All changes and operations with the database and all queries against the database should be expressed as a plain code, not only DDL, but DML and all other kinds of SQL too. Git or anything else version control system is a single source of truth for all your database code. SQL actually is a main database language supported by almost all DBMS and storages. And treat your SQL code, your SQL queries like normal code. SQL is a human-oriented computer language for your data and your database is not a bytecode. It also needs static analysis, code review, tests, and automation of it all in your CI/CD pipeline. The full version of these rules is hosted on GitHub. Please check it out. And I will be very grateful for the stars, pull requests, issues, and any other feedback. But are there tools in real life that satisfy these rules? And our answer, yes, it is. First of all is data building tool, or simply DBT. DBT is a tool for data transformation. And the main idea is very clear and very simple. You just drop SQL file with your select statements to your repository, while DBT materializes these statements into tables and views. No boilerplate code, only SQL. DBT provides also testing framework for your queries, templating with Ginger tool, relationships management between queries, visualization of these relationships, and much more. Another example is data mapping. Data mapping tools are usually very sophisticated tools for extracting and mapping our data to our data structures. It usually results in SQL code generation and performance issues. But some tools provide to us a query first design. You just drop SQL file with your query to a repository and use it from your application code. It's very simple and predictable, and no magic. There are a lot of query first libraries and frameworks for different languages like YesSQL, HackSQL, PugSQL, SQLite, and much more. And finally, I would like to present my small experimental project based on the database as code ideas. Malevich. Malevich is yet another graphical SQL client or SQL manager for database schema exploring and performance analysis, but with some key features. This tool was originally designed for hacking and extending, and you can use for that only your SQL skills and a little bit HTML skills without any boilerplate code. Check it out on GitHub and try online demo. So that concludes my presentation. Thank you all for listening. It was a pleasure being here today. Feel free to text me at any time and follow me. Finally, I will be happy to answer your questions and keep your database as code.
Hello and welcome everybody to today's talk, The Road Towards an Open Database Performance Ranking. And before we start into the technical details into database performance in the cloud, some brief words about me. So my name is Daniel. I have a research background. I studied computer science and did my PhD at the Ulm University in Germany, with a focus on evaluating large-scale distributed systems that are operated in the cloud, with a dedicated focus on distributed database systems. And the results of our research actually led to the spin-off or the startup BenchEnd, where I'm one of the co-founders and responsible for the product development. And having that said, let's start into the advances of database technologies for data-intensive applications, and especially their advancements over the last decade. So driven by the Web 2.0, big data, IoT, there has been a tremendous change when it comes to how to operate database systems, but also how to select database systems. So when it comes to the operation, it turns out that there's a significant move from physical resources towards elastic resources, which are cloud resources, but also edge and fog resources. On the database side, relational database systems are not anymore the only choice. There are now a plethora of choices since the database landscape has been extended with the NoSQL and also the new SQL database technologies. And this has basically led to two key aspects. So first of all, cloud resources have become the preferred solution to operate database management systems nowadays. The second one is that the idea of a one-size-fits-all database system is basically over. And with these advancements and changes in the paradigm, there come a lot of new opportunities to build even better data infrastructure or data management systems for your data-intensive application. But with the with this broad scope of opportunities, there also come new challenges, especially if we look at this rather simple challenge. So finding the right database technology in the cloud that provides 100,000 ops with a 5 milliseconds of latency for a data-intensive application, and to do that in a cost-efficient way. So this is actually a question that comes up quite often in any IT department, and it quite often also hits several stakeholders, but there is no clear answer to that. And why is that actually the case these days? Well, where should we actually get the data to answer this question? If we look at the database systems, so of course we can read the docs, and there we will get a lot of details on the actual feature set of the database technology, the usability capabilities, but also the tooling around the database system. But when it comes to the non-functional features, so the performance, the scalability of the system, but also the costs, it gets way more trickier. The costs, well, all the cloud providers, they have very heterogeneous cost models, but with some effort, it's of course possible to bring that together and to have a comparable cost model across different cloud providers. But when it comes to the performance of the cloud providers, but also the performance of the database systems themselves, it already gets really challenging, because this data won't be available anywhere on the cloud provider side or on the database vendor side. Of course, you will find some white papers, some blog posts, and so on, but this will basically never exactly match your use case. And the same goes for the scalability of the system. Of course, basically all providers promise to provide scalability, but having the hard numbers to actually demonstrate that's another point. And when talking about promises of the database vendors, well, let's have a look on their market promises. Well, basically, I just picked a few here. They're basically having, or all database vendors have basically the same pitch line. So they're, of course, the fastest database you can find. So that ranges from unparalleled performance to speed scale, high performance, even explicitly naming that outperforming some of their competitors and so on. But this is, of course, the database vendor side. And yeah, as a IT expert, of course, you want to verify that these promises are also, valid. And where could you do that? Is there already a single source of truth out there? Well, there are several really good sources to get in-depth details on database systems. For example, we have the database of databases maintained by the Carnegie Mellon University that basically provides an overview of currently all existing database systems with a lot of additional data around them when it comes to their functional features, licensing, and so on. But there is no performance data included. The same goes for the DB Engines ranking that provides you a really good ranking for the database system based on the popularity. So speaking about popularity when it comes to Google hits, Stack Overflow mentions, and so on. But again, no real or no performance data. Of course, there's then a very common third option, which is, just ask Google. And you will always get an answer if you look, for example, for the fastest database for any kind of use case. You will find some blog posts, white papers, even research articles that are talking about a very specific use case. Also might be biased by the vendor, or just having a really small scope of the performance data available, and so on. And if we also look on the, let's say, on the golden rules, how should you assess performance issues when it comes to cloud and cloud-hosted database systems? There are also some really good golden rules by well-known companies and experts in the field. So first of all, if we look at the cloud provider side, we have, of course, AWS that highly recommends to measure the performance of applications to identify or to do the right sizing of the instances. But they do not provide you any tooling to do that by yourself. They just recommend that to you. We also have the database vendor side that basically recommends the same approach. So, for example, here we have MongoDB, and that always recommends measure everything when it comes to your use case and assume nothing. And on the IT expert level, of course, we have the well-known statement by Peter. So if you have to address a database performance challenge, do it in a methodological way and just do not settle for random Googling. And this is also actually something that we see what is currently missing out there, and especially as an open and fully transparent way to assess the performance of different database technologies in combination with different cloud providers. And this has actually brought us to build the first global database performance ranking. And in the following, I will talk in more details. First of all, why are we actually able to build such a global database performance ranking, or basically the first database performance ranking? And second, why is this global database performance ranking actually trustworthy? Why could you rely on the data? What can you do with it? And how did we achieve to provide the full transparency? These are basically the two paths I will cover in the remaining time of the talk. And starting with the question, actually, how are we able to build such a global ranking? Well, let's move one step back and just have a look at the benchmarking of database systems in order to get these performance data. And there we're going to have an explicit look on the benchmarking in the pre-cloud versus the cloud era. So in the pre-cloud era, we had the database systems sold basically as appliance. There was a clear landscape. So relational database systems were predominant. We even had, well, not forever lasting, but at least lasting benchmarks results when we think about the TPC results for example, Oracle, IBM database systems that were operated on dedicated hardware. So there were actually these tables where you could just look up which database system provides you what kind of performance, and it was rather easily comparable. Nowadays, with the cloud database era, well, we have now a plethora of cloud and database options. So already talked about the NoSQL, NewSQL, but still the relational ones offered or operated either on infrastructure or offered as database as a service and so on. The cloud and the database technology domains are rapidly evolving. So they're basically popping up new database technologies still basically every month. And also new cloud resources are thrown on the market with the same kind of release cycle. This has also led to the term of polyglot persistence. So you're using multiple different database technologies within your application stack to solve very specific needs of your application with the right database technology. But all of these has also led to the problem that there's actually no up-to-date benchmarking data. And that this is the case, well, because of these rapidly evolving technologies, because of this very widened domains on the resource, but also on the database level. And in order to get this benchmarking data, let's have a brief look on how did you get that benchmarking data in the pre-cloud era. Well, the process of benchmarking your target system was rather straightforward. So you had your database system operated on dedicated hardware. You just had to select the right benchmark, configure the benchmark, execute the workload, and process the target objectives, which were mainly performance and costs. But already setting up the right benchmark and so on is of course a challenging task, but still. If we look now in the cloud era, well, the process has been extended or has expanded. Well, of course, nowadays, first we need to allocate the resources. So either EAS resources or DBAS resources. And yeah, of course, then depending, we need to deploy and configure the database cluster. Again, select and configure the workload together with the benchmark. And then not only costs and performance, which are of course still major objectives, but also the scalability, the availability of these distributed systems are becoming very important objectives. And also probably elasticity of the database system if we're talking about auto-scaling the database system or these serverless database systems that are able to cope with growing and decreasing workload intensities. And yeah, with these additional aspects in the benchmark process and the previously mentioned frequent release cycles of new technologies, new versions, new cloud resource types, and so on, the process is also way more dynamic and continuous than it was in the pre-cloud era. And besides that, the use cases that are, or the workloads that are thrown against the database system also have evolved. So pre-cloud era was more towards the e-commerce, finance kind of workloads. Now we also have social media, IoT, AI, but also fintech workloads. And yeah, there or these challenges have basically brought us to identify the need for automated database benchmarking to be able to cope with these very dynamic technology domains, and in order to provide continuously performance data, which is also up to date. We have identified that there needs to be a full automation of this benchmark process. Otherwise, it won't be possible to cope with that. Yeah, with these evolving domains actually. And if we are now looking in the process of how to enable such an end-to-end benchmark automation for cloud-hosted database systems. The good thing is that, of course, we don't have to start from scratch, since over the last years, there have been a lot of tooling released, open source tool, but also commercial tools that can support you in fully automating that process. So if we look, for example, on the cloud and database orchestration tasks, there are many tools out there that can support you in doing that in a reproducible way. So we have these cloud automation or infrastructure as code tools such as Ansible, Terraform, Chef, and many more that can be applied to handle the resource allocation, database deployment and configuration, and so on. When it comes to the benchmark selection and execution, of course, the database community has been very active to move along with the new applications that are that have been evolved, and in order to cover the new workload domain, there have been a lot of work done in providing benchmark suites that cover these workloads. So there are of course the TPC benchmarks. There are many more, such as the Yahoo Cloud Serving benchmark, the Sysbench, TLP, time series benchmark suite, Benchbase, and many more. So this domain is also really well covered in order to address multiple different workload types. And when it comes to processing, aggregating, and visualizing the results, of course, there are also many tools out there where you can just put all the processing in and provide really nice interactive dashboards and so on. Also just naming a few here. But of course, the challenge remains to bring all these three pillars basically together in one end-to-end framework. And this is something that has been has gained way more focus over the last 2 to 3 years. Why we started with our research earlier, so basically now 5 years ago, but we've seen that over the last 2 to 3 years, there has been way more attention to this end-to-end benchmarking. For example, MongoDB published several papers on their continuous performance evaluation or benchmarking framework that they're used internally. Started with it, I think, in 2019, in order to improve their performance continuously with every new commit they may make to their source code. A rather similar approach is followed by ScyllaDB. They also provide an end-to-end benchmarking framework when it comes to run ScyllaDB benchmarks in a clustered environment. FlexiBench is coming more from the research side that focuses on the end-to-end automation of single node benchmarks in Kubernetes environments. The Mowgli framework is actually the research artifact that we've built during our academic careers, or the set started with it for 5 years ago. And it also provides an end-to-end automation for benchmarking database systems that are operated on infrastructure as a service across with support for multi-cloud. So the framework supports, for example, OpenStack clouds, EC2, but also Google Compute Engine. And we took basically these concepts to the bench-end platform to enable a way more powerful end-to-end benchmarking as a service platform. So as already said, the Mowgli framework was basically the research artifact that is the open source version of bench-end. It is available in the spec research group tool repository with all the documentation, source code, and also easy deployable Docker containers to spin it up. And the framework basically provides you support for automating the full benchmark process that we see in the upper lane by specifying an evaluation specification, takes over the execution, and it provides you a multi-objective analysis. So it not only provides support for performance and scalability, but also for other objectives. And the data sets that you can get out the framework are built to ensure full transparency and also reproducibility by providing all the required metadata that you can actually replay the benchmarks or rebuild the benchmarks by yourself if you want to. And the framework itself, it's a microservice-based architecture with multiple components. Just a brief overview here on the architecture. It provides one central API to trigger the benchmark executions and also to get the results afterwards. And internally, there are a lot of microservices that can easily be extended or replaced to add new features to the Mowgli framework. And I will briefly go over some use cases that can be addressed with Mowgli. So as already said, you can of course apply it for database performance and scalability benchmarking by also including the aspects of different cloud resources. More details can be found in the paper and also quite some interesting results. You can also apply the framework to do elasticity benchmarking. So auto-scaling the database system under different kind of increasing, decreasing workloads and see if how the database system handles the workload spikes, and also how adding new nodes during runtime is really a good idea or not. Another use case that we covered with the framework is chaos engineering, where we inject failures in a running database system, measure how that affects the performance and also additional availability metrics at runtime. And as already said, the data sets that you can get out are pretty powerful. So what you can do with that, besides just do the sole measurements, is also build new technologies on top of that. So here we applied the data sets to build a performance model to predict the performance for specific database system, and in that case it was Cassandra, how the performance is going to change if we increase or decrease cluster sizes that we haven't even measured yet. And we also applied the data sets to ease the database and cloud selection process by applying a multi-criteria decision making for cloud database selection. So this was a brief overview which use cases can be tackled with such an end-to-end automation framework. And now we brought these concepts into the benchmarking as a service platform bench-end that of course, extends enhances the feature set of supported database systems, supported cloud providers compared to the Mowgli framework. In addition, Benchend provides an easy-to-use web interface to configure your own benchmark scenarios if you're interested in that. It also provides a powerful API to include this benchmarking framework into your CI/CD pipeline to do continuous benchmarking within your DevOps cycle. And we also added a way more powerful analytical dashboard that provides you the metrics of the target objectives, ranging from, let's say, high-level management view, aggregated scores, down to the real tech level, fine-grained time series-based data. And with this benchmarking as a service platform, you can actually enhance your DevOps cycle with these benchmark or with these data, with the performance and cost data that you can get out of it, and address several use cases ranging from pure database performance comparisons, cloud provider and resource performance comparisons, loaded stress testing, scalability, elasticity evaluations, but also do application-specific database optimizations. You can also do the version monitoring. So before rolling out a new database version, do some benchmarking in order to see that if the performance changes with rolling out the new version or not. We did that, for example, for MongoDB, and it turned out that there are still significant performance changes if new releases are, or for the new releases, for example, and they're not always, performance is not always becoming better. And of course, that can be applied to benchmark any new cloud resource offer or new database vendor. But this was it now more the from the use cases for the Benchend platform. Another thing that you can do with it is what actually brought us here today. And this is, you can build an open database performance ranking with it. Since we can now run very easily large-scale performance studies for multiple database systems, multiple cloud providers, and even apply multiple kind of workloads on these database systems within just a few clicks. We use our tool now to provide to the community the open database performance ranking. And before we dive into the ranking, some features, dimensions, and also disclaimer on the data. So the ranking is provided as open data by us, by Benchend. Currently, the performance data comprises cloud-hosted database systems, so database systems that are operated on infrastructure as a service, but also database as a service performance data. We benchmark open source, community edition, but also enterprise database versions. We have multi-cloud performance results since we applied the same workload across multiple cloud providers. Benchmarks, the measurements are actually built upon established open source available benchmark suites, so that you all also can, if you work with them already or want to have a look at their source code, it's easily or it's fully transferable. And we also include in the ranking the default configurations of the database system versus the tune configurations. And tune configurations can be provided by any database vendor, by the community, or by research-driven institutes. And the first release of the open database performance ranking is available since a few weeks. We have there 9 popular relational, NoSQL, NewSQL database systems in different cluster sizes. We used 3 different virtual machine sizes on 3 cloud providers. We also have, I think, already 3 database as a service providers in there right now. The benchmark that we applied is the Yahoo Cloud Serving benchmark, which is out there, I think now for 12 years, which provides a very, very basic performance baseline built on a read update, very simple read update workload. And the ranking is continuously extended with new databases service offers, cloud providers, and benchmarks. So the next release will cover a transactional workload with a focus on relational database systems. And after that, we're gonna publish a series of time series benchmarks, but of course with a dedicated focus on the time series database systems such as Influx, Victoria Metrics, QuestDB, Crate, but also well, general purpose database systems such as Cassandra and MongoDB. And before we actually dive into the results, one disclaimer. If we remember the statements in the beginning for the golden rules, how to select your database system, we do not want to claim that this should now be the only and golden source to select your database system and solve any kind of performance challenge. Definitely not. It should be a very, very, very first starting point if you're interested in the performance or comparing the performance of different database systems or different cloud providers. And you want some trustworthy and reproducible performance data, then our ranking should be the first step to go. But of course, you will need a lot iterations of very application specific benchmarks afterwards to really solve performance related challenges or do performance related decisions. And as already said, the first release is based on the very simple Yahoo Cloud Serving benchmark workload, which barely reflects any realistic application. We also did only one run per benchmark or per configuration. So right now we don't have the variance in performance in it. We have it in the benchend platform. We're thinking about adding that as additional metric in the future. So iterating or executing multiple runs, aggregating the data and build the statistical measures out of it that you can see if the cloud provider performance is stable or not. Because in the past, we also have seen that some providers provide really stable results, some providers really don't. The full data set is available upon request. That will include not only the performance data, but the system metrics, the cloud and virtual machine database configurations, and all the required metadata so that you can actually replay the whole benchmark by yourself. And we will release that data in the next weeks also on GitHub. So if you're interested in that data or you want to have a really deep look on the results, feel free to already check out our GitHub repo, and there you will get notified as soon as the data is available. And having that said, now let's start into the actual ranking and the results. So with the ranking, you have basically a lot of filters to narrow down the performance numbers that you're actually interested in. So as you can see, we have right now performance data for AWS, for Ionos Cloud, which is a German or European-based cloud provider, and for Microsoft Azure. Right now, we have these Yahoo Cloud Serving-based CRUD workload. The OLTP one is coming soon. We have 4 workload sizes that differ in the amount of concurrent threads that are executing the workload. We have these database technologies in there. And we also have, as already said, the cluster size is small, medium, large. So 1, 3, 9 nodes. And the virtual machine sizes small, medium, large. And what you will get out of there is these performance numbers. So you will get the average throughput per second in operations per second. You will get the read latency. You will get the write latency. You will also get the monthly costs to operate that database system. Here, these are only the operational costs on the cloud level. There are no license costs included in the current results, since we only used open source available database systems. If license costs would be, if there would be license costs, then these would also be included in their monthly costs. And we have the throughput per cost metric, where you can actually see how many ops do you get for your dollar per second. You will also get a bit more metadata if you hover over the database system or the cloud resources. And you will get the full metadata with the data set. And what can you actually do with such kind of performance ranking, or with that kind of performance data? Well, there are several use cases that can be covered and might be of interest to you. First of all, of course, we can do a plain performance comparison. Here we see the results for a single node database system that is deployed on AWS resources, always the same instance type. And we see that, for example, your Postgres in version 13 is really good, provides really good performance, followed by Couchbase. And yeah, you can easily now grasp, or you can easily see which provides the best throughput, which provides really low latency when it comes to read and write operations, what would be the costs, or for that kind, more interesting, what would be kind of throughput per cost ratio. We also have, as already said in there, not only database systems that are operated on infrastructure as a service, but also database as a service offers. So what you can also do is to compare, well, different database as a service offers with respect to their performance. So we have, for example, here, the Postgres RDS service on AWS and the equivalent on Azure. And we can see that when it comes to the monthly cost, they're basically same price range. But when it comes to performance in terms of throughput, AWS does a better job. When it comes to read latency, Azure does a better job. When it comes to write latency, again, AWS does a better job. So here you can easily compare different kind of database as a service offers in with respect to their performance and cost numbers. You can also compare infrastructure as a service hosted database system versus database as a service offers. For example, we have in the first row is MongoDB that is deployed on EC2 resources, and second row, MongoDB Atlas on AWS, third row, MongoDB Atlas on Azure. Always same instance dimensions, so same number of cores in memory. And we see that even an untuned default configuration of MongoDB on EC2 resources provides the highest throughput, and of course is the cheapest way to go. It's also interesting that MongoDB on AWS on Azure provides really bad performance. This as a side mark, so AWS Azure it's not in general a bad performing cloud provider, but we run all these benchmarks in the North Europe region. And right now, the North Europe region is heavily overbooked when it comes to any kind of compute resources, and therefore the performance of Azure-based database systems is significantly worse than or decreased compared to, for example, AWS. An even more drastic example is when we compare Postgres on infrastructure as a service. Here we see that, for example, AWS and Ionos nearly the same performance, while Ionos is even cheaper than AWS. Nearly the same price range as AWS. But Azure is really providing really bad performance, while still with the same instance sizes and same storage backend as Ionos and AWS, or comparable. And again, as already said, this is the case because the North Europe region is highly overbooked. The the last use case you can address with that ranking is to check the database scalability. As already said, we have several cluster sizes, several virtual machine instance sizes, but also several workload intensities. And what you can see here, for example, for Cassandra, is that with the increasing workload intensities, you also get a really good scale up factor for the throughput. And even the latencies remain really stable. Read latency even decreases, while write latency is rather stable. Only with the 9-node cluster, which is the first row, you see an increase in the write latency, but still it's still a really good scaling scalability results for Cassandra. Of course, you can also apply the same for all the other database systems that we have in the 1, 3, and 9-node configurations. So that was a brief overview on our ranking and what you can actually do with the ranking. There are, of course, many more things that you can go into more details and so on. So feel free to check out the ranking, play with it, and reach out if you have specific questions or you want to have a look at the raw data. We also really want to see if that helps the community or how the community adapts our ranking. And therefore, we also have a community call, actually. We would love to hear what kind of database systems would you've been interested in having in the ranking. And if you're working in the database field and you know how to tune actually a database system for a very specific workload, we're happy to include your configuration in the ranking, and of course tag you there either with your name or company to provide you a platform to show that you know how to tune specific database systems. And in case you're working currently on a new benchmark, probably coming from academia, but also from industry, and you want to demonstrate its necessity and also its applicability for large scale studies, we're happy to include your benchmark and perform and add a new workload category for or based on your benchmark. And as already pointed out, you can do a lot of interesting stuff with all that performance data when it comes to machine learning based database optimization or recommender systems. And if you're building such a system and you're looking for data that can help you to train your models or enhance your recommender systems in the context of cloud and database systems, we're happy to share these performance data that we collected over the last years, and to build a great system together. So in order to conclude this talk, we'll briefly summarize the key aspects. So running benchmarks for cloud hosted database systems has become way more complex than it was in the pre-cloud era, and it's time consuming and also error prone, especially if you want to do that in a transparent and reproducible way. There are a lot of rankings of database systems out there, but there is no performance-based ranking. This is why we applied Benchend to provide the first database performance ranking, and is outlined with also this first benchmarking as a service platform. We have been able to build the first performance ranking, and the ranking is continuously extended. The next release is already set is on time series database systems and also on relational workloads for relational database systems. And with that, I hope I got you interested in database performance data and showed you a way how you can ease the benchmark process, make it more reproducible, more transparent, and open to the community. And I'm happy to answer questions on any kind of performance related questions on the ranking. Feel free to reach out to me. And I'm looking forward to your feedback. Thanks a lot.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, welcome to the PMM on Kubernetes talk. My name is Denys Kondratenko. I am working at Percona 1 year and 5 months. I work on the PMM product as engineering manager, so I manage other developers as well as a personal contributor. A PMM is Percona monitoring and management solution to observe your database infrastructure performance and health and whatnot. So you could go and read documentation here in our website. And today I would be talking about how to run it at Kubernetes, right? So we would like to measure your performance whenever your database is running, and one of the use cases you could run your databases in the Kubernetes cluster with our operators, and PMM could be used to also monitor and manage your databases there. You can connect it from the outside as the Docker container or like a cloud image. But it makes sense, and probably it's better for some users to run the PMM on the same infrastructure, right? So if you're already running everything in Kubernetes, it's much more easier to manage everything centrally and run the PMM inside the Kubernetes as well. So recently we started to add this feature for running PMM in Kubernetes, and I will be talking about that right now. So how to get started? First of all, we created the Helm chart for the PMM. There is the Helm chart repository that is available in our GitHub, and here are the sources for those Helm charts. So you can see number of different Helm charts over here. So one of them is quite fresh one, is the PMM. So we choose the Helm chart as a deployment tool for Kubernetes because it's quite easy to use, and it's one of the de facto standards how to deploy the different applications and operators, anything, databases as well, into the Kubernetes. So to start with that, there is the README file. Currently this only technological preview, but we are planning to release it very soon in the production use cases. The development is still ongoing, but it's quite ready for you to try, and let's see how you can do that. So you need the recent Kubernetes versions that currently support it, and Helm 3. something doesn't really matter, but here you can see the list of the requirements as well as the persistent volume provisioner, because we need the persistent volume for PMM to store the data about the monitoring and its state and state of the agents. So it's quite easy, it's standard procedure. You add the Percona repository. It's located here on GitHub as well. It's published regularly when the new Helm charts landed. And you just simply install it, right, with default parameters, and simply uninstall it when you do not need it anymore. But the one thing to make sure is that it's actually removes the manifests and all of the PMM tracks except the persistent volume. So persistent volume you need to delete manually if you have one. There are a set of parameters. This is a standard Helm parameters. Some of them standard Helm parameters, some of them are PMM related. I will show you in a minute how that's organized. they all documented, most of them documented here, right? You can go and read everything. So there is image repo, there is the release tag. Current one is 2.28.0, but that will change, and we will update the Helm charts anyway. Image pool policy, this could be handy if not present. This default value. The PMM images are quite large. They are 1 something gigabyte in size, so you probably would like to preload those images before updating, for example, or before starting the PMM. For start, maybe that's like first start initialization, that is not that important, but for the update, it could take some time for for Kubernetes to download that new image, for example, when you will be updating from 2.28 to 2.29, then you would need, it's recommended probably that you would need to preload it into the Kubernetes cluster, so it will be found quickly and restart will be much shorter. If you wouldn't do that, like restart will take some time, depends on your internet. There should be no issues with interruption because we use, for the most of the metrics, we use the push mode with VM agent, so it actually caches a lot of metrics if it couldn't reach Victoria metrics, and same with agent, so they should cache it and push it when the PMM starts available, but anyway, depends on your internet, right? So reduce the time to load the image. You could use if not present and preload it into the Kubernetes cluster. What else is here? PMM environment. This is the environment variables that are defined in our documentation. The PMM resources, this is done for the if you would need to limit or request resources from the Kubernetes which you want to allocate for PMM. And secret name, secret password. This is secret name, you probably do not need to change. This is more or less standard, but initial password, if you wouldn't set this and it will be default as empty string, it actually will generate one, so it will init PMM with generated password, and it's only during initialization phase, so if you will restart PMM or something, this password will be ignored. But on first initialization, when you first time start PMM, that password will be generated and updated in PMM. So if you would like to have some specific password, you can change it here. And again, this will be only on the first deployment used, and it will be ignored on all other deployments. And I will show you how later. Certificates, if you would like to provide your SSL certificates, you can do it here. What other important parameters are PVC. It's, for example, the storage class, so it's optional. It depends on your default storage class in the Kubernetes cluster you are provisioning, but for some of them you would need to specify where to store it. For example, there could be fast storage, there could be the slow storage, persistent, or maybe there is some cache one that will be deleted. So this is a storage class you need to specify for some clouds, for example. I will show later Linode, and we will specify this. For default usage, you probably, if you don't know what to use, just use default, and it will select default provisioner for the storage. Storage size also depends on the how and what you would be monitoring. So there are some recommendation over here about that. And all other parameters, let's see, and you can, as always, set it with the set string parameters or as the values YAML file. So you can generate this file, for example, how this is a way to generate it, and then just change some of the parameters in YAML file. How this YAML file looks like, let's see the default one. So here we see all of these parameters, and actually that README was generated from this description. So same parameters, image, pull policy, repo, tag, and all of the stuff. You can also specify image pull secrets. Here are the PMM environment. So as I said, you can read about this PMM environment in our doc. So you can specify all of these environments, disable updates, which is specified, and I will explain why. Metric resolutions, or data retention, or PMM debug, enable DBS. So here I am specifying enable. Here I'm specifying the disable updates, and why it's done, because this disables update through the UI, so RPM way, and we do not need this because with the container replacement we do the update more in transaction way. So actually in the Kubernetes as well as in Docker, this method is much better when you update the full container. So your data is persisted on the persistent volume in SRV directory, but everything else like system and PMM is updated in other directories with container replacement. So this is recommended to have here. So always do disable updates. There is no sense to enable them for the Kubernetes or Docker deployment. So it's disabled. Here you can, for example, enable DBS and other parameters. There are also optional parameters like Grafana authentication and authorization for IDP. You can specify those parameters for Grafana, but you would need also specify the secrets for them later. And yeah, here is the secret that I told you before. So the name, it's actually prescribed, but you can select it. And password only for initial first deployment only. And you can get this password like that. If you would need this, you would get this password later if it's generated. So that's YAML file, and you changing the parameters here or on the command line. Yep. What else can we say about the Helm charts? Let's see. So you install it with the set of the parameters or with YAML file. Secret, right? So I will demo it, so we will see. You also could specify the SSL certificates, as I said. So the PMM comes with the self-signed certificates. Here you can specify your own if you have one. This is should be specified inside the YAML file, and you need to provide the content of your certificates and keys. That will be mounted inside the SRV directory to Nginx. So Nginx will then see those files. So this is actually the file name and content. File name and content that will be mapped as the volume to the container. PMM updates, as I said, please, if you do modify the values default, leave this as disabled, because it makes no sense actually to have the UI update methods in the Kubernetes environment. And upgrades, when we release new container, when we release new Helm chart, you can update your PMM deployment, specifying your YAML file with values that you defined maybe you have some customization or not, or you can do that with set parameters as well. Yep, and this is linked to the environment variables. Let's go and see how that Helm charts looks like. Their secret service, everything's the most interesting is stateful set, where we can see everything, but it's quite hard to figure out what is here. Maybe let's go and generate one template and see how the template looks like. So let's do it step by step, right? So let's do it by the book, by the documentation, how we should use it. First, what we need to do is to have Helm repo installed, so we do that. I already have it, so I do not need to do that, but you would need to install it. So there is Helm install, but there is the special parameter for it, dry run, and we will try that first just to see how the manifests, rendered manifests, looks like. Yeah, we cannot do that because we have no Kubernetes cluster which Helm want to connect to. So Kubernetes cluster, I will use Minikube for this example. You can use Sky and all other deployments tools, but let me start the small Minikube cluster 1 node just for this example, and then we will try DBS, and we will start much larger cluster to deploy database as a service as well on this demo. Okay, it will be, I believe it will be quite fast. So we deploying the Kubernetes and Minikube 1 node. Done. Okay, cool. Let's check it out. Yep, it's ready. So we can do the dry run and try this out and see. Okay, cool. So right now with dry run, nothing was installed. It just showing us what will be installed, right? What will be configured in our cluster. So PMM deployment name, as I specified it here. This is a chart name. And service account, we do not use service account currently, but in the future we will consume, we could enable the feature to consume the cluster automatically. So by consume I mean that PMM will detect the cluster, start monitor it, and actually add it to DBS. So, and currently this service account could be turned on or turned off. You can do that here as well. So you just need to specify service account false. Let me, yep, service account create. Currently it's true, but you can specify it false and then it will not be created. I recommend to leave it like that. In the future versions of PMM, that allows us to consume the cluster or like monitor it automatically and also deploy the database service automatically. Next, secrets. That's our secrets, like PMM admin password. You can see it here. It's not the password. This is a base 64 encoded password. It transfers like that into the init container and initialize it. So this is your secret PMM admin password. Config map, here we transfer only disable updates as environment by default. Cluster role, this is for managing your Kubernetes cluster. So if we need to monitor it or to deploy databases, deploy operators, we need special cluster role for that. It also could be disabled, I believe, with service account. Cluster role building, same. And the service, so this is how your PMM would be exposed. Here I use node port, specify the port which will be exposed from container. So this is how you expose your PMM to outside world. So you can use node port, load balancer, and actually we have contribution from the community here, so you can, and soon we will support also ingress. So as soon as we will test it, we will probably land it, and the ingress also will be supported. What else? Stateful set. This is actually the PMM stateful set resource, and as you see, it connects to monitoring service to expose PMM to the cluster and to outside world as the monitoring service. So it could be resolved by different agents and users and clients inside the cluster, inside this cluster as monitoring service, right? So then we have bunch of the labels and to actually you can then select specify selector for the commands to get the PMM, or it's also when we deploy something with PMM that also will be different labels over there for operators in the future as well. So that's actually to help you to recognize the PMM stateful set inside the Kubernetes cluster. So what we have here, containers, PMM, image, pool policy, secrets. Those secrets are empty currently, so if you not specify them, they are actually optional and empty. And this one is that was generated as I showed earlier. But we need these secrets as well. So if you would like to somehow configure the Grafana authentication, they're here for you. But we do not do that. We actually configure the external authentication with platform internally. But if you need this customization, it's here for you. Administration password also passed to the PMM. We opened a couple of ports. 443 is our main one. We do not actually expose currently port 80, but in ingress controller it could be used for your also for your SSL termination if you would like to, and it's also used by the readiness probe here inside PMM, inside the Kubernetes. We do mount the SRV, which is the persistent volume claim that we ask Kubernetes to provision for us. And the init container. This is something will be gone soon, I believe in 2.29, because there is the ticket about that allows us to actually shift this into the entry point instead. But in 2.28 we still need this. What this does is actually detects if your SRV is empty, so that means that the persistent volume is completely empty, right? It's just fresh in provisions, and what it does, it's also set your password, and that's what I mean. It only works on the first init, only this way. And it's what it does is actually currently only copy needed file to init the SRV. In the new version, this will be done differently. Let me find the ticket and show you how. So in the new versions, that will be provisioned in a different way. So we're targeting that for 2.29, and this ticket will allow us to get rid of this init container. So there will be only one container over there. So that entry point will look like that inside of the entry point we have the changes which initialize the SRV if it's empty, and it does it in different way, right? So we don't need to copy everything, we just need to make standard procedure. And it also changes admin password, and it also changes admin password only if it's empty volume. So that's coming in the probably in 2.29 as well. So let's continue. This init container does initialization of the empty volume, will be gone in 2.29, but so far we need it. And that's where we mount the SRV for initialization. And here is the volume claim, which actually asks for volume in the for Kubernetes. And in the end there is notes how to get your IP address, etc. So that was a dry run, so it does nothing. It just show you what we will be doing. So let's, as we have Minikube, right? Do we have Minikube still? Yep. Let's go ahead and deploy this. So currently there are no resources. Okay. So let's go and deploy it. I will be deploying it. Let's deploy it with some parameters. So I would like to deploy it, for example, with the DBAS enabled, just for showcase. Or maybe let's do that. Let's currently just do the standard way to show you what will happen with the standard procedure. So okay, right now it's actually deployed the PMM, and you can see that is initting. And what it does now is actually what I said. It actually tries to download the image. So if we can do that, you can. Okay, scribe pmm0, no resources time, yeah, because I need to specify what I want to show. Yeah, so as you see, what it does, it's pulling the image, and as I said, that's some good storage needed for that, so it will take a little bit of time to download it. Okay, it's already done, so it took less than a minute and it's running. So, okay, it's running. How to figure out where it is? Okay, there is actually the hint how you can figure out where your PMM is running, and it works in Minikube really well because Minikube exposes the containers to my host, so we can actually see. Okay, here's our PMM is running here. Let's go and try to log in there. Oops. Alright, this is a standard. We have our self-sign certificate, so if you have your own, you can provide it. Alright, there is a login screen of PMM. Success. And the only user provision it is admin. The password, the standard password is admin as well, right? When you deploy it yourself. But this will not work. Yes, it's just because we also provisioned the password, so as well for the PMM, as I said before. And to know your password, here is the hint as well. So you can do this. Okay, and you can just decorate. Your admin pass. Okay, here is our password. So it's a little bit secure for you, so you just copy paste it, and here we go, success. And here we are in our PMM running, right? So it's only one node on the cluster. It's currently doesn't know about the Kubernetes. It's just running inside the Kubernetes as the container, but we need to add Kubernetes as monitoring. So success, we have our PMM, we can add services, we can add databases to monitor it inside, outside of Kubernetes. You have your, depends on the method of deploying, but you have your IP and the port, and inside the Kubernetes your PMM could be resolved with the monitoring service DNS address. So, and we need to actually specify it here as well as monitoring service if we want PMM to know that. So PMM doesn't know what kind of address it has, right? So when it configures agents, it needs to know what DNS to use or what IP address to use to resolve, so the agents could resolve the PMM server. You can do that manually, or you can do that with the API, which I will show a little bit later when we'll provision the DBS. So this is the first successful step. What we did is the standard procedure, helm report, install, and we used our hints in nodes to figure out the PMM IP address, port, and the password. Okay, that's conclude our first part, where we do simple deployment of PMM and Kubernetes. And the second part will be about DBS, and we will deploy the database as a service inside the same cluster. Okay, so let's start part 2 of this talk. Meanwhile, what I have done is deleted my cluster, because I need like that. So you just do minikube delete, and that will delete your cluster. I would like to create a little bit bigger cluster to deploy the databases with help of PMM. So I run this command. I used KVM instead of Podman this time, and created a couple of nodes. So there are 4 nodes currently that were deployed. So let me then do the same procedure. Let's deploy the PMM here in the new cluster. This time I will use the values. So let's do that. Let's create new values file. Okay, let's go and edit some of the parameters. What I would like to do is actually to change this password, for example. Yeah, anything like you should set up something more secure, or let PMM generate one. And another thing that what I would like to do is also to enable DBS, because I would use that for cluster deployment. Okay, so that's my custom values file, and you can store that somewhere in your version, the Git or some other control version system for further deployment, for store, and all this stuff. So next what I do is installing the PMM, but this is something interesting here. What I would like to do is to deploy a couple of databases, and if PMM, for example, can run, it's run as a root container, but the databases are run as rootless, and there is no bug in the minikube that needs a little bit more interaction. So we have 4 nodes where I would like to deploy databases, and what I need to do is to do a little bit of trick. There is the bug that I cannot provision the Pixie or PSMDB on the Minikube is a couple of nodes, and there is a workaround for that, so I will just quickly do the workaround to be able to set up PSMDB or Pixie inside the Minikube. What I'm doing is actually deleting the storage provisioner for the standard storage provisioner for Minikube, and what I do is to install in the custom provisioner, for example in this case kubvirt provisional, right? So you can read a lot more details in debug. I'm just executing this procedure. It's like 3 steps, so I just could apply that kube what it does is installs different provisioner inside this cluster to be able to deploy PSMDB and Pixie cluster. Okay, cool. And the last thing, yeah, that's all I need to do. This changes nothing for PMM because PMM could run as root, so it's actually doesn't help PMM itself. It helps the PSMDB and Pixie operators to install correctly. I mean, it helps actually the Kubernetes fixes it. So let's start. Let's install PMM, same procedure, same result. So this time we installed with the custom YAML file. What we did in the YAML file is to change the DBAS enabled and the password, right? So we can actually check if that works. Like let's check the admin pass, so we can do this, and yeah, let's check this password was correctly. Yes, this is stored in the secret now. So let's use our values file, which recommended to get into the Git or other version service, control version service. And now what I want to do is to see if my PMM, yes, PMM is running. Okay, it's just started and it's running. Okay, it's even ready. This time what I want to do is to use a little bit of API. I just get all the instructions needed to get it right. First of all, admin pass, right? So we have admin pass already, but let's do then the same procedure: node IP, node port. This is we adding all of this to the environment variables, right? And here I just created another one altogether. And what I also need is to be able to see URL correctly is I'm creating the key pair of user and password, and user is admin and password comes from admin. Okay, also kubeconfig, right? So this kubeconfig we will be using for the DBAS to register this cluster. Okay, let's see if that worked. This is the API to check the version of PMM. Okay, that's worked. So we passed our encoded user password and we requested the API version, and it returned as indeed that we have to the 28 version server managed and distribution method. So fires Docker, which is like we use same Docker container. So let's change some of the parameters then for PMM. Here, let's do that. 1 second. Okay. Let's change some of the parameter of PMM. here I would like to change the public address monitoring service, which I know that I set up in the my values YAML. This is a DNS for PMM, and I would like to enable DBS, but this will do nothing because we actually have this enabled inside of environment variable. But anyway, let's do that just for sake of demo. So this method, what we did here is to pass to the parameters. The question arises where I find out these parameters, right? And the answer is that we have a nice API documentation under Percona PMM README where you can read and see and actually try a lot of the different APIs. So there are nice examples, as well as you can go and see how this API works. For example, changing admin password, settings. Let me find out. Yeah, get settings, change settings. So we use this change setting API over here. As you can see, settings change, and you can see that's like you can provide some parameters, and it will actually give you URL that you can use later in your application or in your CLI, or as in the script or whatever on the bash. So here you can find out, like, if you basic authentication, other authentication, etc., it will just form you. So here on this documentation you can find out all API and DBS API, everything, all API that PMM supports. Here is a nice documentation with good, even like code snippet if you want, or like shell, whatever language you prefer. So here we are most interested in DBS API. There are good examples over here. For example, here's example how to change this public address that we did. We know we don't have IP. I mean, we have IP, but I use DNS instead, which is a recommended way to use the full DNS. And here's the example of how to enable DBS, and that's what exactly we did here. The same. So I passed the authentication and all of the other parameters to enable the DBS and set the public address. Next thing that I would like to show you is like how to register this cluster, right? So for that we use another API, which is also here is the example of it. There is a small bug. I am submitting the PR to fix this, so this you do not need these two dashes. Here's the here's what I use as the URL to register this DBS cluster. So I pass in the kubeconfig, and I think that shouldn't work. No, this should work, because the important thing here, if you would see the PMM setup, there is a trick. So we taken the kubeconfig view flatten minify, which is in our documentation, but to use it in a script or in a bash, I need to actually replace some of the special characters and replace, I think, the new lines. I think new lines are actually the issue if you would like to pass it through the API. So the kubeconfig actually looks. Oops. So the provision stopped a little bit because I have a couple of pendings over here, just because I didn't create enough cluster for it. To find out what is wrong, you can go and, for example, do the describe of the pod that is not running. Okay. and you would see that, yeah, I haven't not sufficient CPU for that big cluster. But anyway, for the demonstration purpose, I do not need this. I did show you how to add cluster, how to create database service, and also you would see all of the monitoring available over here. So we also have some experimental dashboard for the Kubernetes. We are trying to add a little bit more, so the Kubernetes got monitored. What we are doing is to actually add in more and more Kubernetes metrics and creating dashboards, and actually using the upstream dashboards as well to also provide you insights on the Kubernetes metrics. So yeah, let's finish this part. What we did is to install these values with help of Helm values. Let's maybe try to update this. I will show how update works. So if we will go and try to modify values YAML, once again, you can do that here. For example, let's try to deploy some completely different image, which is not recommended. It's only for development, but let's try development image for the sake of update. When you will be doing update, you do not need to actually modify this. The new Helm charts should have the new version over there, so we do maintain the default values. What will be recommended is actually to use customize. So do not use the values file from the from default, but use the customize to actually create your own values separately. So I will do update with my values file. So what I need is go to documentation and check it out. Yeah, so that's like done really easily, right? So with one command. Again, those values will be changed by us. So when you will do Helm upgrade and do not provide the values, that will be coming from Percona, where we will change the version. So let's see what happens. And you see that again, this is initializing. It's initializing. If you will describe the pod, what it does, it's actually pulling the new image, right? So yeah, you see that it's pulling new image, and then it will restart the container. That's why actually I recommend to maybe pre-pull the images, right? So that's image code instantly. Let's wait for it. I think it's will be around 1 minute. Yeah, you see, okay, that's running. Our PMM already running with the new version. Right now this version is development one. So but yeah, everything is done. Upgrade is done to the new version. What you would need to do is just do the upgrade from the with Percona values, for example, and that will do it. Okay, so what we showed up is the upgrade, setting the parameters for PMM. Let's see if our cluster ready on the Linode, and let's try to see. Yeah, our cluster is ready. Okay, let's delete Minikube, so it will not consume all of the resources. I am downloading the kubeconfig to be able to access the cluster. Okay. So what I'm doing here, so I downloaded the kubeconfig file, and I used that to actually manipulate the remote cluster, right? So okay, I deployed the LKE cluster. I have access to it. Let's deploy the PMM, but this time let's do it a little bit differently. So what we would need to do is actually to provision the volume, and in the Linode, for example, in Linode and other clouds it could be different. I can use this Linode block storage retained, the block storage which actually will persist in the cluster, and I need to specifically delete it. It's really good, I think, for such application as PMM, so when you would like to persist this configuration and metrics. So what I need to do is actually to specify this Linode block storage class. So that's what I do in the value YAML file or by the parameter. So let's do the by parameter, because I actually do not need, maybe by, let's do the values as well. So because I would like to also specify the I would like also specify the password, right? So let's do by values. So here is our file to the 28. I don't need to enable DBAS. I will not demonstrate that, but I will recommend anyway. So password. Some pass, okay, anyway, and storage class, right? Here I need to specify storage class, and I would use this Linode block storage retain. Okay, so let's install PMM there, but what I would need to do is actually to say Helm that the Kubernetes is running on the Linode instead of locally. And to do so, I need to actually also specify the kubeconfig command, right? So kubeconfig parameter, and do that. Okay. All right, so we have the same situation that we see that PMM is in it, right? So let's see what it does. Ascribe pod PMM 0. Alright, let's pull an image. You also could use selector if you don't know the name of the how the pod will be named. You can use selector. Let me show you how. So you just, instead of passing the name, you pass the selector. And so I would like to select application name PMM. So remember those labels that we created. That's where you can use them, for example. So it's still pulling. Oh no, yeah, it's already running. Okay, so let me check if it's runs okay. Yep, it's running. So and we could use same procedure, right, as before, to get the IP address and see if we can reach that. You probably also would need to open the port on the firewall for the Linode, etc. But this is a different topic. What I would like to show is actually is that how the HA works out of the box for Kubernetes, kind of. So if we can see a little bit more information. So currently the PMM runs on this LK node, and we have a couple of nodes. And our storage, as we've seen, is attached to this, right, to the PMM. So let's kill it on this node and see if it will come up on another node with same information. Let's see. So what I will be doing now is to cordon this node that PMM is running. So I would like to push this node out, right? So first of all, I need to make sure nothing deployed there, and second of all, I would like to drain it. So I would like to move all the containers in pod from this node. Okay. I don't mind. Let's ignore everything. I just would like to simulate kind of if node goes down, for example, right? Sorry. All right, and you can see that it's evicting this pod. So actually I simulated kind of what is going on when node goes down. And let's see. Okay, you see that's initting, and if you'll get all nodes, you can see that this node, one node is not ready, right? You see, right now we have 3 nodes. We have another node that is unavailable, and let's see where the PMM now running. So PMM is initting on another node, not on the one that we have evicted. So what I did, I simulated the issue with the node, and let's see what it does. So currently it's pulling, and what also you can notice here is that it assigned to the new pod, and it's also attached the volume that was already provisioned, right? This is the volume that was provisioned by the previous running pod in the another node. So what we essentially did, we killed the PMM in one node, we killed that node actually, and that made PMM moved to another node and started on that node. It's actually mounted or get the same storage, so we didn't lose the state. All right, let's wait for that to start again. That's why it's better to preload the images on all nodes, so then PMM will start immediately on the node. Okay, started PMM init, and it's running. Okay, so that's it. So we actually, what we done is we simulated the node failure. So we get the one node out, and PMM successfully migrated to another node using the same storage. So actually it started with the same state on the another node. That's all. So please try out the new method to install the PMM with Helm charts. Documentation is available here on the GitHub and README file, and you can install PMM close to your databases, and as well as use the DBAs to provision databases same cluster. So actually you have 2-in-1, PMM to monitor your databases and PMM to deploy the new ones. That's all from my side. Thank you for listening. Please try it out and see you around. Bye bye.
Hi, everybody. Welcome to another Haas Talks Foss. I'm the Haas, head of open source strategy here at Percona, Matt Yankovic. And today I am joined by Yuri, the CEO of EdgeDB. Yuri, how are you doing today?
Good, good. How about you?
Not too bad. Not too bad. Now, Yuri, I wanted to chat with you because, EdgeDB has recently come onto the scene. I think it was a couple weeks or a couple months ago where you reached a version 1. Is that correct?
Yeah. It was long under development for several years. We finally launched it. Came out of this weird stealth mode that we've been in for what felt like decades, but it was actually a couple of years. And finally we released 1.0. It hit Hacker News, was number 1 there for 14 hours, maybe 15. Amassed almost 1,000 upvotes. The reception was very positive and warm, unusually, I would say, for a Chan. So it was a great launch.
Awesome to hear. Well, I wanted to start maybe with a little bit about the background here. I know that you have been a longtime contributor to the Python community. And so you started your work really early on, developing a lot of the core features and modules that went into Python. And at some point during that journey, something must have happened to make you interested in redesigning a database and kind of like rethinking the approach. What, maybe walk us through, maybe those early days and what gave you this inspiration? Like how did it hit?
Yeah. Well, the answer is luck.
Luck, okay.
Sure. Almost luck. I think we're sort of lucky to stumble upon this idea and how we actually execute it. But the story is actually quite a bit longer than just luck. So my co-founder and I started a software development consultancy in Toronto in 2008. And we worked with a bunch of different companies. We helped small companies to build software, big companies to build software. We ended up helping General Electric, Cisco, ABB, Microsoft, Pinterest, multiple different companies. And we were using our own stack. Most of those products that we built were using our own stack written in Python programming language. And one of the most notable things of that stack was the data layer, and lots of ideas that we kind of battle tested while developing all this software are now in EdgeDB. This was the foundation for EdgeDB. Because it was all in Python, it was a pretty advanced framework and the foundation. We really tried to push the limits of Python programming language. Almost inevitably, I guess, I became a Python core developer around 2013. It actually all started with scratching my own little itch. So back then, when we actually started Magic Stack, that was the name of our Canadian company, consulting company, still exists, by the way. We decided to use Python as a language of choice. And back then, Python has just started the transition, the famous transition from 2 to 3 that took a decade for Python to actually clear. And when we started, I think Python 3.0 was released, and it was an alpha version of it, alpha 6 or alpha 7. So we started to use Python 3 super early. Basically, nobody else was using it at all. And at some point of time, because again, this is a new major release of Python language with this intent, let's fix bugs, let's fix annoyances of the version 2, even if it's slightly backwards incompatible. Like if you see a thing that has to be fixed, let's fix it. So I noticed this weird behavior that, like, when you're checking if an attribute is present on an object or not, it just consumed all errors. Doesn't actually matter what kind of errors, just silence them all. And that was super hard to debug in our data layer, because our data layer kind of overloaded like all those attribute checks, and you could just magically like check if something is present there, make a request to the database. It was like super early iteration of the data layer. We don't do this anymore in HDB. It's a bad idea, but back then we did. Back then we did, and I just proposed, hey, let's fix it. And that was my first contribution to the Python programming language. The actual patch was like 2 lines long, but still, I think it counts. And later on, I just continued to read the mailing list. I proposed more and more features. And at some point of time, I became a Python core developer. And it just kind of, it was an interesting relationship, basically, because we were evolving our code base, and whatever stuff was kind of missing for us in Python, we were trying to push it in Python. And this is how we ended up adding async await to Python programming language. This is how I ended up helping with maintaining the asynchronous I/O layer in Python, and many other things we did.
And that's a very classic start to the open source space. I think a lot of people get afraid of open source and to start contributing, but they don't realize that many people who end up becoming very influential or core developers start with a 2-line patch. They start with the things that are impacting their own, usage of the software. Exactly. And it's a very easy transition if you're willing to, start to look and start to learn and start to contribute back. I think that's one of the awesome things about the open source space is it's one of the few places where you can go and you see something that just doesn't quite work right, or it doesn't quite seem right, and you have the ability to change it and to help influence that community. So that's why I've always been a huge fan of the open source space and been in it for all these years.
People actually approach me all the time and asking these questions, like, how do I become a Python core developer? And I'm always answering, hey, just start contributing. It's super easy. We now have GitHub. It's not like the contribution process is obscure or anything. If you see some typo in the documentation or some improvement, just contribute, just start. And then after making 20, 30 contributions, people will know you. And this is how you will become a Python core developer. You don't have to be a genius to become one. You don't have to know C, C++, or assembly. You don't need all that. All you need is basically just enthusiasm. That's it. So I really encourage all people to not just contribute to Python, but really to anything. There are so many open to contributions open source projects. It's a great thing.
Oh yeah, definitely. And so during this time, you've just kind of achieved your core developer status. You've been working with, some of these new modules like async IO and, some of these contributions. So, and you've had your own data layer. So how did that transition to EdgeDB? So how did that, how did you go from I'm contributing core Python to new database or, the EdgeDB?
Yeah. I guess Elvis, my co-founder, and I were a little bit tired of running this consultancy agency. It's not an easy business, actually. Sometimes you make something great and it goes nowhere. Sometimes you make something great and it actually flies. You never know. It's always a roller coaster. You have to You have to basically sometimes survive from check to check. And we decided, hey, we should actually become a product company. It would be so much more interesting and engaging for us and open way more possibilities. And we looked critically at what we had. And I mean, we're developers, both of us, software engineers. So this is what we do best. So we looked at our infrastructure and, hey, this data layer looks actually super promising. What if we actually make it a database? Like, it doesn't have to be a library. It would be way more powerful if we just took all the good ideas, mix that already work, mix in some other good ideas that we know will work, and just make it a proper database, make it language agnostic, so that it wouldn't matter if you are coding in C or Ruby or JavaScript or whatever. And just use this high-level data store. This is how HDB kind of was envisioned. I think around 2016, maybe 2015, but we haven't actually started working on HDB per se at that time. We were thinking that, yeah, this must happen, this will happen, but we have to prepare for it. Because the vast majority of code was written in Python, and we knew that Python isn't just going to cut it in its current state back then. This is how I got involved with asynchronous I/O, because we needed concurrency, we needed high throughput. This is how we and why we actually worked on adding async await to Python, because we knew that HDB is going to have this asynchronous core. This is how we discovered Cython, which is this dialect of Python that compiles to C. How we created UV loop, which is like this I/O acceleration library that is now, I think, almost a de facto standard in the Python asynchronous world. So yeah, we kind of gradually evolved our code base and ourselves to this idea that HDB will happen. And around 2018, we slowly started working on it. I would say that we started to spend about roughly like 50% of our time just making sure that the lights are up and business is running, and 50% of our time working on HDB.
Okay. And so the data access layer that you built HDB on, is it really designed more for an interface or an experience that developers are more used to than a classic SQL interface or the standard kind of APIs that are in relational databases nowadays?
Well, nowadays, HDB is basically a relational database. It runs on top of Postgres, but this is an implementation detail. But everything else is kind of different with HDB. So first of all, we are saying that relational model is great, and relational databases are just ridiculously good, especially Postgres. It's absolutely an incredible database, and essentially it's a platform that you can build foundation. There are multiple companies that do this, by the way. For example, Yugabyte and Timescale, they all kind of take Postgres and build either on the side or underneath it. This is a common pattern. So with HDB, we're just replacing the entire front end. We replace how the schema is defined. We replace we replace the query language. We define how you do migrations and multiple other things, including the binary protocol, the client API. So basically, the entire front end of the database is changed with HDB. And to actually be somewhat successful at this change and to actually make it possible to actually compete with traditional relational database and with SQL, it had to have a proper foundation. And I think we have it now. We call it graph relational. Essentially, it's an extension to relational model. And we use this foundation to define everything, our data model, to define our query language. So to answer your question, basically, HDB is a new database that wants to be a complete replacement for traditional relational databases. It's built on Postgres. It's fundamentally relational. It's best for the same use cases that Postgres is best at. It just has far greater DX. It will make you way more productive.
Yeah, and I think this is an interesting approach, and this is what really piqued my interest around Edge. So you mentioned Postgres as the platform, and I have seen a lot of companies use Postgres at its core But it's interesting because there's two different types of problems that people are trying to solve. So you look at like a Yugabyte or a Cockroach DB, for instance, and they are trying to leave the client interface and the APIs there, so you can use what is already built for Postgres, and then they replace the backend to make it cloud native or whatever.
Yeah.
So they have replaced the backend, which is cool. But what I hear from developers is they want a faster, easier experience. They're pushed to move faster. So a lot of them don't like SQL. I'm a database guy, so I've grown up in the database space forever. So, but I always say this at conferences that I go to. It's like people think databases are uncool when you talk to developers. They're like, yeah, we need a database, but we don't like writing in SQL. Yeah, we hate defining this and that, and it's just not natural to us. It doesn't follow the flow. And you see that certain databases like MongoDB become popular because it bucked the trend of a lot of the relational client libraries, which is interesting because EdgeDB's approach, as opposed to taking a client library and building the backend, you've taken the backend and said, the backend is pretty darn good, but what really could be better and could reach more developers? It's the front end. It's the interaction. It's how developers think about code. It's how developers think about the data that's in their applications, and that's a very different approach. But I think it has a lot of potential just because of where developers are nowadays and how they're evolving and the pressures that are being put on them. They want to think about data like they think about code.
Yeah, absolutely. And I mean, this is a vast topic, and I will share a couple of thoughts. I might end up walking in circles if I do. Just interrupt me. Before I start, though, yes, we are based on Postgres, and yes, we're building on top of Postgres. Traditionally, companies usually build on a site like timescale or kind of change some of the base layers, let's say, like IO layer, for example. We are doing a different job right now. But nothing actually precludes us from tinkering with Postgres at a deeper level, potentially into the future. We as a company have a very ambitious goal, essentially. It's basically to redefine relational databases. If we just wanted to write everything from scratch, let's say, just not use Postgres, just write our own storage engine, that would be possible. It would just take us 2 more decades to do that. It's excruciatingly painful to create a proper, working, solid, robust database engine. So we chose Postgres. We could focus our efforts on a new front end and on better scalability. For example, we could try to do something similar to what AWS is doing with Aurora, or we could do something similar to Yugabyte or PlanetScale. But then our focus would be just kind of diluted. We would not be working on front end as much, and we would probably not be able to work on the back end as much. So instead, we decided that, hey, using Postgres is ultimately an implementation detail. It's a great one. We should focus on one thing, do it right. And when it's time for us, and when our future customers grow to some certain scale, when they would need a better engine, basically, like a better internal engine than just vanilla Postgres, basically, then we'll take a look at what we should do. And by the way, Postgres is not also standing still. It evolves rapidly. It's evolving rapidly. They are adding hooks and things, and now there are new database companies that try to use that functionality to change table engines, to change how the data is stored, and multiple different advancements are happening. So basically, with HDB, we're going to continue focusing on DX and implementing some of the currently missing pieces of the puzzle. And then when it's time, sometime into the future, we'll start working on the backend infrastructure and try to address the scalability issue. But ultimately, the vision of HDB, and I'm glad that you actually talked a little bit about SQL and developers don't quite like it. That's actually true. Developers hate databases, and I think this, you said it right, I think it's the reason why MongoDB became so popular, because suddenly it was like a breath of fresh air. We don't need migrations. This is like the most painful thing about relational databases. We don't need SQL, just use simple APIs. And a lot of developers decided, yeah, let's try it. 10 years later, they discovered maybe that's not the best approach. And now we see this renaissance of relational databases. If you open Hacker News or Reddit, you will see that like almost every day somebody is blogging about Postgres and how cool it is. Unfortunately, databases, relational databases, are still pretty much where they were in 2010 and where they were in 2000s and 90s and 80s. SQL is still SQL, tables are still tables, and without actually addressing some of these fundamentals, I don't think that it's possible to meaningfully improve the DX of a relational database. So we have to actually start digging deep. There are multiple different companies that create ORMs or create some middleware or create, UIs for the database, but they all kind of try to just solve one piece of this big puzzle. And with HDB, we are trying to do something way more ambitious, which is basically, hey, how would a relational database look if it was designed today? Today, when not in the 70s, when we had mainframes and when the software architecture was, it's not even correct to say vastly different. It was just alien to what we have now. And what would it look like? What would we do differently? And HDB is an answer to that. And if you want, I can go into the detail, like what exactly have we changed.
Yeah, no, I mean, I think you're dead on. I think, SQL's evolution, it is slow right now, and it has been for the last 20 years. It's stable. That's great. And there are people who have those skill sets, but the current generation of developers are thinking and moving differently. And they have so many different options that they are exploring and starting to invest in. I think that it only makes sense that databases eventually have to catch up. And, there are, like you said, ORMs out there. There are different techniques and things that people use to try and mask this. But part of the challenge with those is they are outside of the database itself, right? And so
exactly
they're bolt-ons. And
yep.
Problem with the ORMs is ORM interprets what you want and tries to interpret what the database wants, and the likelihood of getting that 100% right all the time is pretty low. And it generally has scalability issues, other things, because it's not designed to necessarily work 100% the same way. And I think that really limits it.
Don't even let me get started on ORMs. So
hey, I used to do a lot of database, consulting, right? So that was my thing. So I know the pain.
It was almost a revelation. Like when we were preparing for the launch of 1.0, we had this live launch event on YouTube, and we wanted to make it interesting. So we had like almost a mini conference. By the way, it's all on YouTube. Anyone who is listening now and curious about this, you guys can search on YouTube, and you will find it. Just type HDB. Anyways, I mean, Elvis and I, my co-founder and I, had a conversation a few days before the event, and we were just talking about ORMs and so-called object relational impedance mismatch, which is actually the root cause of ORMs. It's basically that tables are not how programming languages represent data necessarily and how developers work with it. And we just said this out loud that, hey, object relational impedance mismatch sounds like, I don't know, string theory or some deep physical property of this universe, but it's not. It's very far from it. It's a self-inflicted pain. Mm-hmm. And the only reason why we have it is because our relational data model is slightly different from our programming languages. And because of this deep incompatibility, we struggle. And this incompatibility actually manifests itself in the design of SQL as a programming language, which is query language, which is actually great. And it's a shame that it's a little bit more complicated than it should be. And so people don't actually use its full potential. And yeah, basically, this is the root of the problem. But it's important to realize that this problem is self-made. And that with the choice of right data model inside the database, you just don't need this. You don't need this extra layer of abstraction. You just can talk the database native tongue without the need of this weird, awkward, slow translator. And I think it's weird. ORMs have been with us for decades, and they shape the perception of how you should work with a database. Basically, there are like two camps now. I use pure SQL, or I try to use ORMs, and when you use ORMs, you also have to use SQL. Unfortunately, that's inevitable. But it's been so entrenched in our minds that sometimes it's hard for me to pitch HDB to people. Like I'm saying that, hey, we redefine the data layer so that the data model, so that it's compatible, it's high level, it has object types, and they basically say, hey, so it's basically an ORM in a database. Well, sure, I'm not going to fight your opinion. Yeah, you can say that, but somehow it's incredibly hard for people to just even wrap around their heads around this concept that, hey, database can just natively have a higher level data structure within it, and you don't have to call it a norm, because ORM is something else.
Yeah, well, I mean, I think ORMs themselves, when you add the S, it is a 4-letter word, and I think it's negative because it is that translation layer. But I think that what you're doing is something that many other databases have done or tried to do, which is create a new way to access natively, which is more of an API-driven approach. And that's a little different, right? And so you see people's approach to this, MySQL, for instance, they have, their X protocol, which, gives you an API that you can access. And you can now access JSON through most relational databases, but you still are bound by a lot of the SQL issues and shenanigans. And I know that as, you get more divergent code bases and more options in terms of databases, even the SQL standards start to slip a little between the databases, so they don't always work. And so there's a lot of complexity out there. And you mentioned your graph relational focus. Now I'm curious, when when I hear graph, and this is a specific question, that there are two different things. There's graph databases, and then there's GraphQL, which is more of the API for databases.
Yes.
Which one are you talking about specifically? But I'm curious.
None of those.
None of those. Okay, there you go. See? So explain it.
Yeah. There is a story here. Basically, the edge word in HDB, it doesn't mean edge computing necessarily yet. What it meant when we coined the name was just an edge in a graph. But we are not a graph database. So when we are talking about graph, we are talking about the graph of your relations within your relational schema. We think of graphs when we work with objects in JavaScript. Basically, yes, like, I don't know, you have object A and object B. You don't necessarily have to use any graph data structure or anything. Just having two objects in memory linking each other, well, conceptually, it's a graph. So this is the why we call it graph relational, because it's an extension to relational model that basically slightly elevates it to a more high level model. But I think it's time for me to decipher what graph relational means, what this extension to relational model is, because it's actually very simple. So it actually consists of just a few minor adjustments of the classical relational model. So adjustment number one: every piece of data must have an ID, globally unique, data-independent ID. Because in classical relational database, you can have a table without any ID whatsoever, or you can combine a couple of columns and say, this is my ID, or you can just have an auto-increment integer, and that would be your ID, or no ID at all. In HDB, every object type or table has a required property called ID, which is UUID. Second extension is that we are introducing concept of links. So essentially, we say that a piece of data can explicitly link other piece of data. So essentially, you don't need to have joins. You don't need to have foreign keys. This slightly more higher level abstraction of a link, you can also call it reference if you want, just replaces this need. So now your one type can directly reference the other type. And the third extension, which is a little bit more kind of esoteric, it's that we treat everything as a set. So our query language, HQL, is a set-based query language, and our data is stored in sets. And links can be single or they can be multiple. If it's a multiple link, it refers to a set of objects. And this actually, like, you don't think about this much when you write HQL or when you work with the database, but it manifests itself in pretty interesting ways. For example, there is no concept of null in HQL in our query language. And null is a painful thing in SQL. It can do so many interesting things to you. Like, for example, it can collapse your data and just nullify it all, and then you have an empty report, or you would be missing a column in your report. It would be null from time to time. Maybe, I don't know, you calculated mean value in your report, and suddenly you had one line in your report when you just had one value. I think Postgres will happily return you null in this case. So it's really a weird thing, because in SQL it can mean an error, an absence of data, multiple different things. In HQL, we don't have this all. If there is an error, you have an exception. It's better to crash a query than give you incorrect results. And if you have missing data, it's an empty set. And the entire language is carefully engineered, architected, and balanced around this notion. So almost like there are no surprises, basically. Anyways, this is the entire graph relational thing. It's the kind of the mathematical foundation of HDB, and just by looking at it, you can imagine and basically deduce what HDB is doing. You can think of HDB as basically, I don't know, LLVM. It's like an optimizing compiler. We compile high-level data schema to low-level table layout. If you actually look under the hood, you just connect to the underlying Postgres instance that we manage, you will see a fairly normal table layout, pretty classical one. Like no surprises there. We don't do anything crazy there. We just map our high-level data model to low-level table structure. We compile our query language, HQL, to SQL. We do some interesting tricks, and we use some interesting and unique traits of SQL implementation in Postgres specifically, but ultimately it's SQL. You can read it. So yeah, it's a basically compiler for high-level thing to low-level thing. And it all builds on that. This is kind of the kernel of HDB, the graph relational model, and this idea that we can compile high-level things to low-level things. And this way we can unlock more power.
Yeah, it's
almost, not new. It's not new in our industry, right? No people write bytecode by hand. You use compilers for this.
Well,
so why would you be writing SQL by hand? This is my question.
Yeah, it's almost like a Babelfish, right? I mean, I'm hesitant to use that because that was coined by AWS, or it's a trend. It's the thing that's going to speak developer speak and turn it into something that, you know, a hardcore database nerd would understand and do it for you in an efficient way.
Yeah, but sometimes it's not even possible for a hardcore database nerd to do what we do, because there is a limit there is an obvious time limit how that database,
of course.
How much time the database nerd can spend writing just one query. I can give you an example. So when we try to explain HQL, I think actually GraphQL helped us a lot, because GraphQL showed people that, hey, expressing this idea that you can just fetch a hierarchy of objects in one query and getting this data easily is awesome. Mm-hmm. And this made it much easier for us to basically pitch HQL. So this problem, hey, give me a list of users, and for every user, give me a list of his friends, and for every friend, give me their email and I don't know, first name and address. It sounds like an easy thing. And it is an easy thing conceptually, but actually implementing it in SQL is surprisingly hard.
Yeah.
And actually implementing it in ORM is surprisingly hard. In SQL, you can actually do some tricks, especially, I mean, if you use Postgres and you use things like ArrayAg, but it's going to be somewhat painful for you to compose this query. If you rely on ORM, your ORM can actually make thousands of queries for this simple thing. You might never know what it's actually doing, but it might be doing some horrible things. under this for this simple conceptual task that every developer has to, one way or another, deal with nowadays. And this is why developers hate databases, by the way, because even simple things like this that sound conceptually easy are hard to do. So with HDB and SQL, this query is trivial. It's like SQL 101. You will be able to write this query like literally 1 minute after being introduced to SQL. It's a trivial thing. It will be compiled to a SQL query, one SQL query which would be executed atomically. It will be executed very fast in Postgres because Postgres Query Planner is crazy good. And but the SQL query that you would get for fetching a hierarchy of, let's say, 3 levels deep, it will look complicated. It would look something like you wouldn't want to write by hand. And this is the whole point. It's literally 5 lines of SQL that would be compiled to, 30 lines of SQL that is not so obvious, yet super fast to execute, like 2 milliseconds to execute for Postgres. And boom, you have it. This is where you start to kind of see this leverage, that this idea kind of manifests itself as a very powerful idea, that you can do so much more if you add this kind of step of compiling high-level things to low-level things within the database, not outside of it.
Okay, so because Postgres is the back end, can EdgeDB sit on top of other implementations of Postgres, or is it only what you download directly from EdgeDB? Like, so for instance, if you're running on AWS and you want to run AWS's RDS Postgres, can you put EdgeDB on top of it?
Yeah, we support it right now.
Cool.
We used to have an extension to Postgres, which would prevent you from deploying to AWS. We used to actually patch Postgres, but some of those patches were upstreamed. We contributed them back to the community. So basically now HDB runs on vanilla Postgres. You don't need to have anything special in it at all. We have guides on how you would deploy HDB to DigitalOcean or AWS or Google Cloud or Azure. It's honestly up to you. We have a Docker container that can deploy along an existing Postgres or just ship it with a Postgres inside. Entirely up to you. But the future of HDB is going to be slightly different. We don't actually want people to deploy to AWS this much because it's painful. I mean, there are some people who will always want it, and we're not going to make their life harder if they want to do it. But the majority of people just struggle because there are so much things that you have to configure properly. How you configure your, TLS certificates, how you map one port to another, how you configure HDB to actually see that Postgres, how do you do backups? Like, all of this is quite complicated. So the dream that we have at HDB is to basically just automate this all, give you a nice HDB cloud option, where it would literally take you just one command or one button click to just get your database running in production. And we are incredibly close to it. We're going to launch first technical preview of our cloud in just about a month. For 4 to 6 weeks.
Is that cloud then using, like, you can deploy in AWS, Google, DigitalOcean, and you get to choose kind of the base cloud platform, and then you manage everything out? Okay, cool.
At the very first, it's going to be just AWS. At least during this technical demo period. But the goal is multi-cloud. You will just choose the region, you will choose the cloud provider, and we will just run the database for you and automate absolutely everything.
Okay, one of the big things, and this is something that I've seen as a trend in the database space, and I was actually talking about this at the Postgres Silicon Valley conference a couple weeks ago, was the developer side of Postgres. It's the demands there are increasing, and this is going to really drive a lot of Postgres innovation over the next 20 years or 10 years or 5 years or next year, all of those being inclusive. And I think that one of the interesting things is cloud providers and cloud instances typically are designed to solve the operational issues, but they leave all of the development the work between building an application, designing it, making sure that, the schema is okay and everything, to you. And it sounds like Edge kind of fits that gap. where you provide some of those tools to make more efficient decisions from a database perspective, a bit better design, enforce some of those rules that you should have in the first place to ensure your data consistency and scalability, as well as provide those operational things.
Yeah, absolutely. This is the whole point again at kind of reinventing the entire front end of the database, because we're not just reinvented the data model, let's say, or designed our own query language. It goes deeper. So at HDB, for example, schema migrations. That's a first-class feature of the database. The database is actually the best place where the migrations should happen, and the database knows how to do them correctly, perfectly. It knows what migrations are potentially dangerous or not. It makes sense to do them in the database. It's still an open question for me why I think HDB is the first database that relational database that just has this first-class notion of schema, first of all. A schema that is editable and that is kind of viewable by you, and that is controllable by the database and tracked by the database, and the first class migrations workflow, so you don't have to use a norm or anything else. But then again, it goes deeper than this, because we also implement our own binary protocol, and we also implement our client APIs. And I'll just give you an example with client APIs. So why do we actually want to implement our client APIs? Well, because we are, I think, entering different age now. It's a serverless age. It's a distributed age. When you run multiple, when you can run multiple different database nodes in potentially multiple different regions. Some of them can be read-only. Some of them can be writable. Things can happen, like network partition errors can happen, and database client APIs, all of them, are just not there. Let's say a network partition error happens, well, your application will display 500 error. And guarding against that, it's just you will have to just copy paste a lot of boilerplate code to just handle this specific case. Or let's say you want to intelligently route your read-only queries to read-only replicas. There is no infrastructure for this whatsoever. It has to be hard-coded. So at HDB, we actually know absolutely everything about every query. We know if it's read-only or not. We know if it touches any volatile functions or not. We know absolutely everything about everything. And that allows us to make some decisions. For example, our client libraries will soon be able to route queries automatically, read-only queries to read-only replicas. Our client libraries right now can repeat the query if it's safe to repeat, if a network error happens. Like if it's a read-only query and a connection was just like the socket disconnected, the I/O, no I/O. We know that, hey, I can actually reconnect and transparently repeat this query and get the data because it's safe, because this data is read-only. Whereas if I was mutating something and the network error happened, I have no idea, maybe that query actually committed. So now I can show you 500 error. But most of the time, we read data, right? So by just automating this tiny aspect of your client API, hey, can you just survive network errors? We're already improving quality of service. Or let's say you start the transaction and then you get a serialization error. This is going to be more and more common theme. Most libraries just give up. Hey, you have transaction serialization error. But the whole point of this error is so that you can just go and retry this transaction. So in our APIs, you don't have to do anything special. We will just retry it for you automatically. We basically engineer the APIs to just be capable of that. Some of our APIs look slightly weird in Python, for example, because in Python there is no concept of multi-line lambda function or closure. So in Python API, you will basically say for tx in con.tx with tx. So you kind of do like these two blocks, but that allows us to repeat this transaction if it fails. So a lot of thought went into designing those client libraries to make sure that all the best practices are incorporated in them so that developers don't have to think about them at all. And this kind of attention to detail, I think, makes HDB a unique company right now, because so many companies try to figure out deployment and scalability and global availability. Those are all good companies, and this is a big problem But ultimately, I feel great about it. I think the humanity is safe. We have already plenty of options for globally available databases. But this API, the UI, the DX part of what it means to interface with a relational database, it's still missing. It's still neglected, and a lot of the pain that should be solved by the database entirely is basically continues to rest on developers' shoulders. And what do? They either just don't like it and suffer through, or they just don't care and they ignore those problems. Or maybe they're not even aware of them because you don't have network partition errors on your laptop when you're developing applications. You will have them in production for sure. You might not even know that you have them. So yeah, this is what makes HDB quite unique.
Okay. Well, Yuri, I like to end these discussions with some rapid fire questions.
Sure.
These are random questions that have nothing to do with technology in some cases. Sometimes they do. Sometimes it's just kind of a mix. So I like to do this. I started this recently, and it's worked out pretty well, just to get to know the person who we're talking to a little bit more, and get people interested when they meet you to maybe say, "Hey, that's pretty cool."
Should be fun. And
should be
if
fun.
anything goes wrong, we'll edit it out for sure.
No, it'll go into the bloopers.
Oh my god!
Yeah.
Right,
So Yuri, so let's say we meet up at a conference and someone wants to, buy you a drink and talk to you about HDB. What is your drink of choice? What would they buy you? Could be coffee, could be drink, could be soda.
It depends. At conferences, I usually go for beer.
Okay.
But maybe if I'm about to pitch HDB, I would choose a glass of red wine.
Oh, okay. Okay. Connoisseur of wine or a beer if it's just hanging out. All right.
Yeah.
All right. Fair enough. What is the last book you read?
It was Andy Weir novel. What was the name? It was about this. I cannot actually retell the story, I guess, without spoiling it too much. But basically, the first chapter started that the sun got dimmer and dimmer and dimmer, and the humanity was faced with this dilemma that the world is about to end.
Yeah, so that was not. I mean, obviously Andy Weir is famous for The Martian.
Yeah, it's his latest one.
Let's see, what was Hail Mary, or is it Artemis?
Yes, Hail Mary. Yeah.
Okay.
I love the
book.
I love the book. It's a great book.
Okay.
Super easy read.
Super easy read. Well, okay. Yeah. So are you then a fan of science fiction books in general?
Yeah. I'm a big fan. Yeah. Unfortunately, I don't have as much time as I used to have for science fiction
who
books
does?
Before. And this is why, by the way, I loved Hail Mary so much, because sometimes in the evening it's just like I need to unplug my brain and I just cannot read anything. And somehow Hail Mary was just perfect, absolutely perfect. So easy and so engaging.
So normally I ask people their favorite programming language, but I'm just guessing it's Python for you.
Probably Python, but I actually also rediscovered JavaScript for myself. I was always like an advanced JavaScript developer, did a lot of interesting things with it. But when I was writing a client library for HDB a couple of years ago, or 3 years ago, I chose TypeScript. And I love the experience of TypeScript a lot. It actually was quite a fun thing for me to do, and I never would imagine that it's possible to fix some of the language words with just this optional typing. And it makes total sense, and it's amazing. And yeah, TypeScript, I think, is a great example of engineering done right.
No, okay, cool. And so let's look at this technology landscape. I know where you are currently company-wise, what you're working on, but are there some technologies out there that you're looking at going, wow, that's really cool or interesting?
WebAssembly is one of them for sure. Yeah.
Okay.
I think it will unlock a lot of interesting use cases in the future.
Okay. And if there is one thing in the technology space that really worries you, or that you're trying to figure out how we solve as a community, what would that be?
The thing that worries me slightly, but then again, maybe I'm just being ignorant and maybe I haven't done my research yet. is Web3 thing. For now, I don't get it from the technical standpoint. From my limited knowledge of the crypto
So
architecture,
decentralization and
I'm not against decentralization. I'm just not sure that Web3 in the way how it's currently pitched is going to be a thing. Maybe it will change and evolve into something different, but in its current form, I'm just not sure from the technical standpoint if it's feasible or not. So it's one of those things that I'm sometimes paying attention to and reading articles, but I still haven't made up my mind.
Okay. Well, Yuri, I wanted to thank you for coming on today, chatting with us, telling us a little bit about EdgeDB, where you're going, how you got here. I do appreciate your time today.
Yeah, thank you so much. And to all listeners, please check out EdgeDB. Go to edgedb.com and we have great documentation, amazing tutorials. It's going to be an interesting ride for you. I guarantee that. Absolutely. So check it out, please.
Yeah. Yeah, and we'll go ahead and drop the links in the description as well. So
Awesome.
if you are interested in either trying it out or maybe even contributing some code, providing bugs, some feedback, I'm sure Yuri and the team there would be most grateful for that.
We would be delighted.
Yeah. And so for those listening, go ahead and subscribe to the channel here. We would love to hear your feedback. If you'd like Yuri back on, tell us. If you want someone else in this space, you want to hear about a different project, let me know. I'm happy to have on people. You know me, I like to talk. So we do appreciate all of you hanging out, and we will see you next time.
Bye-bye.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, everyone. My name is Sergey, and I'm a group product manager at Percona. I'm excited to have you here today at Percona Live, and I'm going to talk about cross-cloud migrations with databases on Kubernetes. So what you're going to learn today from this talk is how we at Percona designed our Kubernetes operators so they can help you with migrating your databases from one cloud to another or from on-prem to the cloud using Kubernetes operators. This should be quite interesting and awesome. This is a quick agenda. So we're briefly going to look at how databases on Kubernetes look like, what is operators, how they work. Then we're going to jump into the multi-cloud and hybrid cloud stories. We're going to look into how Kubernetes helps there, how we designed our operators, what kind of techniques we're using. There will be brief examples from our operators, YAML manifests on how you can configure it. And then we're going to quickly go through a demo. I have a demo for migrating your MongoDB from EC2 or DigitalOcean machine to Kubernetes with our operator, obviously. So let's begin. Kubernetes and operators. So when we talk about databases on Kubernetes, what you need to know is that there are two components. First one is Kubernetes primitives. It is everything that you need to create on Kubernetes to run your application or to run your database. It is pods, stateful sets, storage, PVCs, service accounts, everything, right? And you need to define them in manifest. You need to carefully understand how to configure them all and so on. So you need to know Kubernetes pretty well to configure it all. And the second piece is configuration. For databases, it means that if you want to run a cluster, you need to ensure that all the nodes are configured properly so that they talk to each other. For example, in MongoDB world, you need to ensure that you have the same certificates so that the MongoDB nodes can talk to each other within the same replica set. You need to ensure that you specified correct IP addresses, ports, and many, many, many more, right? And doing all this manually is not an easy task. It would require you to learn all these things, understand how they work, and also maintain all of this, right? And this is where operators are going to help you a lot. And what operators do, they allow you to obfuscate or masquerade all these Kubernetes primitives and database configuration. Instead of it, you talk directly to the Kubernetes API and you specify what kind of database you want to get, what kind of network do you want to use, how you want to expose your database, in other words, how you want to configure your backups, how you want to configure your database in a way like configuration file for the database, and so on. And you just specify this big YAML manifest, you ship it to Kubernetes, and operator does all the heavy lifting. It provisions the Kubernetes primitives, it configures the database, and what you get as a result, you get a service. You get an IP address or the endpoint that you or your application or your developers can connect to and utilize this database at full. And it is production grade, and it is backed up by expertise of the people who develop these operators, in case of Percona, by our expertise. And what I really love about operators, that it's not only a way to deploy your databases, but it's also a way to manage them. You can take the backup, for example, and upload it to S3 compatible storage. You can create a scheduled backup so that operator is going to automatically upload the backups and apply the necessary retention policy to it. You can scale your database through the operator. You don't need to go into the container and reconfigure it in any way. You can upgrade your operator and your database through the operator, which is awesome. So there's lots of maintenance tasks that you execute manually or with some custom scripts that operator can execute for you now. So instead of figuring out how to do that, you can talk to Kubernetes API and let operator do everything. Okay. And if we talk about operators basics, for the ones who don't know how it works, there are two components. First one is the pod with operator container inside of it that has some logic, some code, and the custom resource definition. Custom resource definition is just a way to expand Kubernetes API. So Kubernetes API has various resources that you can manage and create, like a pod. But once you create a custom resource definition, then you can expand this API and create MongoDB cluster, for example, through the Kubernetes API. And that's what custom resource definition does. And then what is happening, the user or the application or some CI/CD pipeline creates a custom resource, which is a YAML manifest defining how your database should look like. And operator sees that new custom resource created or custom resource was modified and executes the code logic that it has inside of it. And as a result, you get a database service or any other application. If we talk about Percona operators, there are 3 production-grade operators that we have for MySQL, for MongoDB, and Postgres. They are 100% open source, so we don't have any open core licenses or anything like that. All the features and our operators are really feature-rich. They are available 100% for free. So and they're Apache licensed. So you can download them from GitHub and utilize the way you want. And the last point here, number 4, is supported by Percona. This means that you can have a contract with Percona, and we're going to support your databases running in Kubernetes with our operators. And obviously, if you don't have a contract, you can always submit a ticket for us or contact us through the forum, and someone from the community or our developers and engineers are going to help you with questions that you have for our operators. There is a link down there where you can read more about Percona operators. Go ahead. I encourage you to try them out. Now, jumping to today's topic about multi and hybrid cloud. Let's go. So first of all, we need to understand what is the problem. And there are a few. Maybe there are more, and I guess there are more, but what I see that these 3 are the top ones. So first one is vendor cloud lock-in. Lots of businesses, they do not want to be locked in within a single cloud or within a single vendor. And what they want to do is they want to have the infrastructure and the applications ready to be easily moved or restored on any other environment. And this is the big problem actually nowadays. And it's, again, it is not only about your infra, it's also about your application readiness, because in your application, you can use some custom services that one cloud provides, but once you want to move your application to another cloud, you will need to do the full re-architecture or recode everything, which is daunting and would cost you a lot. Another problem, obviously, is migrations. So if you are running in one cloud, your company's strategy changes and you need to move to another cloud for various reasons, whether it's cost or it's just the strategy. You need to be ready for that. And the last but not least, disaster recovery is usually when you run again in one cloud or on-prem, you need to be sure that you can quickly recover your application and your business operations in another data center or in another cloud. It is all applicable for not only for applications, but obviously for databases. So these are, I believe, the three biggest risks and problems that multi-cloud helps you to address. And if we talk about databases, it's pretty simple. For disaster recovery, it can be backup and restore, but it takes a lot of time. So usually for disaster recovery, you would also use something like a replication. So you have a data center, which you can call primary, or it can be primary cloud. And you have another data center, which you call replica, and you have a replication between your databases. We're going to look deeper into details how this replication is going to work, but this is just a high-level overview for multi-cloud for databases, how it usually works. And what would happen if we add Kubernetes into this picture of a multi-cloud? Because what we know about Kubernetes is that it provides you with no vendor lock-in by design, because Kubernetes API is more or less standard. Yes, we would be completely honest. There are some Kubernetes flavors that come with various building blocks, but in 90% or 95% cases, Kubernetes APIs are usually the same. There are definitely some limitations, like you can compare EKS running on Amazon and GKE running in Google Cloud, and you would see that there are different webhooks, for example, or the way provisions the storage or the networking might be a bit different. But in 95% of the cases, it's the same API across on-prem, clouds, and various clouds. And as long as it is the same API, the same control plane, it's definitely easy to migrate. So if you have a pod in Kubernetes cluster A, then you can recreate the same pod in Kubernetes cluster B. It's just a matter of migrating the storage, the networking, but all the Kubernetes primitives are the same. And what also Kubernetes comes with is huge community and application libraries. What I mean by libraries is operators. So you can have lots of applications running it, and you can replace lots of components in your clouds by Kubernetes applications. For example, Amazon RDS can be replaced by Percona operators for MySQL or for Postgres. And that would already solve your vendor lock-in problem and migration problem. Good, so now we understand how Kubernetes helps us. Let's see how Percona operators can help you with databases running in multi-cloud. So as I mentioned before, there are three operators that we have for MySQL, Postgres, and MongoDB. We're going to go through them one by one and briefly overview how we address a multi-cloud problem for each of them. If we talk about MySQL, so our MySQL operator deploys Percona XtraDB cluster, which provides you with synchronous replication. Percona XtraDB or cluster, or PXE, is a clustering solution for MySQL. It uses Percona Server for MySQL and Galera. So it provides you synchronous replication. And the way we approach it, so you have two Kubernetes clusters, one in Cloud A, another one in Cloud B. In each Kubernetes cluster, you install the operator and you deploy Percona XtraDB cluster in each of them. And what you do is you just set up an asynchronous replication between these two clusters. That's it. So now in Cloud B, you have the same data that you have in Cloud A, but your application still writes here in Cloud A. So in case of disaster, you can easily switch your application to Cloud B. Or in case that you want to migrate or perform any maintenance, you can do this failover gracefully. So it is again an asynchronous replication between two PXE clusters, and it is all controlled by the operators. So you need to configure two operators and you need to configure two clusters. What it is important to know about it, that this functionality is available only for MySQL for version 8 or version older than 8.22, because in 8.22 out of failover for asynchronous replication was introduced, and we rely on this functionality. What it means is that in case of one of the nodes, either here, either on main side or on replica side fails, then the replication will automatically restart. You don't need to reconfigure anything, and we leverage this functionality in our operators. And another important aspect here is that either main side or replica side can be a non-Kubernetes environment. Yes, it's not going to be controlled by the operator, but it's important to understand that if you want to migrate from on-prem to Kubernetes, for example, you can do it with the operator running in Kubernetes environment and with manually configuring MongoDB somewhere or MySQL somewhere on-prem. So it's a good for migrations. And I just want to iterate that it's not valid only for MySQL, but for MongoDB and Postgres operators. So we'll see it in the next slides. And this is a quick example of how main and replica side are going to be configured with our YAML manifest for our operators. So in here, you see that we create replication channel. We name it like this. We say that it is source, which means that's the main side. And on the replica side, we define the sources list. So we assume that this is some IP address on the main side, and we define the port, we define the weight, and that's it. So you configure two operators, you configure two clusters like that, and you get your replication running. And in case of disaster, you can easily switch. Let's talk about MongoDB. What we do for MongoDB is on a high level, we expand the replica set. So again, we have Cloud A, we have Cloud B, we have two Kubernetes clusters, we have two operators running in each of the Kubernetes clusters. And in Cloud A, which is the main one, we have replica set, which is regularly deployed. And in Cloud B, what we do is our operator runs all these nodes as unmanaged. And what happens then, we expand the replica set. So now it's a big replica set once we expanded it. So again, we're leveraging the standard MongoDB functionality. I'm going to show MongoDB in the demo, so it would be easier to understand, but I think it should be easy enough. So on the main side, we expose all the nodes. On the replica side, we expose all the nodes. And what we do here on the main side, we expand the replica set with the nodes that we have on the replica side. So we just define all the host votes priority here. And now instead of 3 nodes in this replica set, we have 6, because we add all the nodes that we have on the replica side, or 5, whatever you have. Now, if we talk about Postgres, for Postgres, it might surprise you a bit, but we decided not to use the replication method, and we decided to use PG backrest. The reason is simple, because it is easier and it already has this functionality. For Postgres operator, we have PG backrest as the tool that we use for backups and restores. And when you set it up, you upload full or incremental backups to some external bucket, to S3 or GCS or Azure Blob Storage, whatever. And you also put the write-ahead logs. And what we do actually is, again, we have 2 clusters here, one in Amsterdam, another one in London, for example. And for the one which is on main side, we just configure PG backrest so that it uploads the full backups and write-ahead logs to this external bucket. Probably you want to keep this external bucket either in London or in some other, in the third site, but it's not the topic here. And what we do on disaster recovery side, we configure PG backrest to pull all this backups and write-ahead logs and restore them continuously on our cluster running in disaster recovery side. So it's just backup here, restore here, and it's going continuously non-stop. So it's like similar to replication. And as long as we already have this functionality in PG backrest, we don't want to implement the replication mechanism in our operator. It's easier for us to utilize PG backrest. And that's it. So, and again, if we look into the example of the YAML manifests, on the main side, we say standby false, and on the replica side, we say standby true. And that's basically the only difference, because the backup configuration is similar. Primary and replicas configuration, it doesn't matter what you have. But this is the only flag that you need to be aware about. You set it to true, and you start syncing the data from this bucket to your cluster. And now you have two clusters which are in sync, and you can easily fail over in case of disaster. So what we looked at MySQL, where we use asynchronous replication. We looked at MongoDB, where we just expand the replica set, and we looked into Postgres operator, where we use PG backrest. Again, all these items are available in our operators already, and it's 100% open source. And we have customers who use it in prod a lot, so we encourage you to try it out. Before we go to the demo, I also want to look into this interesting example. This is multi-cluster services, or MCS. If you ever worked with this, it's pretty interesting. It's I would say it's like the next Federation V2 or V3 already. What it does, for now, it only expands, allows you to expand the Kubernetes network across multiple Kubernetes clusters. How it works is on one cluster, so you connect two clusters into the single, what is called MCS domain. There is an MCS operator running in each of the clusters. And then these MCS operators, they allow you to create specific objects in Kubernetes, which are called service imports and service exports. And once you create a service export object on each of the clusters, you have service import object created. But what you need to understand is that from every cluster in MCS domain, you can access any other resource through this SVC cluster set .local domain. So instead of figuring out the public IP address of the cluster, you just connect your application to this service import object, and it can be here, it can be here, it doesn't matter. And the beauty of it, that now you have two Kubernetes clusters, and you see them as a single networking domain. So it removes a lot of complexity for you. You don't need to think about load balancers. You don't need to think about any other IP addresses, cluster IP, or whatever it is. You just use this SVC cluster set .local. And I encourage you to try it out. It can be also used for multi-cloud. It just masquerades a lot of networking complexity for you. And for example, our MongoDB operator automates the creation of service imports and service exports objects. So once you enable MCS, our operator detects this and creates all these services. For other operators, there is no need for that, but we'll think if we need to automate it as well. Anyhow, I encourage you to try it out. It's pretty interesting technology. Okay, let's go to the demo. As long as I'm not very confident, I'm going to have it pre-recorded. So I'm just going to comment what's happening here. What I have is I have one MongoDB node, which is running somewhere. I guess it's DigitalOcean IP address. And I have a replica set with one node only. It's just for demonstration purposes. And my goal is to migrate this MongoDB node to Kubernetes so that I have all the data synchronized. And this is our Percona server MongoDB or Percona operator for MongoDB YAML manifest. This is where you define the configuration for your MongoDB cluster. You can see size here. You can see that I disabled sharding. You can see the version of MongoDB that I want to run, and many, many, many more, right? And you see, I set this unmanaged to true. This is the Kubernetes side, so I want my nodes to be unmanaged. I don't want operator to create a replica set. I want them to be fully unmanaged. I expose them through the load balancer in Kubernetes. Again, don't do this in production probably, rather to use something like MCS or some VPN network if you have it. Okay, I'll already have these nodes deployed so that we don't wait for it. Let's see. I have load balancers already there. So I have these 3 public IP addresses. Each node has its own IP address. For MongoDB, it's extremely important that once you expand the replica set, that all the nodes can talk to each other, so they can form, they need to form a full mesh. If they don't form a full mesh, you're not going to be able to have a fully functioning replica set. So all the nodes must talk to each other. And I have already created some dummy domain name, which points to this nodes. I'm using my domain, I guess. Yeah, so I have Kates-1 mongo as prawn.in, and there are Kates-2 and so on and so on. So what I'm going to do now, I'm going to look at the status again. You see I have one node in the replica set. I'm going to add more nodes. I'm going to add node number 1. I'm going to add node number 2. So I'm adding Kubernetes nodes to my replica set, which is running somewhere on DigitalOcean, not in Kubernetes. So now I have all these nodes here added. You see they have secondary status, secondary, and primary is still my DigitalOcean node, not Kubernetes one. I think Kubernetes is somewhere in Google Cloud, but it doesn't matter much. Kubernetes can be anywhere. Okay, what I need to do now is I just need to switch primary from DigitalOcean to Kubernetes. The way to do it is through MongoDB. I'm just going to change the priority one of the nodes. You cannot do it through the operator yet, because we want to manage the infrastructure, but we don't want to go deep into the MongoDB internals. What I'm setting now is for one of the nodes in Kubernetes cluster, I'm setting high priority, and I'm ensuring that it can vote, and that's it. Reconfig, yeah. Okay, the configuration is done. What should happen now is that one of the nodes in Kubernetes cluster, it should become primary. And now my application, I need to switch my application to write to this node. If you do this kind of failover, you need to reconfigure the application probably, but it's fine. Okay, yeah, you see my Kubernetes node, Kates-1, is now primary. So that's it. The migration from on-prem to Kubernetes is done. Now I can kill this secondary node, which is running in DigitalOcean. I have the data synchronized, and that's it. I'm officially multi-cloud, right? Obviously, I don't have a lot of data there, so it's not production environment. But what I need to do now is I'm going to tell the operator to take the lead. Now, unmanaged is set to false, which means that operator is going to manage my new environment now, so that I can kill this DigitalOcean node, and now I have a MongoDB cluster running in operator and managed by the operator. Am I going to show something else here? Let's see. Yeah, I'm just showing that primary status is here, and this node is still in secondary. I can delete it now. So that's it. That's the demo. I showed you how to migrate MongoDB from somewhere, let's say on-prem or other cloud, to Kubernetes with Percona operator. These slides will be shared later, and there is a link actually to this demo, which is recorded, so you will be able to see it again. This is the last slide for today. There are some useful links that would help you to understand this multi-cloud story with Percona operators. This is for MySQL operator. This is the documentation for this cross-site replication. We also have a blog post about migrating your MySQL database to Kubernetes with this feature. The same goes for Mongo, the doc, the blog for migration, and also there is a blog post about Kubernetes MCS. Please give it a read, it's pretty good. And for Postgres, again, the document on how to deploy a standby cluster for disaster recovery, but it can be also used for migration. And this is the blog post about migrating stuff and setting it up. So good. That's it for today. Really appreciate your time. I hope you enjoyed my talk, and I wish you a good day. Thank you, everyone.
So just for those who are listening who might not be familiar with Mongo, can you give a 10-second, what is a jumbo chunk?
So basically, when you start inserting a lot of data and MongoDB doesn't really figure out that you inserted a lot of data, and it all goes into the same chunk, then it will grow past the size of the chunk, which is 64 megabytes by default. And that will cause the balancer to not move that chunk anymore. So it's just a lot of data that is there, and MongoDB doesn't touch it anymore. So if you want to move that around to a different shard, for example, then it's problematic because it's a big piece of data, right? So you want to avoid that most of the time.
Hi, everybody. Welcome to another episode of the Hoss Talks Foss. I'm here with Ivan Gromwald today from Percona, and we're here to talk about Ivan and his career, what he's done at Percona,
the MongoDB ecosystem, and all the fun things in the database space. Ivan, how are you doing today?
I'm doing great. Thank you for having me.
So, Ivan, you've been in the database space for quite some time now, right? Maybe tell everybody a little bit about you.
Sure. So I started my career actually as a security administrator. So in the IT security department. That's unusual. Like most people start like as a DBA or sysadmin, but yeah, I did a couple of years as a security administrator first. Eventually, the company I was working for at the time had a position in the IT department, so I moved over, and that's where I started to become familiar with, servers, networking, cabling stuff. We did pretty much everything related to hardware and provisioning and so on. We even had a really cool project where we had to start a data center in a new building from scratch and move everything we had over to this new building, which was quite complex, but also it was a really good project to be involved in. So yeah, after a couple of years working as a sysadmin, I moved again because there was a position in the database team that we had outsourced at the time, and the company was they wanted to have an internal person with knowledge, not just outsource everything. So I moved over to the Oracle DBA position. This is back in 2008 or so, a long time ago. And that was my first contact with databases, with the Oracle DB. So yeah, I spent a couple of years there, and then eventually I moved over to another company that was an e-commerce company. And they were having a mixed environment where there was some Oracle DB, but there were also other open source databases, and that was my first contact with the open source ecosystem. They were having MySQL at the time. There was a bit of MongoDB. It was earlier versions of MongoDB, like 2.0 or 2.2.
Oh, wow, that's really old. Yeah,
that was ancient.
Early days. Early days.
Yeah, MongoDB had the old mmap storage engine back in the day, which was memory mapped files. So it's a completely different world from the MongoDB we know nowadays. So I spent a couple of years in that company and then eventually moved over to consulting. So after that, I never left the open source ecosystem anymore. So it's been over 10 years that I've been doing just open source DBs. I forgot everything about Oracle now. So yeah, my focus has been that for the last 10 years or so.
So you got involved in the MongoDB ecosystem pretty early on, when things were still being flushed out in terms of the architecture. It was still an early project. It was still considered a quote unquote startup. And now we know it isn't. It's a very established company with a very established technology footprint. What have you seen grow over that time period, right? So how has that ecosystem evolved from your perspective? What have you seen growth-wise, maybe some concerns, maybe some things that have changed or transformed over that time period that you're, was interesting to see?
Right. Yeah, I guess from the early days, things were quite hard. The mmap search engine was completely different from what we have today with WireTiger. I think that was the biggest transition probably. mmap v1 was memory map files. There was a global lock that was like everyone's nightmare at the time. You wanted to avoid this global lock as much as you could, but there's not much you could do about it. So it limited a lot the concurrency of the database at the time. I think it's quite similar to what happened with MySQL when at the beginning there was the MyISAM storage engine, and then when InnoDB came over, it was like a revolution. Well, the same happened for MongoDB when they brought WireTiger over. That introduced a whole new world of scalability and new things for the database. Also, Percona started to become involved, so We got now the Percona Backup for MongoDB, for example, which makes it really easy to have a backup in a sharded environment. Where back in the day we were dealing with stopping all of the nodes at a specific point in time, and then like trying to figure out how to take a snapshot of everything at the same time. So we have more tools from the community also that helps make our life easier nowadays.
Yeah, and as that ecosystem has grown, you've seen that the use cases for MongoDB have expanded. I've often talked about this in the past, where I've started to see databases start off with a very specific niche use case almost, right? So it's very specific, it's good at this thing. And then as time goes on, either the community wants more use cases or companies want more market share. So they start to evolve. And you mentioned WireTiger, for instance. It's taking what was a NoSQL, non-transactional system, and it's starting to move into the transactional space, starting to provide things that were never built into the architecture. So as that ecosystem has evolved, more and more people have started to do things in Mongo. I'm curious, what do you see people do in the Mongo space that you're like, why are you using MongoDB for this particular use case? Do you see that, like, where you're like, you scratch your head and go, this is not really a good fit for the database?
Yeah, well, I think MongoDB is trying to be a general purpose database nowadays. So it's trying to do what other databases are doing, like, for example, transactions. The support for transactions is more or less recent. I think they were introduced around MongoDB 4.0, right? So I guess if you really need transactions, perhaps it's a sign that you should be thinking maybe about a traditional relational database. I mean, you can do it with MongoDB, but it doesn't necessarily mean you should be doing it, right? Maybe it's one of the things that can tell you that maybe you should take a look at other type of technology. I don't know.
I mean, I think, like, for me, the most popular use cases that I always see Mongo like out there in, a lot of SaaS companies, a lot of web, companies with websites that have that, native JSON data format that are looking for something that's easy. They're looking for that scalability and that ease of use of having the flexibility in the document design. And so I see that quite often in gaming companies. If you're building mobile apps, things like that, it's Mongo is still a very popular use case, but I haven't really seen it evolve into more of the corporate systems as much. It's more on the other web app, the application side, things that are more consumer facing. I don't know. Have you experienced that as well?
Yeah, to be honest, I haven't seen it for things like, for example, financial data. I think that is more suitable for a traditional RDBMS, like MySQL, for example. That kind of thing, yeah, it's probably not very popular, or at least I haven't seen that a lot.
Yeah, and I think that, from a Mongo perspective, it has done a good job of kind of encompassing all these different use cases. And like I mentioned, I think the document storage really lends itself well to the web app and the mobile app type design. It lends itself well to a certain sort of workload. But I think one of the interesting things that I always scratch my head at is a lot of people adopt Mongo specifically because of that flexibility. And so they say, oh, I don't need a schema. I don't need to think about validation of my schema or things like that. But you really do, don't you? Because as data grows, ensuring that you have some semblance of good data structures and validation, it becomes more important.
Yeah, definitely. And this is why also they introduced this schema validation tool eventually into MongoDB. I think because if not, you run the risk of having mixed data that you don't really know what it is. Like, it can get out of control really quickly. It's one strength that you can really add new fields, to documents without any schema changes that are sometimes painful in other databases, but at the same time that can become really complex and get out of control quickly if you're not careful about maintaining a structure at the very least.
Yeah, and I think that leads to a lot of performance issues. And the problem with most databases is you start off, you have a simple application, you have something that's designed to work from the ground up. You test it, you have a few thousand users, everything's fine. But then all of a sudden you become successful and you get 100,000 users or 1,000,000 users, and then everything changes. And a lot of times with the schema validation or the design of the documents themselves, the indexing strategy, the sharding strategy, it all kind of is fine until you reach a certain inflection point, and then you realize, wow, you really screwed up early on and you should have fixed these issues. And they become bigger issues, right? It's something that early on, it doesn't seem to impact you, but later on it can really add up, especially at scale.
Yeah, definitely. I agree.
Yeah, and I think we see that with some of the newer features in Mongo, for instance, like the shard rebalancing things that they've introduced recently, go directly to try and fix some of those issues early on. And I think that's one of the key topics. It's always a popular topic at different conferences is how to choose the right shard key, or how to rebalance your shards. What are the tips and tricks to make that faster? Because when you're talking about multiple terabytes of data, a shard rebalance is very painful.
Yeah.
Very, very, very painful.
Yeah, we run into that with our customers a lot, and there's really no easy solution, because nowadays the balancer is not super configurable. So what we end up doing sometimes is doing some manual operations to try and do the balancer's job sometimes. But yeah, I think that is one of the areas where development still needs to do a couple of things to make balancing a bit more configurable, to reduce the impact. And another thing is the jumbo chunks. Okay, that is really a pain, and for that we also run into that with our customers very frequently. I have a few scripts actually that I developed and published in the Percona blog to help with the problems with the jumbo chunks. And also earlier versions of MongoDB were sometimes having jumbo chunks that become undetected. So you really don't know that you have a jumbo chunk. So in one of these blog articles that I was talking about, there is some instructions for dealing with that. And the same is the other way around. When you delete data and then your chunks become empty, there's no way to actually compact them together. So to reduce the number of chunks when you no longer need them. So I had to deal with that problem also and learned about it as well.
So just for those who are listening who might not be familiar with Mongo, can you give a 10-second, what is a jumbo chunk?
So basically when you start inserting a lot of data and MongoDB doesn't really figure out that you inserted a lot of data and it all goes into the same chunk, then it will grow past the size of the chunk, which is 64 megabytes by default. And that will cause the balancer to not move that chunk anymore. So it's just a lot of data that is there, and MongoDB doesn't touch it anymore. So if you want to move that around to a different shard, for example, then it's problematic because it's a big piece of data, right? So you want to avoid that most of the time.
So it gets pinned in one area and stuck there until you manually do something to fix it.
Right.
So as we talk about data sizes as they grow, as things evolve, I'm curious, what are the most common issues that you have to deal with customers coming and asking for help or working on systems? Are there common problems that you see over and over again in the Mongo ecosystem that you really wish people would just stop doing?
I don't think there's really a mistake of people doing it. It's just the way that the database is working nowadays. Like scaling up or down the number of shards is costly. Like there's a lot of data to be moved around, whether you want to scale up or scale down. And again, this is the balancer's job to do all this chunk management. And I think it needs a bit more work because of the configuration of the balancer, for example, or the algorithms that it uses. sometimes it can have an impact. So normally you define your balancer window to be during the night when there's the least database activity. However, it can still have a significant impact. So I think there's room for improvement in that area.
Okay. And I think one of the issues that I see crop up is, modern environments now, everybody wants their own databases. Everyone wants their own setup, which means that, you've got systems that are very large, but you also have lots of little systems as well. So you'll have a mixed environment. You might have one database, one setup that has terabytes of data, but then you might have 1,000 small databases for individual applications, individual microservices, individual functions, and that presents quite a challenge. Are you seeing that escalation in the Mongo space as well?
Yeah, definitely. This happens in all the databases, and this is why automation is a key thing to get right from the get-go. Because otherwise you end up with different MongoDB systems that are configured differently or don't follow the same standards. So it's very difficult to manage when you grow. Even though MongoDB has sharding from built in, when you start growing the number of shards, it becomes really complex, and you start easily going into the hundreds of servers without even noticing. So it's critical to have good automation and also monitoring, right? And that's where PMM kind of comes to help you, right?
Yeah, and I mean that automation comes in many different forms, and I think that there's always different tools out there. You have a talk coming up on Ansible and Terraform at Percona Live, but we also see the growth of Kubernetes as a deployment mechanism to deploy MongoDB. We have an operator ourselves to help with facilitate that. But those aren't the only deployment tools and infrastructure and orchestration tools that are out there. Do you have a preference? Is there something that you prefer? I mean, I know you're talking about Terraform and Ansible because you did it, but have you gotten into the Kubernetes side? Are there other tools that you see that are really popular out there?
Well, I had a chance to try the operator a couple of times, and I've seen really good results with it. I see there is a lot of community interest in that, but still haven't been personally involved with many production deployments. I know that other people at Percona have that kind of experience. I personally haven't had it yet. But according also to the forums in Percona, there is a lot of interest. Most of the forum talk that has been going on in the last couple of weeks has been related to the operator. So definitely that's the way to go, I think.
Okay. And so let me ask you this, and this will be our final thought for the day. As you look out at the open source ecosystem, you look at the new technology landscape, what are some of the technologies and the things you're seeing out there that get you excited, that you're really looking at like, wow, this is something interesting. I either want to learn it or I want to use it more, or maybe you use it already, but it's something that you would like to recommend to other folks as something to take a look at?
Well, I mean, I'm going to repeat myself here, but again, the Kubernetes is all around the place now. Like everybody's talking about it or implementing something in Kubernetes. So I think it's the key concept to embrace for the next couple of years. Even if we're not sysadmins, like we're supposed to be DBAs or consultants, right, working with databases, but Kubernetes is going to be a topic, whether we like it or not. So it's better to start working with it. The sooner, the better.
Yeah, absolutely. Well, Ivan, thanks for stopping by, sharing a little bit about your background in the MongoDB ecosystem, some of the things going on. I would encourage our listeners, if you haven't already, check out Percona Live. Ivan's going to be speaking there. He has 2 talks. I will be there doing podcasts, live streams, and all kinds of other fun things. So we would encourage you to come out to Austin if you're in the area. You can take a look at the conference. It is scheduled right now for Monday the 16th, Tuesday the 17th, and Wednesday the 18th of May. It is going to be awesome. There's going to be Mongo content, MySQL content, MariaDB, Postgres. There's all kinds of Kubernetes. We've talked about Kubernetes. There's some security topics, something for everyone in the data space. So we would encourage you to come out. But Ivan, thanks for swinging by. And we really look forward to hearing your talks at Percona Live.
Thank you. And thank you for having me.
No problem.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hi everyone, welcome to my presentation, Database Reliability Engineering for MySQL. My name is Matthias Krauls. I am presenting to you from Belgium. Currently I'm a principal consultant in Python's OSDB group. I have a bachelor's degree in computer science. I've been using and administrating Linux machines for as long as I can remember, over 25 years now. And I've been involved with MySQL for over 10 years. As a principal consultant, I'm mostly focused on MySQL at Python, but we also support other technologies. This is something about the company and all the problems that we see in our customer base, and then these are the places where we can help our customers. As you can see, we do consulting, managed services, we do migrations, and also cloud solutions, as well as on-premise, as basically anything that the customer needs. When we're talking about database reliability engineering, I see four main focus areas. The first one is availability, and preferably high availability, and we'll talk about the difference between both of them. Service discovery, knowing where your services are. Observability, knowing what's going on within your databases, and then when disaster strikes, how can you recover, and can you get back up to running situation. So yeah, let's get started with the first one. So high availability. So when you look at this very average car, you see that this car has 4 wheels. Well, you can only see 3, but I can guarantee you that there's a 4th one. So what this car needs to operate, to work, is 4 wheels. If you lose 1 wheel, the car is not working, so it's not available. So having 4 wheels for your car is not high availability. When we're talking about high availability, we can keep the same comparison and talk about the wheels of a car. And in this case, we're talking about the bolts holding the wheels, the wheel in place on the car. And in this picture, there's 5 of those bolts. And if you lose one, it doesn't mean that your car won't drive anymore. It doesn't mean that your car is not available anymore. So those 5 different bolts, they are ensuring high availability. So if you lose one, you can still operate. There's no need to, no immediate need to stop everything and to fix it. Like if you lose a wheel, then you can't ride anymore. But if you lose a bolt, then you can still ride. You can still drive. You might want to go see a mechanic to figure out why you lose a bolt. Maybe it wasn't tightened enough on the last maintenance, and so then it's a human error. Or maybe there's something structural wrong on the car that the bolts are loosening, and so you need to see a mechanic to figure out why and to try and fix it. But this is the difference between availability and high availability. If we now go back to the database, because we're here to talk about MySQL, when do we consider MySQL available? So in most cases, you will need just one server to write transactions, which is your primary, or used to be called the master. And then you need at least one server to read transactions from. In the worst case, you can use both the same server for both operations. But in many cases, when you have a very large scale website or application, you're gonna need more than one read server. And this is what we need to have availability for MySQL. So high availability in that case means that we make sure that we can keep the database available even when a server fails. So this is your general topology. You have one primary, one writer server on top, taking all the writes, and then you have a bunch of read servers on the bottom where you can do read scale out for your applications. And in this case, the master is a single point of failure. So if your writer server fails, no more writes can happen to the database, and your application will be down, or at least have some kind of degradation, because you won't be able to write. Imagine a service like Twitter. You can probably still read all the existing tweets, but you cannot send a new one. So that would be a problem for many people. So in order to prevent this single server to be a single point of failure, we will introduce a topology management tool to handle these kinds of failures. And so the tool that we will introduce is called Orchestrator. And Orchestrator is a high availability and replication management tool. You can use it for all kinds of purposes in your MySQL environment. If you connect it, you can use it for discovery. And so what this will do is, if you give Orchestrator the coordinates of one of the servers, it will start using the regular DBA commands like show slave host, show process list, show slave status to try and connect to the other servers in the topology. And that way it will discover the entire topology by just feeding it one single server. One requirement is it needs to be able to connect. If it can't connect, it can't run the commands I'm listing here. So you need your automation when you spin up a new server to create the Orchestrator topology user, so Orchestrator can connect to the database to figure out where in the topology it fits. And then the very nice and very useful feature that Orchestrator has is the visualization, the web UI. So when it discovers all those servers, it will present them to you in a very nicely formed web UI, which you see an example from here. This is from the Orchestrator manual. And as you can see, there's different colors in the servers. You have the orange, green, blue, red ones. So these designate different data centers. So this topology is an anonymized topology. There's no specifics about these servers. Like you can see that they're 5.7, but not the minor version. You cannot see their host name. You can see their replication delay, but nothing more than that. So that's also a feature of Orchestrator. If you want to create screenshots of your topology, you can anonymize them to make sure that you don't expose too much information about your environment. And then the third and probably most useful feature of Orchestrator is the ability to refactor. So what we understand by refactoring the topology is making changes, like pointing a replica to a new master, or promote a new server to become the new master or the new primary, or do things like start stop a replica, do some maintenance on the binary logs. All of those things are things that Orchestrator knows about and that it can help you with. So there's a command line tool that you can use. There's an API where you can script a lot of things, or there's the web UI where you can do drag and drop. So you can basically drag one server to another location in the topology, and Orchestrator should be able to figure out how to reconfigure replication so it can handle the change. There's some some prerequisites for that, obviously. But in general, Orchestrator can do that to almost any topology running MySQL. And then all of these things, they are extremely nice, but if your master goes down or your primary goes down in the middle of the night, and you get paged to go log into Orchestrator and do the drag and drop, or to run a script to do the promotion, you're not going to be happy. What Orchestrator can also do is it can automate the recovery. So you don't have to get up, so it can automatically figure out, hey, the master is down, I need to create a new master and recover the topology. To do this, first of all, the detection of the failure is a requirement. And so if you think your typical monitoring tools like Nagios, Zynga, those kind of tools, they will send probes. So they probe the master or the primary, and what do they do when they detect the failure? So imagine your monitoring tool tries to connect to your primary, and it cannot. What do? Do you take immediate action? It might be like there's a network failure between the monitoring tool and the database. Will you retry maybe to see if there's actually a problem, or if the monitoring was having like a temporary failure, or and if you retry, how many times will you retry? So all of those things are items you have to think about when setting up automation. The advantage that Orchestrator has, it's connected to every server in the topology, and it can gather information from all of those instances. So if it detects a problem on the primary, it will check with all the replicas of that primary, like, hey, can you still see that primary? If you can see the primary, then there's no problem. Then I have a detection issue, and I won't take any action. But if all the other replicas are saying, hey, we can't talk to our primary, we don't get any binary log events anymore, then Orchestrator can be fairly certain that there's a problem, an actual problem with the primary, and it can use that knowledge to make decisions and to do a promotion on the first detection. And this is what Orchestrator calls the holistic approach to monitoring, instead of an individual server by server approach. And so back to our example, so we had the situation on the left where our writer went down, and so what Orchestrator will do is it will take one of those readers, make it a new writer, reattach all the remaining readers to the new writer server, and take the old writer out of the cluster. So it will put that server aside. Something went wrong with that server. It might be as simple as like a network glitch, and at that point you can say, okay, this server is healthy and we can put it back in topology, but it needs a human to look at it, to investigate what happened. And to prevent for all reader servers from being promoted to master, and every time the master being put aside, there is an anti-flapping mechanism built in Orchestrator. By default, it will not make a new promotion within the hour. So what you might want to do is send some kind of alert that someone needs to check on what happened to that old writer. Make sure that it gets back into the pool of available servers, and figure out and acknowledge that everything is fine on the new topology. So to do this, if you run a single Orchestrator node, obviously your Orchestrator will be the single point of failure. So since Orchestrator 3.x, there's an implementation of the Raft consensus protocol in Orchestrator, which allows orchestrator to be set up in an HA way. Well, you could set up orchestrator as an HA system before, but then you needed like HA on the database side, and orchestrator cannot manage its own backend database because it needs that to be functional. So if that database would have gone down, then orchestrator would be down. So what we used to do before orchestrator Raft was like set up a synchronous replication backend, like, or virtually synchronous, like Galera or these days InnoDB cluster, which is still available. But if you use the Raft protocol, then you can you can drop that replication component from the database on the database layer, and you can even use SQLite if you have a small scale implementation. You can use SQLite as the orchestrator backend. So you don't have to manage any other database server technology for orchestrator itself. So Raft will do leader election and distribution of the data as mentioned, and in order to have an HA setup you need at least 3 nodes. If you have 1 node, you never have high availability. If 1 node goes down, there's not another one to take over, so never HA. If you have only 2, then they can start, if they lose connectivity to each other, they can start fighting which one is the active part. And so you need a majority vote, so you need 50% plus 1, so you need at least 3 nodes for a high availability. So if two nodes lose connectivity, that one node will say, hey, I'm a minority, so I will be I will decommission myself for now until I can rejoin the cluster, while the other part can still be fully functional and operational. So this is what it looks like then. Before, with the synchronous replication backend, you had the replication of the data on the database layer, and there was no communication between the nodes. If every node was connected to the clusters, which also had some implications. While in the Raft version, you see that the communication is happening between the application nodes. There's one leader node taking making the calls on the servers, and the other 2 are passive. They're monitoring, but they're following the lead of the leader node, and there's no more replication between the different backend databases. So that brings us to the next section, and that concludes the part of high availability. So brings us to service discovery. So service discovery is the ability for application to know where the writer server is, where the reader server are, where the reader servers are, and there's several options for this. I've known installations where if the master changed, there was a deploy required to deploy the new configuration file, and then the application would start writing to the new server. This works, but this is not the most convenient way, because it needs someone to trigger that deploy or read it automatically, or the other option is to have a DNS change. In that case, you rely on an external system. DNS is something that's probably not managed by the database team. And there's a famous Belgian blog that says everything's a freaking DNS problem. So I'm not a big fan of DNS. It's useful, but to rely on, I'm not a big fan. Floating or virtual IPs, they're also an option. In many cases, this will mean that your virtual IP is only available in a single data center, or you have to route your IP addresses to multiple data centers and then make sure that it's bound to the right one. This is a problem probably when you have a data center issue and you need to fail over to a different data center. Then virtual IPs are much more troublesome to migrate. Or the final option, and this is what we will be discussing further, is to use a proxy server, something to sit in the middle between the database and the application. And in this case, we'll be talking about ProxySQL. ProxySQL is a layer 7 application proxy. It's layer 7 because it's not just network throughput or not network relaying like something like HA proxy. What ProxySQL does, it accepts the client connection, and then based on its configuration, it will send traffic to MySQL servers wherever it's configured to send it to. So it's intelligent. It can be used for multiple databases, multiple clusters. It's built on the MySQL protocol, so it can understand the traffic that passes through it, and it can do things like splitting reads from writes. It also understands the database topology underneath, so it knows whether instances are up or down, whether replication is fine, whether there's replication delay. It can even do something like GTID consistent reach, so it can make sure that the connection is only sent to a replica whenever the GTID it's requiring to be there is actually applied there. So it's very knowledgeable about the MySQL topology, and it can do very intelligent routing, and basically it protects the application from the complexity of the database technology. So from application from the application side, what it sees one server where it can connect to, and it sends a query and it gets a result. But underneath that one server, there might be tens or hundreds of MySQL servers serving the traffic. So it's a very convenient way to protect the application from that kind of complexity. To start, some terminology. So in ProxySQL, we speak about host groups, which is basically a group of backend servers where queries will be sent to. Very important to know is if you send queries to a specific host group, the query will be sent to only one server within the same group. It will not be sent to all the servers in the group, just to one. This is to load balance between multiple servers. Query rules are like the core functionality for ProxySQL. That this is what defines where a certain query or query type or a query for a certain user needs to be sent to. So that is where you define how the traffic will flow through your proxy. And then MySQL users and servers, these are items that the proxy needs to know where to send traffic to. So the server configuration is actually the list of MySQL servers that is available in a certain host group. And then the users are also required because the proxy will connect, the application will connect into the proxy, so it needs to authenticate to the proxy. So the proxy needs to know the users and the passwords in order to validate those credentials. And then from there on, depending on the user or the type of query or the query text or the address or the port you're connecting to, traffic is sent to the right backend server by evaluating the query rules. And then the basic design for ProxySQL is very simple. You have your application servers connected to your proxy, and then the proxy connects to the database on the backend. And then I see people think like, hey Matthias, but now you have a single point of failure on your proxy. Correct. But This green proxy SQL block can be multiple proxy servers, and you can basically load balance them using like a general stateless HTTP load balancer or something similar, or TCP load balancer in this case mostly, because the proxy can be clustered to share configuration. So you have multiple proxies that will distribute the configuration among each other, and then the application can basically choose which of the proxies they use, because they will all have the same configuration, and they will send the read and the write traffic to the same backend groups. Another approach is this, where you put the proxy SQL instance on the application server. So basically your application connects to localhost, and the proxy then again sends traffic to the right backend group. This works very fine also with the clustering of the proxy. In many cases, what is being done, if you have a lot of proxies, a lot of application servers, is you make a combination of both of them. You basically put the proxy SQL servers as some kind of satellite servers on the application side, and you put in the middle, you put a layer of proxy servers which do your core routing. So basically your satellite servers, they will send traffic to your core servers, and your core servers will send traffic to your database backends. That's usually the most most high available way to set up proxy SQL without the need of any additional load balancing applications or something. So that really helps. That brings us to the observability part of this presentation. So what is observability? So the first thing in observability is you need to know if your systems currently are having an issue. So you want to be alerted for problems. Like if your disk is running out of space, you want to know about this. There's many ways to alert. You can use a pager system, you can use an IM system or email. Depending on how reliable your IM or your email is, you can be satisfied with the performance of that, or you can have some kind of pager system like Opsgenie or PagerDuty or something like that to send you alerts on your phone, so you know when there's an issue. And then the other part of observability is when you need to troubleshoot performance, or when you're diagnosing an issue. You want to have some kind of graphical interface where you can have dashboards with metrics, so you can compare against the past situation, like, hey, my database is suddenly going slow. What's different in the workload against last week? So last week everything was fine, and now everything is slow. So how can we see what's ongoing? So that's what observability is about. And what we typically use when our customers don't have a good solution for this is Percona's monitoring and management tool called PMM. This is a all-in-one solution for observability, and it's mostly focused for databases. It's free and open source. It consists out of, I have a slide for that, out of several open source components. And it's an out-of-the-box solution for monitoring MySQL, Postgres, Mongo, Proxy SQL, Linux servers. It will be able to be your full monitoring and alerting stack when you configure it well. The caveat that I always tell to our customers is that this is a single server, so it's a single point of failure. There's currently no real good solution to make PMM high available. But in general, it's not mission critical for your application. So it's not if your observability stack is down, that your applications will be down. It's gonna be important to not have it down and to keep it running, but it's so you can know what's going on, but it's not gonna be of that disaster kind that everything will be down, your revenue will be stopped. So that's generally not the case. PMM is available as a Docker container, as a virtual machine image, or as an AWS AMI. So whenever the easiest installation way is to use the Docker container. So you basically install Docker on your favorite OS, and then you do Docker pull PMM server and Docker run PMM server, and you'll be up and running. The VM image also works but you'll need the virtualization team to approve that image to be loaded. And in AWS you can always use the AMI, which is a convenient way to spin up an EC2 instance for PMM. So these are the components. In general, you have a PMM server component, which is what we've been talking about so far. And then you have a PMM client, which basically runs in general on your database server. So this client has two tools to configure PMM admin and PMM agent. PMM admin is the tool that you use to write configuration into the server, and the PMM agent is the tool that ensures communication between all the components, and that will make sure that the right exporters are being started. So exporters are things that collect the metrics from your system. You have the most basic one is the node exporter, which is basically exporting information about your system, your OS. You have the MySQL D exporter, MongoDB exporter, Postgres exporter, ProcSQL exporter, and then the RDS exporter. If you want to monitor RDS, the RDS exporter then uses CloudWatch and enhanced monitoring in CloudWatch to pull system level metrics from your RDS, because you cannot install the PMM client on the RDS machine because you don't have shell access. So in this case you need to install it on a different machine, which can be the PMM server but doesn't have to be the PMM server. But in many cases this is how it's done, to install the exporters or the client then on the server, to be able to collect metrics from the managed service database. On the PMM server itself, you have a big component called Victoria Metrics, which is a drop-in replacement for Prometheus. The difference between Prometheus and Victoria Metrics is mostly that Victoria Metrics supports push and pull model. So Prometheus only supports pull model, so it pulls metrics from the database server. So the monitoring server needs to be able to connect into the database server to pull metrics out. And in many cases, this connectivity into the database server is considered to be like a security hole, because you don't want anything to connect into your database. You want things to be pushed out from there. So that is why this is what I believe that made Percona switch from Prometheus to Victoria Metrics. And then you have the PMM Manage D daemon, which is the management tool that configures all the systems that are being monitored, and it uses a Postgres backend to store all of that data. On the other hand, you have the query analytics part of PMM, which connects to the database using either using a slow query log file or using the performance schema if it's enabled. And the query analytics are not stored in Victoria Metrics because Victoria Metrics is mostly a time series database. The query analytics are stored in ClickHouse, which is a column store database, which is very good for analytical workflows like finding aggregates and finding like the bad queries that consume the most time. You can use ClickHouse, and then there's a little query analytics app that is running in Grafana on the PMM server that you can use then to explore the data stored in ClickHouse. And then Grafana is the tool that mostly exposes the metrics and the dashboards. So you have some screenshots here. The PMM login screen, something about the operating system here, like this is overall CPU utilization. This is a MySQL summary with connections, supported connections, client thread activity, all those kinds of things. And then here you have a screenshot of the query analytics, so you can see all the queries that are running. You can filter on environment, on cluster, on database name. So it's a very useful and powerful tool to know what's going on in your system and to start diagnosing issues. In the latest versions, there's also an alerting option. It's a bit out of scope for this session, but know that in the later versions of PMM, you can also use it to set up alerting, and so you based on the metrics that it collects, it can send you alerts. So, but this is out of scope for this session. So, and then the final part of database reliability engineering is disaster recovery. And disaster recovery is mostly what do you do when a catastrophic event or a human error hit your database. And there's two major factors in disaster recovery, and they're called RTO and RPO. The RPO is the point in time where you restore your service to. So in the in the graph here on the bottom, you see this is the time when disaster hits, and so the RPO is the time you need to go back to get to a point in time where you can have a consistent restore of all your data. And so the loss, the amount of data lost is the RPO. So this is the amount of data you can lose in the event of a catastrophic event or a human error happening. And then the RTO is the recovery time object. It's the time that you can be down before you can restore your service. And typically, if you want to have less downtime, you might lose more data because you basically restore an older backup, and you'll go back to that point in time, or you promote a delayed replica to become the new primary, and you start using the data as it was on that delayed replica. But mostly we try to limit the amount of data we lose, and we get a little more downtime to get to a more consistent, more reliable way for disaster recovery. And so RTO, the fastest way to get to a stable situation again is with disk snapshots. So if you want to make consistent snapshots of your data, you need to stop MySQL cleanly and then make a snapshot of the disk, or you run flush tables with readlog and you freeze the file system for a moment. All of these operations, all of these options, they are invasive to MySQL. If you stop MySQL, it cannot serve traffic, so you need to run these on a special replica. But this is the fastest way to get a consistent copy of the data, and from that snapshot you can immediately spin up a new server and be going with a consistent data set. Another way to get to make a backup of MySQL is Percona Extra Backup. This is a way to do online non-blocking backups for InnoDB. InnoDB is important here because it relies on the MVCC options that InnoDB offers to create a backup. So if you want to make a backup of my ISAM table, it doesn't have those features. So in order to make a consistent backup of my ISAM, you need to block all the traffic and make the backup of my ISAM, and then you can release the database again. So for my ISAM, Extra Backup is still blocking, but the recommendation is to use InnoDB for almost all workflows, so that should not be a problem. It can do full and incremental backups. It's what we call a physical backup. It's just like a snapshot option. It takes a copy of the data on disk, but it takes a bit longer than a snapshot. Snapshot typically runs within seconds, while Extra Backup depends on the size of the database to run. And very important is, if you want to use Extra Backup, make sure that your Extra Backup and your MySQL version are in sync, because there was a problem a while ago where there was a change in the redo log format of MySQL in one release to the other, and all the backups started failing. So important is, before you do your MySQL upgrades, make sure that you have a working Extra Backup version before upgrading. So then point-in-time recovery. This is a way to reduce your RPO, your data loss, to 0. If your binary logs are backed up and available next to your general backups like snapshot or Extra Backup or whatever backup method you use, you can reduce your RPO to 0. Obviously, doing that takes time, so the RTO will never be 0 in this case. Well, RTO will never be 0, but it will be increased if you want to do point-in-time recovery. And in order to be able to do that, is you need to live stream your binary logs to a backup location. So when disaster hits, you can still have access to the binary logs, and you can figure out from the binary logs the exact point in time where the catastrophic event or the human error or whatever happened, and you can replay the bin logs, the binary logs, until that exact point in time, so you don't lose any data from your event. But to do that, obviously that takes time. So, conclusion. In order to have high availability and in order to have database reliability, MySQL replication is required. If you have a single server without replication, you can never achieve high availability. You can never achieve database reliability. That's a no-brainer. Orchestrator is a tool that can help you to automate your writer availability. Orchestrator will not help you for reader availability. Reader availability you need to solve by scaling. You need to have some spare servers available that can be used during an outage of one of the servers. If a reader server fails, that should not affect your database availability. That should be absorbed by the other servers in the topology. If a writer server fails, Orchestrator can help to promote a new writer server, but that takes away one of the reader servers. So you need to be able to deal with those kind of events. Proxy SQL can really help with service discovery, especially in the mixed mode where you have a core proxy and you have the satellite proxies on the application servers. It will be very easy for your application servers to figure out where the database is, and the proxy clustering will make sure that all these nodes are in sync, and can be used for talking to the right database. PMM, if you don't have any monitoring tools for your databases, it's that easy to install. It's very user friendly. So I highly recommend, if you don't have anything good, or if you're not certain about what you currently have for your metrics and monitoring, I highly recommend to install PMM, to expose the environment metrics, to set up some alerting, and to be able to troubleshoot performance when it happens. And then obviously when disaster strikes, backups are always important. Make sure to make backups, make sure to test backups, because otherwise you'll shoot yourself in the foot. And that's all I have for today. So if you have any questions, feel free to ask through the channels that are available. I will be online to answer some of the questions. If you do not have any questions at this time, but if you want to reach out to me, here's my email and my Twitter. So you can always feel free to contact me if you have any questions. And that's it. So thank you for watching, and until next time.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Please welcome to the stage with Open UK, Amanda Brock.
So, good morning, Austin. I guess this room knows a lot about open source, and you all know that we're all about community, we're all about collaboration, and we're all about conference. And how good is it to be back in the room together today? So I want to thank Percona for bringing me to the world's biggest database conference in open source. And I want to thank all of you for making the effort to be in this room today, because I know it's been a tough few years and it's hard to get everybody back together, but I think it's brilliant for us. So thank you very much. And I guess you're probably wondering what a nice girl like me is doing in a space like open source. Well, about 14 years ago, I worked for a company called Canonical, who some of you may know. And we were the commercial sponsor of the open source operating system, Ubuntu. Back then, we were the cool kids on the block, or at least we thought so. And I worked there for 5 years. I'm an ex-lawyer. I spent 25 years as a lawyer, and 5 of them in Canonical. And there was a bit of an accident happen when I joined Canonical. I was meant to come in as a corporate tech lawyer and to build out this legal team. And what actually happened was I fell passionately in love with open source, and that was just never on the agenda. So since then, I've worked in a number of different roles, and I do a lot of pro bono work. I sit on a number of advisory boards. I chaired one for the UN, Tech for Good, and in particular open source in that space is a big passion of mine. And this year, I stood for and was elected as a member of the Open Source Initiatives Board. And it's quite a big thing to take on, and I've taken it on because I thoroughly believe in some of what Peter was saying about open source. And unfortunately, the OSI doesn't own the trademark in open source, but open source has a clear meaning, and I'm going to talk to you a bit about what that is today, and what is open source and what isn't. I am the editor of a book being published in September. Now, the great thing about the book is it has 20-odd authors. It will bring lots and lots of skills and resources and information about open source to everybody, and it will be really expensive. But it will also be open access, and that open access means that that information, those skills from all these lawyers and policy people all over the world, governance people, people who understand how to build community, that will all be shared for free, which I'm really pleased about. And I can promise you, it is the only time you will see my name on the front of a book that I've edited. I will never be doing that again. I also speak a lot, and I do a lot of this traveling around talking to people about open source. And as we started the Roaring Twenties, I was quite excited because I had 20 keynotes lined up for 2020, and I did 0. They were all digital. It was heartbreaking. So for me, the year got off to a great start as we started to look at what was happening in open source, but it didn't quite work out the way I expected. And I suspect that's the last couple of years have been the same for all of you. And in Europe, and I saw this morning, to my surprise, the bulk of people being from Europe, but I guess they're logged in early, they started a digital decade. Now, I'm guessing that, like me, you probably think the digital decade was the last one. But this digital transformation that's happening at pace has now hit the point where every nation state, every government is looking at the infrastructure it has for its citizens being built on software, and that software is inevitably open source. So all of the services traditionally supplied, bricks and mortar, are now being digitalized. And what we're seeing there is the rise of open source, of course, because everything infrastructure-wise is being built on it. And there is some really interesting work coming out of the UK looking at government as database and saying that government is as good as the database it runs. Now, I don't normally read from slides, and I don't normally have many words on my slides, but this, I think, was really important. And this is the EU President, Ursula von der Leyen, writing to Margaret Vestager when she appointed her in 2019. Now, Vestager had been the competition, the antitrust commissioner in Europe for nearly a decade, and there are few people who understand the money in tech more than that lady does. And in this appointment, von der Leyen says to her, the changes in digital technologies and geopolitics are already having a profound effect on the lives of Europeans. We're witnessing major shifts all the way from global power structures to local politics. What we do now will determine what kind of world our children live in, and will define Europe's place in the world, creating a Europe fit for the digital age. Now, you can swap that. You can stick US in there, I can stick UK in there, we can stick Asia in there. You can pretty much do what you want with it, but it's true for all of us. What we do now is going to affect the future for our children. And the next thing that we did in the UK was we Brexited. For anyone who doesn't know what that means, it means we exited the EU. And this picture was taken at FOSDEM, the last conference that I went to face, and it was taken at FOSDEM 2020, and it's outside the Commission at midnight on the 31st, or it's actually 11:59, on the 31st of January. And what happened next was the Commission put the lights out, and I don't know if they put the lights out every night at midnight or if they were just making a point to the Brits from FOSDEM gathered outside, but we were out. And it's important because it started a lot of thinking about what this meant digitally. And we see Europe starting to talk about digital and data sovereignty, about bringing data home, looking at how it balances its own ecosystem of tech supply chain, how it balances citizen data being private and protected with the ability to make money out of data. And then, of course, along came the pandemic. This is the little-known Scottish variant, which is actually easier because you can hear it coming. I laugh about the pandemic, something that doesn't happen every day. There's not a lot to laugh about. It's been a rough couple of years. And in some ways, it's been good for open source, but I'll come back to that later. So as that was happening, we saw digitalization for anybody who was sort of reluctant, as a reluctant technologist, happen at pace. And we saw Europe in particular really publicly, really openly redefine its boundaries. And we saw this case Schrems 2, where the arrangement between the US and Europe for the shift of data, the privacy shield, was set aside in a court case. And we also saw a bunch of legislation that I won't go into in detail, but which was focusing on big tech, which was focusing on how they brought the digital structure back to being European. And one way that's been done is through something called Gaia X. And talking to a couple of people, I don't think the US is quite as familiar with it. And it's a data infrastructure for Europe. It's a digital and data sovereign infrastructure. And it's built on open source, and a lot of it is going to be about open data. And as you start with that sovereignty piece, what's particularly interesting is that you see Asian companies and the big US tech companies all being part of it. We were interested in Open UK. I stuck my neck out, and we've been a day one member. Because part of what open source is about is global collaboration. And as we Brexited, we had some difficult times with some of our European colleagues, and I had to remind them that it's not local source, it's open source, and it's global. So we've been part of this from the beginning. And in Europe, you don't just see this interaction with the UK or with the US, you also see it with China and Asia. But it's not just Europe. Then you start to see this geopolitical shift in the States, and the States and China, and even the UK and China. And it spreads from being nation states into citizen activism. And we see Black Lives Matter, and we see youth action at COP26. Open UK had a big event at COP26, and I'll talk to you more as we go on about the place of open source and sustainability, and I mean ecological and sustainable development goals type sustainability. But again, youth action. And then a war. I mean, what kind of couple of years have we had? And what's that done to open source? So depending on whose reports you look at, it's going to tell you that between 58 and 98% of any software stack is open source. But that really depends on how you define what open source is and how you understand it. Now, if I was to ask everybody in this room to start to define open source, I could probably put you in the four corners, maybe more, with different definitions. And your definition is very much going to depend on your experience, your personal experience of open source. Peter talked about foundations. If you've come through that route with the big companies collaborating, for you, that's probably open source. If you've come up a community route, you probably think it's that. One thing I suspect we'll get agreement on is that it's software that is shared in the open, that follows the open source definition and has an OSI-approved license. And even if any of you in the room don't agree with that, if you look across governments, if you look across the public sectors as they're evolving, you'll see that's what government is looking for. Now, there's a problem with that. It's fine as a basic definition, and it's good if we're measuring against that in terms of how much is being adopted. But there's also a risk. And often when we see people move to open source, they do it because they want to have an economic benefit. We did a survey last year, again, I'll talk to you about it in a minute, and I was gutted. I was really upset that the main reason people use open source is cost saving, according to our survey. So if we look first at that cost saving piece, they do it to avoid lock-in, they do it because they think they can recycle and reuse software. That's not going to happen if you throw software over the wall onto a repo like GitHub, stick an open source license on it, and don't touch it. If you don't have the good governance, if you don't have the good hygiene, if you haven't got documentation, if you haven't got a way of stewarding that code over time, if you haven't got maintenance, it's not going to be usable. So, you know, you're wasting money. So I think open source, we have to start to acknowledge that it's more than that strict definition. But we also have to remember that that strict definition is what we should be writing down when we do. And as we look at this sort of rise in open source, where has it come from over the last decade? And I have three things that I think have really caused it. I think the first is the rise in the status of the developer. So I used to work very hard at Canonical, and I worked very long hours with people in the US. And I spent 5 years of my life becoming a parrot. And I became a parrot who could explain why open source wasn't the risk that other lawyers and procurement people thought it was, and it was quite exhausting. That's not needed anymore. To get open source into a business, you no longer have to go through legal and procurement. The developer chooses. And the developer is able to choose to some extent because they have the access to open source software on Git-based repos. So before we had that, you couldn't do it. And it was a very different market selling services around open source and persuading people to use it. So we've seen this shift with the developer status elevating and their ability to just choose what they want to use, which is a great thing. It's also open to abuse, which Peter mentioned, where you have this, I think it was Mongo who described open source as a marketing tool. If we talk about what open source is, I'll accept lots of things. I'll accept that it's a socio-political movement. I'll accept that it's a methodology for development. What I and anybody who has any understanding of open source will never accept is that it's a business model. And that's been public, and that's been in reports since 2008. Matt Aslett wrote a 451 report in October 2008, and the thing that was identified there is open source is not a business model. So for the last, 2022, 14 years, we've all known that. And anybody who doesn't build a business understanding that hasn't done their homework. So if I go back to what it is that has changed, the third thing, and again, Peter and I picked up on the same image. This is an image that Dan Cohn created. Sadly, he's no longer with us, but for Cloud Native. And I think Peter's is much more up to date than mine. But when you see the scale of open source in the cloud space, it's just an inevitability. Now, fangirl picture, but, and sadly, I normally get a new one every year when I go to the Open Source Summit. I haven't had one for a couple of years. It's a little bit out of date. But don't listen to us. When I joined Canonical, public enemy number one was Microsoft. Bug zero was the destruction of Microsoft. Microsoft CEO Steve Ballmer talked about open source being a cancer. We live in a different world. I think Microsoft is probably the biggest single contributor by lines of code to open source today. And this is my mate Steve Wally at Microsoft keynoting Open Source Summit live in Edinburgh. And he explains that as being down to 3 reasons. And the reasons are that today customers ask for open source because they know it's the best software. Microsoft runs a cloud product, you might have heard of it, and you can't do cloud without open source today. And the third reason he gives is developers, and particularly the younger developers who've never used anything but it and the methodologies that go around it. Now that comes with some challenges around skills and learning, and I sort of feel that we've in some ways failed that generation. We haven't passed over all the information that the early stage open source people had about why things have to be done a certain way. And that skills development is something that really needs rectified. You know, if you read, Matt Acey talks about this being an inevitability and that the young developers aren't interested and they don't care. And I totally 100% disagree with him. I think we just haven't built that skill set for them, and we need to own that, all of us. So of course, talking about what's happened through the Roaring '20s so far, I've mentioned the pandemic already. In some ways, it was good for open source. I mean, we're used to working at home to some extent, we're used to dispersed working, there's all of that. But actually, when you look at the government responses to it, you see that the underlying tools bring in open source software. I'm not going to call out the British government as being a particularly good example, but I am going to call out the Germans, and they licensed their app on Apache. They had over 2,000 contributions from the community to that app because they built it in the open. And now what we're seeing is that a number of these apps and the tools for the pandemic are sitting in the Linux Foundation. Peter hadn't seen my slide deck when he did his, but many of you will be familiar with this news story. And I was quite excited about it because open source was in the New York Times. You know, that doesn't happen every day. And it was the end of 2020, and there was apparently a meeting of 7 leaders of companies that were open source, companies who had built a business model around open source, and they were very unhappy in the cloud environment because they felt that the cloud companies were strip mining their assets, strip mining their open source software. So just to make sure that I say this, I want to be really clear. When you put software out into the world as open source, that is what it is. You can't take it back. You can't say you didn't mean it. It's out there, it's open source, it's there forever. You can change later, of course, and you can make the next release proprietary, but there is absolutely nothing that you can do about what you've shared. And you have to think through your business model before you do that sharing. So when I left Canonical, I spent a couple of years working with startups that wanted to be open source companies. And they came to me and they were all fresh-faced and excited. And of course, I'd gone through Canonical, I'd gone through this whole shift to the cloud. We took 70% of the cloud market overnight. Do you think we took revenue to match that? So I knew what the score was in cloud back around 2012. I said to them, what if? So you put your software out there, and what if someone else uses it? Well, that's kind of the point of open source. Mostly they were fine. What if you put it out there and someone else makes money from it? And some of them were getting uncomfortable at that point. What if you put it out there and you make some money, or even you make a lot of money, but somebody else makes more? And at least half of them never came back to me. And they were right, because if you haven't got a business model that you're going to be comfortable with, that's going to sustain, then you shouldn't open source the code. You should think long and hard about what you're doing and understand what you want out of it. And we saw the opposite of that happening. Clearly, whoever advised Elastic didn't take them through the what-if theory. And they came in early 2021 with this doubling down on open part 2. Now, it's absolutely fine if a company doesn't want to do open source software. I think they're making a mistake, but that's up to them. And if a company doesn't have the right business model, because open source is not a business model, to sustain their business whilst distributing open source, they shouldn't. They should be proprietary. But the real issue is that we've had this spate of disingenuous, to use a lawyer's word, activity. Calling a clause the commons clause gives the absolute implication that it's part of the commons. So if what it does is make code proprietary, that's misleading. If you say you're doubling down on open, I had to look up what that term meant. It's now very, very popular in the UK, but I'd never heard it before. And it apparently means that you're playing some sort of football game and you're doing something and you're really committed to open. That's not what this is. This is a shift away from open source. And unfortunately, despite much of the debate that goes on, something is either open source or it's proprietary. There is currently no in-between. Now, that doesn't mean that we shouldn't have an in-between, but somebody has to go and invest in that. And it will take a lot of energy and a lot of money to create the movement for public source, shared source, whatever you want to call it, not to be proprietary software. Right now, it is very clearly proprietary. And we see this sort of business attack and, using open source as a marketing tool and shifting away, lift and shift once you've got to a stage where you've made enough money or you've locked your customers in. But that's not the only attacks that we're seeing. There's a real problem coming to the fore right now with standards. And what we see here is another attack on revenue. So a lot of the pushback we get around open source in business is around revenue. And of course, it's disruptive, right? So it comes into your sector, you think this is brilliant, I've got something free, I'm going to use it. With a bit of luck, you learn about hygiene and compliance and you do good governance. But if you have a revenue stream that's disrupted by that, you're not going to be happy. And what we see is patent licensing making a lot of money for companies in the mobile network operations and in the SOC and other spaces. And their standard essential patents that sit within their closed standards are problematic. And they're problematic because they require something more than the open source license for the open source to be used. And the real issue is that the companies who are coming to the table are massive, they have a lot of money, they're bringing lots and lots of resource to argue this battle. And effectively what they want to create is something that I would call frowned source. And it's kind of like open source apart from my patent revenue. And it's just a real problem that we all need to be aware of and ready to take on. And the challenges that we see in open source are broader than just business models. We have this security piece, and let's own the elephant in the room. I'll start by saying that security is not an open source issue. Security is a software issue. So as we digitalize, we have to look at security for all software. The US has taken real leadership, and that's to be admired. The Biden order last May, OpenUK responded to that, looked at supply chain, asked for SBOMs in open source, which is exactly the right thing to do. And then we saw Log4j, and we saw the impact of that. But how are we going to do this? And we've seen the US government last week had a second meeting with the OpenSSF and Linux Foundation, about 50 people in the room, I'm told. Very US-centric, but looking at how do they fix it. And I think there are tens of millions of dollars going into this 10-point strategy. OpenUK is also a member of OpenSSF, and I think it's great. But what we need to be really clear and really sure about is that we have an international, joined-up approach to fixing these problems. Because again, it's not local source, it's open source. And we all have to have skin in the game on this. And it is, as I say, because we're seeing national infrastructure across the world move to open source. So back in January, I was part of an advisory board to this energy digitalization task force for the UK. And it recommends that the UK energy system infrastructure is moved to a spine, a digital spine built on open source. We're just going to see more and more of this. And what it means is that we have to think about how we fund. And that funding, I think, has to move. Not only does it have to be internationalized, not only does it have to involve governments, but we have to start to think about what open source is. It's in the Commons. The Commons Clause is not, open source is. But then you start to look at public good and the role that open source is playing in this digitalization of all our national infrastructures. And we have to think about how governments are going to fund it. We have to think about sustainability. I said we had an event at COP26. We're going to host a one-year-on event in October. And at that, we delivered a couple of things. We delivered the open source strategy, and we delivered a blueprint on the data center of the future. At this year's event, we're going to deliver an EV charging blueprint entirely built on open source, working with a Dutch organization. And of course, I mentioned the other things that we've been going through in this digital roaring 20s and the war, which has already been referenced a couple of times today in Ukraine. And I think this was either the 8th or the 12th of March. It was a Twitter call. Some of you might even have been on it. There were about 800 people listening to developers in Ukraine. And I tell you, it was heartbreaking. So Anne and I were talking before about how to do this without crying. I'm a crybaby, and I'm trying not to. These young men were not coding, they were taking up arms, and that's what they were having to do. And we wanted to do something to help them, So we set up an open source link with the Red Cross to try and take donations. It's technically a UK link, but anybody can contribute to it. And we've been trying to help a number of women developers get out of Ukraine and come to the UK. Other people took different approaches, and there is a bit of a problem here. So open source does not discriminate between fields of endeavor and between people. And what we've seen is this protest where open source won't work in Russia. And one of the hardest, I'm going to cry even more, sorry. One of the hardest things I've ever done was say no to a friend in Ukraine in April. And what they were doing was looking at how to make this software not work in Russia. And of course I said no, and it wasn't easy. Unfortunately, we now get to move on from the war. I've mentioned a couple of other things that have come up through the pandemic, and of course there's this belonging, this diversity that's really important. Open UK is an organization that's really flourished in the last couple of years. I'm very proud to have led it through that phase, but it's not about any one person. It's about this UK leadership and global collaboration. And we have 2 staff, and we have all of these good people who some of you will recognize as international leaders in open source who work with us and volunteer their time. Many of them are currently at KubeCon. And what we do is we look at 3 things. We look at community, legal and policy, and learning. And on the community side, we showcase what's going on in the UK. We have awards. We bring people together to give them a voice. And we use that to influence legal and policy. And we do that by responding to legislation in the UK and Europe. We've been recognized quite early stage in Europe. We were part of the Google Oracle litigation in the US. We put in an amicus brief with some other open source companies, and we responded to the Biden ordinance. Last year, we created 3 phases of reports where we looked at the data that was available that had never been cut for the UK before, and we showed the numbers and the level of open source adoption in the UK. And we did a survey that supported that, and lots of brilliant case studies. And this is the kind of data we got out of it. And what you see here is using formula that I don't like that came from the commission that looks at sort of total cost of ownership, number of developers, number of lines of code, which I think is really old school. I think it's old school because it looks at this equivalency through total cost of ownership rather than value added. But on that, we can show 20% of the digital economy is based on open source in the UK. I suspect it's nearer 60. We also know, although we can't prove because the stats haven't been shared anywhere, that as we Brexited, Europe thought that it went from 490,000 to 260,000 open source developers. So almost half of them are in the UK, which is partly why it's been possible for us to have the reach we've got. Now, for anybody listening, I suspect there are more listening than in the room from the UK, please complete our survey. Anybody based in the UK can do it. If any of you have colleagues in the UK, please share it. What it does is start to ask questions that have never been asked before around this governance and good hygiene that I've been talking about. And the last thing we do is we work on learning and skills development. And we've distributed about 8,000 of these little gloves. And the gloves are based on a software glove by the singer Imogen Heap. Ariana Grande toured with the glove. So we find that it has a real attraction to young women. And we've created 2 courses that are available Creative Commons. The second one in particular appeals to me because the 10 lessons are based on the 10 definitions of the open source definition and the Sustainable Development Goals. And it's all done in a very light, fun way. It's all animated, completely Creative Commons. If anybody's interested, take it, it's yours. And you can work out how to make the gloves online. We also were runner-up in the GNOME Community Challenge. And I just wanted to show you what a small grassroots organization like ours can do. So we work with an amazing press agency, comms company OneByte, who have helped us with this. And we have this Twitter impact that's way beyond our size because of the great people we're made up for. So what I would say, just to conclude, is that we've managed to achieve quite a lot as a small organization. The battle is still ongoing. The war is not won. And for open source to really take the pride of place that it should in the next decade, it not only has to be the open source tiger this year, but it has to roar through the next decade. And that requires all of our global collaboration. Thank you.
Please welcome to the stage Donnie Burkholz.
Thank you, Amanda. That was fantastic. And I think it really brought home that idea of think global, act local, right? Wherever your local is, and tying everything that we're doing here in the open database community to open source as a whole, and how that ecosystem continues to evolve and needs to modernize, right? And that modernization is important, especially for a lot of the open source projects that have been around for decades. How do you keep that moving forward? How do you make it accessible to the new developers, the new DBAs, the new SREs who are entering our community today? So I'm going to talk about products. Many of you may not know me because I've spent most of my life, most of my career in the developer ecosystem, working at companies like RedMonk, working on open source projects like Gentoo Linux. In fact, I just looked up as Amanda was talking, my first open source contribution was almost 20 years ago today. I wish it were exactly 20 years because it would be a little bit cooler. But it was more than 19. It was on April 9th, 2003, and it was a forums post. And thanks to the engagement from the community that I got as a result of that, it snowballed into me spending more than a decade of my life working on open source software on the side as a volunteer, which eventually turned into the long-term career that I've now spent. So I've spent a long time in and around these spaces. I'm spending this just telling you about this so that you get to know me a little bit, and you get to know that even though my title has product in it, I'm not the business person in a suit. I'm coming from the community, and I care about making the community sustainable and building sustainable businesses around it. And so I'm going to start out by just painting a picture of the future as I see it, which there's three main components of this. The first is that it's connected, right? There is no being completely disconnected anymore. Everything is getting only more and more connected, which makes some things more important, like the GDPR, for example. If everything is connected and everybody's data is everywhere, then respecting privacy, having good guardrails in place only becomes more and more important. It also means integration becomes more important. Everything has to tie together. When you think about what a typical enterprise's environment looks like, it's complicated. There's not only one technology stack, there's probably 5, 10, 20 or more. There's not only one database, there's not only one cloud. Things run in multiple clouds, they run on premises, they run in multiple different technology stacks. They're hybrid cloud, whatever that means, right? The point is it's complicated. Things are running everywhere. And everything connects together as well between software and services. You can't succeed with just software alone. You can't succeed with just services alone. You need everything together to help a customer succeed with trying to implement, in our case, databases and data platforms. Second, the future is intelligent. Now, I don't want you to think when I say this that it's the same tired trope you always hear, which is that AI and machine learning is the future and we should all go jump on some kind of deep learning course. No, this is about all the different types of intelligence. All right, it's about bringing together the expertise, the intelligence that's inside all of your heads. How do you make that visible and transparent? How do you make that accessible to everybody you're working with? And how do you connect that to software as well? What happens so often is that intelligence inside one person's head, the best DBA at their company, it walks away with them when they transfer to a new role, when they change to a new job. It's all gone. All that implicit knowledge, all that tribal knowledge inside of their head about their company is gone. The same is true for communities. Sometimes you have community leaders who just understand how things are supposed to work, all the cultural mores and standards, right? The old guard, if you will, who there's principles that have never been written down in a community, and yet they're true. And you have these people who have been around for decades who enforce those principles and say, this is how we work here. But in many cases, it's never been written down. And that intelligence is really important to write down, share, so it's not lost. And it is about automation as well, right? Of helping make our systems more intelligent so that they stop people from doing the wrong thing by accident. How do you help things not go wrong consistently, especially as we get bigger and bigger scale, right? Data's never getting smaller. Database environments are never getting less complicated. They're only getting more complicated, more hybrid, more diverse. And we need more and more automation to help us succeed in those environments. Because there's always a corner case that's going to slip through somehow. There's configuration drift that's happening. There's somebody jumps into a server during an incident, makes a change. That change never gets replicated, never gets scaled out. And it's lost or it's maintained, and that one is always different forever. And so how can we take advantage of more and more automation to help us do the right thing, and focus our time on creating new value rather than our time on responding to tickets. All right, I spent a few years at an enterprise myself, walking in the footsteps of all the customers that the vendors are trying to sell to, and for those of you who are end users, making sure that I understand your pain points. And what it felt like was just constant toil, just trying to keep up, right? There's always pressure to decrease budgets, cut your costs year after year if you're in an IT department, and at the same time, you're being overwhelmed with these tickets. So how can you take advantage of more and more intelligence to keep up? And finally, the future is open. That's why we're all here, right? It's open source. It's keeping that openness real in a way that matters. How do you have open source not just be a marketing term, but be something that is true, that is real, that is authentic, where you can pick up open source software and you can use it in a helpful way. You don't have to go pay to get value. You get value out of that freely available version of it. You can go grab it from GitHub, download it, install it, and it's giving you something useful. It's not giving you something where you try it and then you just feel that pain of, now I have to go pay. It's open standards, right? Of how do you have things that work together consistently at scale? It's using standards. In our case, you might call SQL a standard. It says it's a standard. It doesn't always work consistently across different environments, but it is the lingua franca of databases, right? Every time there's a new database that emerges, at some point they almost inevitably go back and add SQL. Because tying into what Amanda said about how developers are influencing technology choices, this means that the barriers to entry are more important than ever. And open is one of the biggest ways we get there. How do you make it as easy as possible for people to adopt new technologies? Because if developers are the influencers, if they are the kingmakers, as my old colleagues at Redmonk would say, they're going to go whatever way is easiest. And if we make it too hard for them to go the approved way, the default way, they're going to find another answer. Now, we've been talking about the future, but what about today? It's great to have these visions of where we could go, and yet today we're so stuck. The problems, in many cases, remain the same as they have been for decades in a slightly different form. Right? It's things like performance and availability. Like Charity Majors at Honeycomb, who I've known for a long time, says, it doesn't matter where your database is running or who's running it for you, you still own the performance and availability for your application. You don't get to outsource that. Your customers, your company's customers, do not care. If you say, oh, we've got a supplier who's running that for us, they don't care. They're going to leave you because you chose the supplier, you created that trust in them, and they expect you to hold that trust up. It's security and compliance. It's an ongoing battle, one that is thankfully starting to modernize because we've got better tools for automation and continuous compliance than we used to. We don't now have the team in checklists who shows up once a year, once a quarter to do your PCI audits. It's getting more and more efficient and doing so in a way that helps you scale more effectively and dealing with those increasing demands for self-service. And if you're not hearing those demands, chances are that's because your developer teams have already bypassed you. They're already in the cloud doing self-service on something else, and you're just not hearing about it anymore. Because those developer teams are looking for and expecting self-service. They're looking for ways to move faster, and you're looking for ways to give it to them, but ways that don't give you more and more work. Our 2020 survey showed exactly that. The problems are the same as they have been. Right? It's availability, it's performance, it's incident response, it's security. It's dealing with all those issues continue to be the biggest pain points. And so we need to continue to take action to make those easier. Now, everybody here is from the broader open database community, and everybody has a different view on approaching that problem. Our view has been, as Peter said, has been a 15-year-long experiment now in staying fully open, doing everything we can to take open source as an experiment and say that is going to be the way we approach this. We're going to be the champions. And so we've had our great services business built around this for a long time. And we've also had open source software that we kept everything open source all the way throughout. And now we're bringing that together into something we call Percona Platform. This unifies the software and services to run your database experience in any infrastructure. And so when we think about what we're trying to do here, we've had services for a long time. We've had software for a long time. Software has been super popular. I'm going to show you some of the numbers later on. But we've never really brought that together. We think we have some of the best experts in the world. I'm happy to have a discussion about that with any of you afterwards. We think we have some of the best experts in the world in all the databases we support. And we're applying that expertise more and more, not only to the services, but to our software, bringing all of that together into that holistic solution to help customers get what they're looking for. I'm going to show you in a little bit a couple of demos of this. So you've been in an hour of keynotes now. You might be getting a little bit tired. You might be running out of coffee. We're going to show you some real working software just to keep things interesting. And if the internet works, the demo will work. Otherwise, you get to watch a video. So when we think about what we're trying to accomplish, what we're trying to give to customers with Percona Platform, it's about giving them control and visibility. Because when you have developer teams that are looking for self-service, the first thing that might be running through your head is like, oh, that's going to go off the rails. You know, they're going to do crazy stuff. The environment's going to fall over. They're going to use up all the resources. They're just going to start up instances that are going to keep running. They're going to never shut them down. It's going to be a big old disaster. They're going to do things that aren't secure. And so what do you need to do to give them the right guardrails to succeed, but do so in a way that doesn't have to involve you every step of the way? And do so in a way that for your production environments gives you overall visibility consistently across your databases, across your environments, from cloud to cloud to cloud to on-prem, and lets you see and manage those consistently. And secondly, it's about that simplicity, right? Because, I mean, let's face it, all you know, databases are super complicated. Complicated to configure, complicated to manage, complicated to monitor. The more we can do to bring that together into one place, the better. The more we can keep people from having to jump across fragmented tool sets, the better it's going to get. And finally, it's about enabling developers to move faster. And we do so through giving them a database platform that lets them move quickly while DBAs or SRE teams provide that platform to them. All right, and this is really that mindset shift. How do we change the culture, and how do we use technology to make some of that real? We give our developer teams platforms. We maintain that platform. We provide them with a self-service experience. We provide them with enablement, support, and training. And then those development teams can go, they can run, right? They've got everything they need to succeed. They don't need to start filing another 27 tickets the next time they're looking for a new database server. So we've brought together the things that make Percona great, the things that people love us for, all in one place. The open source software and the tools. We brought the expertise. We brought self-service content, which many of you who, if you haven't been a customer of Percona, we have a great knowledge base available for customers. It's only getting more and more popular, getting more and more articles in it. We've got close to 1,000 articles in there now, so there's a lot of problem solving. And what I find, I'm right on the cusp of being a millennial myself, and I know that at least for me, I hate talking on the phone with anybody ever. If there's anything I can possibly do to avoid interacting with a human on the other end of my commercial relationship, I will absolutely do it. I will change my vendor choices if one of them requires me to talk to a human and the other one I can just go buy it. And many people are exactly like that. So they're looking for ways to do as much self-service as possible, take advantage of what you might call level 0 support to just go solve as many issues as they can, and then go to the experts when they really need to, when they need customized advice, something that's unique about their environment that's hard to solve themselves. And finally, something that is new to Percona Platform. So we're bringing together the best of what we've sold, the best of what we've always given away in open source software, and something new. And what we're bringing new is these automated insights. So we talked about the power of intelligence to change the way we work. Automated insights are the first way that we've taken at Percona to help with that. And Barrett, our Director of Solutions Engineering, is going to show you a demo pretty soon here on what that looks like in practice. So when I joined Percona, I saw this great opportunity, and they had seen it too, in how can we take advantage of that software and pull it together into something really holistic and make that more of a product offering. Now, in the past 12 months, we have seen 75 million downloads of Percona's open source software. It's a massive, massive number. And what's really interesting about this number too, just that reflects some of the comments earlier about Kubernetes, is about 3/4 of those downloads were from Docker Hub. They're containers, right? People are using containerized databases, containerized database monitoring so much that you have to make sure that somebody's doing that at your company. And if it's not you, then you want to figure out how do you get visibility into that? How do you start enabling them? And how do you tie that into your broader data strategy? Or it's going to continue to happen without you. because there's a lot of people using containerized databases right now, whether you know it or not. They're making decisions about which database they're going to use, whether you know it or not. They're doing so in a self-service way. And now, even today, 2/3 of our support customers have chosen to run the Percona stack. All right? It's not been a part of our product at all. They've used it because they love it. They've used it because it works better for their needs. And of our managed services customers, all of them use PMM because that's how we run it. So that's not a very interesting stat to share. But 58% of them have also chosen to run the Percona database. This is just great support for the value that we're trying to bring to people, to take that expertise that people have known Percona for and translate that into software as well. And here's a few quotes from some of our customers who just really love Percona software today. I'm not going to read through all of them. I'm just going to give you a minute to browse through them. These are just some examples. Of course, I wish I could share all the examples that aren't public. Right? Peter showed a slide earlier on talking about some of the customers across different industries that we have. And this is one thing that when I joined Percona, I was amazed by the customer list we have. I wish I could share it all. But when you talk about 9 of the top 10 tech companies coming to Percona for our expertise, that's something that is so flattering. It feels really amazing to me. And this is a little bit of a humble brag, but I'm going to go with it anyways, because it just was it was a shock to me. Because I knew Percona for their expertise, but I didn't realize how much it meant to people who are leading the forefront of innovation in the tech industry as well. So what does this platform look like? I've been waving my hands around for a while talking about this Percona platform thing. What is it? In our case, I'm going to walk through this top to bottom fairly quickly. And I encourage you to come to our full-length session that will be running tomorrow if you want to learn more about it. We've got PMM, which really we see as the heart of the platform. It ties everything together. It's got both monitoring components. One of the most loved part of that is something called Query Analytics, or QAN, which gives people a great way to really dive in and identify the most problematic queries that are running. It's one of the reasons that people run PMM today. We've got advisor insights that are new. These are these automated insights. You're going to hear a lot more about those in a couple of minutes from Barrett. And then it's also got a management, which we've been making a lot of investments over the past couple of years to improve our management capabilities. Bringing you things like graphical backup and restore, which we're going to GA fairly soon here. An inventory, private DBAS, which you're going to hear more about in a little bit. Then we've got the database distributions, which is not just the database server, but really everything you need to succeed packaged up in one place. Percona Extra Backup is one of our most popular pieces of software. People use it regardless of which vendor they're using their database from, because it just works really well. Similar is true for Percona Backup for MongoDB, which we've got some really nice additions for. Hopefully you make it to a session if you're a Mongo person here. And then we make sure that all these database distributions include the backup, include what you need for high availability, what you need for security and audit logging, so that all of that is available open source. We just had a roadshow event a week or two ago in Sweden, where one of our customers went on stage, created their own matrix of decision making, and showed just item by item why they had chosen to run Percona software. And every one of those was because we had been publishing features, we had been publishing enterprise features in the open. Finally, we've got Kubernetes operators. We've got operators for all of these databases. They're all GA. People have been running them very successfully in production. We invested a little bit early, I think, for stateful databases on Kubernetes. That was a place where people were not ready when we started working on it. We invested ahead of the curve, and fortunately, that community has continued to grow. That momentum has continued to grow, and that's really reinforced the investments that we've made in it. Now I'm going to bring up our Director of Solutions Engineering, Barrett Chambers, to show you more about advisors.
Cool. Thanks, Donnie.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello guys, I'm Rahul Malik, software developer in Percona. So I'm going to talk about Pstress. Pstress is MySQL database testing tool, and it can do the stress testing in concurrency, it can do the feature testing, and it can do the crash recovery testing. So it is based upon the pQuery. It is developed on top of pQuery. pQuery is also in-house Percona tool. And how it is different from pQuery or MTR or RQG or Sysbench, the existing tool that we use for database testing. So it is different from them is because it uses the real-time metadata, like you whatever you are doing some inserts in some table, or you are adding the new column, so that column data will be reflected in all other threads. So it executes very successful queries because the real-time metadata, it knows how the table, and then using the options provided by the user, it generates a load. So it is little different from the existing tools. And that's how it can stress your database in concurrency, because it knows the real-time metadata. It's not like it is executing randomly any SQL. So it is executing the SQL which modifies the data in all the threads. So it knows the real metadata state of this. So I will be talking in this session, I will be talking about how you can use this tool for your stress testing or feature testing, and also how can you use this tool for crash recovery testing tool, and who is the audience for this test tool. First of all is your database developer who are developing the new feature, and they want to see like how your feature plays when in a bigger picture, like when you combine like for example, you have added some support of index or something, you have changed some code path in index, how it is going to play with some foreign keys, or with some inserts, or with the crashing the server during when in some insert is happening, or in some alter is happening. So that's how it take care of the bigger picture. And also it is used for the people who want to ensure that their database can work under the proper stress. Like for example, there are thousands, hundreds of concurrency, multiple threads are running, and then you are trying to alter a table to ensure, because that's why we use the database, to ensure everything is available all the time. And then when you want to add a new column, and how it responds when all the data is already in the buffer pool for. So that's how it is to ensure that your database can work correctly under the stress, under the concurrency. And also the third use case is to those who want to ensure that the crash recovery, how when under the extreme load, if your database crashes, how does it recover? So I'm going to talk about all these three things, and also the pillars. I will talk about the pillar on which this database is based. So there are different three things: probability based, and then real-time metadata update, and also the seed concept. So I will be talking about all these things in this session, with some example also, where I'll be just executing the load and sharing you. So yeah, so thank you guys. Let's start this session. So guys, I will be sharing you how to use this tool as a regression testing, or as a stress testing, feature testing, or if you want to do it, the crash recovery testing. So I will be showing you all the three use cases. Let me share you the screen. So I have already checked out in my home directory Pstress code. So this is the repository. All you need to do is check out Pstress from the Percona QA repository, and once done, I'll show you the command to build. The build command is straightforward. If you want to build it against the upstream MySQL, And then you just need to pass -t MySQL on. And if you want to build it against Percona, then you need to pass -t Percona server on. So this is a simple command, and you have to provide the base directory. So in this case, I will be building it against the Oracle upstream. So I have an alias, so I'll just pass that command. So once it is built, it will create a Pstress -ms. ms is for MySQL target. So this is the target, and it is created inside the source directory. So now to do any sort of testing, so this is a C++ executable. So I will be directly using this to do the stress testing. And so I'll show you all the help here. So it has almost 111 features to generate the type of TML or DDL you want. So like, for example, I'll in the later in the session, I'll talk about the seed, which is a very important tool, which is a very important option, sorry. But here, a few of the columns, like number of this help is like number of columns you want, whether you want auto incremental or not. So it is a self-explaining, the help option is. So you can use that, provide some probability for each option. I'll show you how. And then that's how you will stress your database. So for example, right now, I just want to, so this is, I have already started the instance. It doesn't have any table. So I will be calling this --table 4 --threads 5, and then like number of columns you want, and I will just using default everything. So the default number of columns is, maximum number of default depend upon the page size. For 8, it is, for 8.0, it is 7. For 5.7, it is 10. So for 8.0, the default number of column is 7. So it would have maximum 7 number of columns. I need to provide socket. It uses as a default root user, and let it run for 3 seconds, 4 seconds, or let it run for 10 seconds so that we can see the type of load it is generating. I will not run against the partition tables or not temp tables. So, and maximum number of records you want. Like for example, I will give it, I want maximum 1000 record. So now see what type of load it is generating. So it is generating some update, delete, and select. So most of your data by default will be your TML. And it would execute some DDL. I'll show you exactly. So this is the metadata that's I will explain again in some other in some session. So what is that metadata? So right now it has executed the load, and let us see the table structure. So there are 4 tables. So it has 0, 1, 2, 3 columns, some keys. It uses auto incremental, and then row format is redundant. So this all changes. If you see some other table, it would be different key block size. So, and then it will be keep on generating, and then some of the columns are added as the part of the load, and some are the default columns. And so that is how you stress your database. You pick some of the options you want. Like for example, here I've not picked any particular options. For example, I want to pick some particular option, like I want columns to be 20. Then it will now see so show create table. Initially it has 3 columns, right? Because the default value was 7. If you now see, this one has it has 16 columns, 17 columns start from 0 to 17, because I have given the option column quantity 20. So based upon that, it will pick some of the columns. So it has picked 16 columns. So you can see the different type of columns. It has char, it has varchar, it also has blob. So, and if you want to see some data, this is the data it has. just 7 rows because the load doesn't run for sufficient time. Maximum record was 1000. So based upon 1000, it will pick some records and it will create that number of records randomly. So that is how you do the stress testing. And for example, now I want to do some feature testing. For example, I want to test a feature where a developer has changed some code path in add column and drop column. So it is recently 8.0.29, and there has been some work done in this area also. So I will give minus add column probability 80. So the default is, if you want to see the default probability, grep add column minus 83. So the default is just 1. So it executes just one add column per, what is the total load? Like there are, if you see inserts, so the default insert is 600. If you see update, the default update is 200. So this, for every 600 sort of insert, it will just do one add, and for every 200 it will do, this is a ratio of SQL that are executed. So by default one add column will be executed and 600 insert would be executed, and update and so on. You can just grep and find out the default probability for any option. So now I will increase that probability, like add column to 80 and drop column to 80. So now it will have a lot of add and drop columns. So now that's how you are doing a feature testing. You will be executing lot of add and drop column. I will increase the thread also, so that it executed in lot of threads and some table also. Like let me have 10 tables. So now see the type of load it is generating. So it has metadata created randomly. It means, first of all, so the process, it creates the metadata and then it starts the load. So once the metadata is successfully, it will run the load for how many seconds? What is the default second? Yeah, just for 10 seconds. Show process list. So you can see that it is executing lot of add, drop column, and then add column. So it is executing lot of this type of DDL because that's what we have given right now. So it is completed. So if you see the SQLs, it generated here. 1 minute. So you can see the total number of DDL it has executed. Yeah, I've just picked any session. So you will see that it has alter add random column. So it has done, so it has executed 15 select, 3 insert, 4 update, and 1 add column and 1 drop column. So this is particular thread. So there are 20 threads like this which has done. Like for example, let us pick which has run for a long time. So this is the SQL again. There were select two, insert, 1 update, and 3 drop column randomly it has done, and out of this 2 were successful and 1 was because of some error. One got added out. So this is how you do the feature testing. And I've talked about the stress testing. For stress testing, all you need is to put a lot of threads and provide the different seed values. We'll talk about the seed also. Yeah, so.
So Pstress is a probability-based test tool. When I say probability, it means The type of load you want to generate is depends upon the probability, like number of columns, indexes, partition, and the DML or DDL, the type of load you want to generate, is all depends upon the probability we have given for some option. Let me explain you through an example. So this is our command. Here, socket, tables, no partition, log directory, where we are generating this logs generated by the peak query, and second 0 means just to load the initial metadata. Now here, this is the probability I was talking about, columns 30. It means the table could have maximum number of columns 30. So if I execute this and you see this, it has 16 columns. If I change this to 10 or to 5, it will have just two columns, D0 and F1. This 0 and 1 is the numbering. Initial tells you decimal, float, integer, char, var, what is the type. Like for example, if I say index is 0, so it means it will not generate any index. So there's no index generated on that table. If I say index is 5, so it will generate 5 indexes. Now again, another example is, for example, instead of running for 0 seconds, let it run for 5 seconds, and to see the type of load. For example, is a default probability. Let it run default. Let us see like number of insert, update, and delete it has done. So this is the logs it has generated, and if you see, these are the different type of SQL it has executed. Insert, it has done, so most of the SQLs are select, insert, and updates. I mean, as our in real scenario, the load is mostly DML, so that's why the default probability is more for insert, update, and delete. So it has done like 6,858 inserts. So now if I change this probability, and if I say insert is say 1 million, something like this, so it means now the most of the load will consist of insert. So it's a combined probability. Like we see what is the initial individual probability for each options, we combine them and we execute load based upon that probability. So right now I have given 1 million, 1 million to the insert. It means most of the load will be of an insert. So let us execute this load and see again what it has generated. Yeah, the load is complete. So if you see, like now there are just few select, few update, few deletes, and there is a add some random column, just one random column. So that's how it has generated this most of the inserts. So now our load is mostly insert. So there is some different options, like for example, you can say only command line SQL. It means it will just execute that and nothing else. Like for example, insert, update 10. It means based upon the probability of 1000 plus 10, 1100 total probability, out of which 1000 would be insert and 10 would be update. That's it. Only the command line SQL, or there's the option only command line DDL, or few other options. Based upon that, it will execute. So this is how to interpret the meaning of the option. So for example, if I say insert 0, and now if you see the load, it is still running. Yeah, it is done now. So insert, yeah, there's no insert value here. So it has not done any insert because I have given insert. So this is how the probability based tool works. So the type of load you want is totally depends upon the probability we have given. You can execute mostly DDL, just DDL if you want to focus on a feature, and then we just give an option like, okay, execute alter table space, add alter encryption or something like that. So just execute that pure DDL, nothing else. So it will do that. Everything is based upon the probability. So this is the special quality of this tool, real-time metadata. This differentiate this from the other tool. So what it does is, if it executes DDL in any session, the internal metadata of that table will be updated, and the other session will immediately start using that new metadata. For example, a column is added in one session, then the other session will start using that column, and then that's why the insert will not fail on that table, because the other threads will know the metadata of that table. So that's why this tool has very high success rate of executing the SQL. Or if an index is added in one column in one session, and then the other session could drop that index. So let me just give you an example also. So this is our command, and socket, table, log directory, no partition, only command line DDL. So only command line DDL means it will just execute the whatever the DDL options we have given, no other DDLs, just add columns, drop column, and the normal inserts, whatever it is doing. So the normal insert, update, and delete has a very high probability, like almost 1,000. So this will be the equally to this add and drop column also. So now there are 10 sessions that will be executing this SQL. So now if I run this, I already executed this. So just let me show you the result here. So these are the our 10 threads which have executed, and I also have grabbed one column. Like for example, this is the N37 which was executed. So let us just grab that SQL. So 1 minute, I have to case instance too, because that is order. So thread 6 has added that column, and you can see like it was successful, and the thread 1 later in the point of time, it has dropped that column. So that was also successful. It means this column information was spread to all the threads, and the data is generated based upon that. Also, you can see that inserts are also successful. Inserts are also generated on that column. So that is why it has a very high success ratio of executing the SQL. And plus, if you have any bug in a concurrent where, like for example, we have dropped some column and immediately there was a insert, or for example, you have added some column and there was an insert on that column immediately in some other thread, then it can cause some trouble. So that kind of concurrency issue it can catch, because the metadata is updated real time. So guys, let me explain you the concept of seed. So Pstress uses a random number generator. What does it mean is, it generates the random number, and that numbers are used to generate the type of query, the type of initial table structure, and everything. And when you use a random number generator, there is a seed concept, mathematical concept. As long as you use the same seed, it will generate the same random numbers. And if you change the seed, it will generate the different random numbers. So how you interpret this in the Pstress, as long as we have the same seed, we will get the same table initial structure. It will have same number of rows and exactly same amount of data. If we change the seed, then the number of columns, type of columns, and everything will be changed. So let me explain you with an example. So this is the command, and let me explain all the things in this command. Tables, I will be just using one table. There will not be any partition tables in that, and it will be executing in single thread, and there will be just 4 records. And second 0 means it will just run for 0 seconds after loading the initial metadata, and just for logging purpose. And exact initial record means if I have record 4 and I have this option, then it will generate exactly the 4 records. Otherwise, it will randomly generates records, and there will be maximum 5 columns, and the seed is 4. So if I execute this, and you can see the structure of TT1. TT1 is the type, the table structure it generates. So you can see right now
like it has medium text and int column. So if I change the seed value to, for example, say 5, then you will see that the complete table structure is changed. Now it doesn't have, see, previously it has medium text, now it has just char, var, char, and int. So this is the concept of seed. If you change the seed, it will generate a different type of load. So if you can reproduce some bug, most probably you have to use the same seed. If you change the seed, then it will generate the different type of load.
So apart from the concurrency testing, and this tool is used for crash recovery testing. So what it has is there's a C++ executable which do concurrency run, and also there's a driver script which is written in Bash which do the crash recovery testing. So how does it do is, so there's a concept of steps. I mean, you can resume your testing, and once, like for example, you have given 5 seconds or the database goes off, so it stops there and it knows that database is not available, and then it generates a metadata file to knowing that your existing metadata state. Using that file, you can again restart in the next step. So that's how it can be used as a crash recovery testing tool. So how we do it is, we execute it with, like for example, minus step 1, and we crash the server. We induce skill -9 to ensure that when your database is under the huge load, it can recover. And then this C++ executable, it generates the JSON files, which is the existing metadata of your database, like what it knows. And then we restart the database to ensure that your database can recover from that that kill -9 or the crash we have given to it. It can recover and it can recover to all the data structure. And then we continue the load using the same JSON file that we have generated in the previous step. So we resume that load from that point. So it serves two purposes. First of all, you validate your crash recovery testing, that whether your database can recover when it is under a huge DML and DLL load. And second is, since there's a concept of steps, and for example, you have introduced some corruption at step 7. So all you need is, you know that you have a database ready after the step 6, so which you can start and then replaying from that step only. Like you just need to replay from that, like last 10 or 20 seconds. So that's how it helps to reproduce also to some of the bug, because there's a concept of steps. And if a crash introduced on the 7th step, you can start from the database of 5th step, because it will start properly, and then you can just replay all the SQL using this again Pstress, and then you can reproduce that crash. So this multiple steps, it also helps the crash recovery testing tool, as well as ensuring that you can reproduce the concurrency issued bug easily, because now instead of like hitting some bug after 1 hour, you have a multiple steps where you save your data directory at like after each 2 minutes or 3 minutes. So if some bug is introduced at 60th second, you know that you can start from the 55 seconds, and you just need to replay the last 2 to 3 seconds. Plus this can also be like, for example, you need a very long load, so this can be also adjusted with an option, like you, instead for running for 30 seconds, you just give a very long run to see some sort of that corruption.
So hello guys, now I will talk about how you can use this test for your crash recovery, and also to automate the test cases for this thing. So to do that, let me share my screen. So I have already cloned in the home directory Pstress folder from the Percona repo, and it has a folders src, and where all this C++ source code and executable is placed. I have already built it. So it already has a Pstress PS executable. And this is the folder Pstress, where your bash script and everything, it is developed on top of pquery. So most of the scripts are inherited from the pquery. And this is the main script pstress run.sh, which we will execute and which uses a configuration file. And by default, it uses a pstress run.configuration file. I've already modified that. I will show you what all difference I have done in that. I've changed the base directory, and I also changed the working directory. So it will randomly generate a directory in your temp directory, in my home temp directory. So let me just clear that. So there's a residue of old run. I will remove them. Yeah. And now I will start the pstress run.sh, which will be using the base directory from my Percona server, and also which will be using the configuration file of this pstress run.cnp. Let me show you the configuration file as well. So this is the configuration file developed by Mohit. Mohit take care of all the updates in this bash script. So this is it is using the pstress ps by default. If you want to change it to upstream, then you can just mention --ms or wherever is there. Dynamic query parameters. So it tells like what all options do you want to use for pstress. Right now it uses the bare minimum, like tables and records, and that's it. Log all queries, log failed queries. But you can, if you want to do some real testing, you can mention like number of indexes, number of columns, and if you want to do some feature testing, you can mention it. And right now I'm not changing anything, just because I'm going to show you an example here. And like what all, this is option, like what all type of kill it do. Kill 9, so kill 9 is just a random crash. Kill 4 is with your generating the core file, and signal 15 is most like a shutdown, giving a signal. So by default it uses a signal 9. So that is what like I'm talking about. We are doing the crash recovery testing, so we use this by default the signal 9. And number of trials, number of steps. So this is it. I've already talked about these steps. So steps or trials, so it will be run in a 50 steps by default. So since it has inherited from pquery, so that in-file option was used in pquery, and that's it. Most of the other options are random, and this is MySafe, the options that you use for MySQL to start MySQL, and number of threads you want to run. And the same thing you can pass here also. Dynamic query parameter. So pstress run.sh is the script I'm going to execute, which default uses the pstress run.cnp, and it will run your database. It will start MySQL, and it will run the load pstress in multiple steps. With each step, we will be killing the server at the end of the step, and then it will generating the JSON file. The C++ executable pstress ps will generate a JSON file, which we use in the next step to restart your metadata and continue the load. So this is the trial run, ensuring there is no relevant server running. So previously it has cleaned everything. It has started the MySQL and waiting for the run to start, and then it will start your pstress ps. So, and then once the trial 1 is completed, we will kill the server and we'll restart it. In case of any failure, it will save all the important directory that is required to replay the bug. So that is about the pstress run.sh, the bash script, which is used to replay, or which is used for crash recovery testing, and also the automatic testing. I mean, normally instead of running a single pstress for a very long time, which reduces the chances to reproduce the bug, we do it in a multiple step, and we save the database, and so that you can, in case of any crash, you just need a delta time to repeat that. So now this is the options it has passed. number of record, number of seed, tables, and socket and everything it is running. So Pstress is running for maximum 60 seconds. I'll just show you also. Also, once the run is complete, it will just take a few more seconds. So it is running now, and this all options, I haven't modified any option. If I Let me share some success stories with Pstress. I'll not go into very details and just give you an example where it has helped to find out some regression in MySQL. So, it happens because when we develop something and we do not consider the very big picture, because database are very complex and MySQL is very complex. So you may miss some scenarios which can happen only if during the concurrent load. So like, for example, this is the recent bug I have fixed. Let me share the screen. So PS8190, and it is a debug crash, and it happens. So there are a lot of scenarios involved in this. First of all, you must have some index on a table, and then there should be some entry of that index in the buffer pool. And when you discard the table space, then it make that entries doesn't remove entries from the buffer pool. And if it is followed by a drop table, and then your server crashes, because then it tries to remove that entries, and which doesn't have any parent in the buffer pool, because that link was removed as a part of drop table space, and not but they were not removed. So very small bug, but it only comes when there are a lot of mixed scenarios with it. You have a DML, you should have an index, and then it should be in the buffer pool, and then followed by a discard table space, and then a drop table space where the asset actually hits. So there's a complex scenarios. Writing an MTR test case including a lot of scenarios like this is impossible. So that's how this tool was developed. There were individual SQLs, they were all combined together, and then you can run them and you can find the regression in your systems. So there are a lot of bugs like this we have identified in to make extra backup or PXC or PS or even the upstream to make them better. We have found out a lot of bugs like this, which happens due to the crash recovery or due to the concurrency. So yeah. The scope of this tool is only stress testing and crash recovery, and it cannot be used to check to validate your data. Like, for example, if we have done some DML, whether that data is updated properly. So it doesn't do that. So you just insert some data. If it is successful, then it will assume that it has been it has been added to your database. And yeah, so this is the limitation of this tool, that it doesn't do any validation, which is it is developed for. And the second thing is, it is written in C++, and since it involves real-time metadata update, so you to add a new feature, like for you have to you have to do this real coding in C++ and add that. Like, for example, if you introduce some new feature, some instant add column or something like that, then you have to actually go inside and do the coding in C++ and add that. So it takes more of a developer knowledge to update this tool. But once done, then automatically all your SQLs will start using that. So that's why it need the mostly, but it has a support for grammar files, like the concept of RQG, where it replaces some of the SQLs with that table name. Like, for example, you have a grammar file where you say very complex table, like select star from T1, T2. So it will replace T1 with some of the
tables that is present, but then again that will not serve the purpose of for what it is developed. So you have to do the real coding in, and then you can take the advantage of that feature with all the existing features of your database. So that is the limitation. You need to have a proper C++ knowledge to develop this tool. And yeah, these are the major two I think with this tool.
Hi, welcome to Virtual Percona Live. This is a quick little session on MySQL constraint checks. My name is Dave Stokes. I'm a technology evangelist for Percona Corporation, and we're talking about constraint checks. Now, they were introduced in version 8.0.16, which is way back in April of 2019. Before that, versions 8.0.15 and earlier ignored any constraint checks you had. Didn't flag them as bad syntax or anything, it just didn't do anything with them. Now, it's easier to keep bad data out of your database than to fix the bad data later, and check constraints are perfect for this. And you'll see that it really helps to name your constraint checks. Now, here's a simple little one. Create table, C1, which is integer, and we're going to have a check called C1 is greater than 1, which means anytime we try to put anything in C1, its value has to be greater than 1. Then we have C2, which is also an integer, and then later we can name it down here as a constraint. We're going to call that constraint C2 less than 100. We're naming that constraint. And we're going to check that C2 is less than the value of 100. So you can do them inline, or you can do them with a separate constraint line. Now, if we try to do an insert into T1 with C1 and C2 with the values 2 and 3, if you run a quick just check up here, C1 is greater than 1, so that's going to be okay. And C2 is going to be less than 100. So we insert that, everything goes great. Both valued enters are good. Now, let's say we come back and we want to put in values of 1 and 3. Now, in this case, C1 is not greater than 1, and it tells us constraint check T check underscore 1 is violated. That's kind of a clunky name. I kind of read that as table T1 check number 1, but that can be kind of hard. That's kind of a little bit of obscurity. I like to name them like you see C2 less than 100. By the way, this obscurity might be good in rare circumstances, but in many years of practice, I can tell you that's more of a pain in the butt than it's worth. Okay, another time, let's go to insert values of 2 and 300. We know from our little desk check that C2 has to be less than 100. This time it comes back and tells us constraint C2 less than 100 is violated. So it's very easy to see what's going on here. The little one's a little, previous page with a little nebulous. This one's a little more direct. Okay, let's create another table. We're going to do a constraint called name too short. We're going to check that the length of the data entered in the column name is less than 4. We go to insert data, name, values Dave, Bob, and Joe. And it comes back and tells us check constraint name too short is violated. Now notice in this case it doesn't tell us which one of these it blows up on, so might be better name this name too short length under 4 or something like that. And by the way, once it finds a violation, it doesn't do the rest of the insert, doesn't do any of the insert. So it stops at the first failure. Now here's another example. table T3. C1 is an integer, C2 is an integer. We have a constraint for C1 greater than 0, C2 less than 1,000, although it says 2,000 over here. Constraint C1 plus C2 is less than 1,000, so C1 plus C2 is less than 1,000. You can make these fairly complex checks. So if we go to put in values of 0 and 3,000, we get C1 greater than 0 is violated. If we come back and put in value of 1, so it passes the first check, we get the message that C2 is C1 plus C2 less than 1,000 is violated. So it runs through these checks sequentially. By the way, you can turn these off if you don't want a constraint check. When you create your table, you can actually come in and put in this hint, and you have to have the entire thing, the slash asterisk, the exclamation point 816 not enforced, asterisk, backslash, or forward slash. And you can see that the check here is x has to be greater than 100, and here we're trying to input 1 and it doesn't complain. So, by the way, if you look at the show create table, it has exactly the thing that we want not to be checked. By the way, there is a way to do this. When you create your table, you can come back and use alter table, name your constraint check, and by the way, this is the default. This will go for the first check in that table. Not enforced. Ooh, they should have a space here before enforced. And you can drop them. So if you have a constraint check that you don't like anymore, you can alter table, drop check. Now there are conditions your expressions must adhere to. An error occurs if the expression disallows constructs. Non-generated generated columns are permitted, except columns with the auto increment attribute and columns in other tables. Literals, deterministic built-in functions and operators are good. Function is deterministic given the same data in tables. Multiple invocations produce the same result. So things like connection ID, current user, now are not going to return what you want, so they're not allowed. Stored functions and loadable functions are not permitted. Stored procedures and function parameters are not permitted. Variables, system variables, user variables, stored program local variables are not permitted, and subqueries are not permitted. But constraint checks are very handy. And I want to thank you for watching this.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, everyone. I'm excited to have you here today. It is Percona Live, and my name is Sergey. I'm a group product manager at Percona. Today, I'm going to talk to you about physical backups with Percona Backup for MongoDB. This is the agenda. So maybe not all of you know what Percona Backup for MongoDB is and what it actually provides, what kind of value. So today I'm going to talk a bit about it. So it's going to be a quick overview. We're going to look into the differences on high level between logical and physical backups, just super quick, like an overview. And then I'm going to talk a bit about our comparison between performance of physical and logical backup in PBM. And the last but not least, this section will take us through physical backups, technical realization, what we did to implement physical backups in PBM. I really hope it's going to be super interesting and enjoyable journey today. So let's begin. Overview, right? So first of all, what you need to know about PBM. I'm going to say PBM today a lot. It is Percona Backup for MongoDB, PBM. First of all, it's 100% open source and free. You can find it on GitHub. There will be links somewhere in the end of this presentation. You can see it. It's a Apache license, so feel free to play with it. It is enterprise ready. What I mean by that is that I know that there are a lot of our customers and other users in community who are using PBM in their production environments, and they're pretty happy with it. So that's why I'm saying it's enterprise ready. Number three there is it is feature rich. And I'll talk about some of these features a bit later on, but what you need to know is that it's fully compatible with major public clouds. Usually what I mean by that is that if you run MongoDB somewhere in a public cloud, you can take your backup and upload it to the storage of your choice in this cloud. Usually it is either some S3 compatible storage like Amazon S3, or it can be MinIO if you run it somewhere on your own premises. It can be Azure Blob Storage, it can be Google Cloud Storage, GCS. So a PBM can upload your backups to this kind of storages. We do support the backup and restoration of regular replica sets and sharded environments. So there are multiple replica sets, they're all sharded. We can support that and maintain consistency. That is crucial for the backup. We do provide the point-in-time recovery, which can help you to minimize recovery time objectives and recovery point objectives. These are very crucial for disaster recovery or even for regular, hey, just spin up the database for me in staging. So you can do it much faster. And we also provide physical backups. Currently, they are in tech preview, and they're going to be GA, I believe, in a month or two, once we finalize all the tests and polish it a bit. But we're going to talk a lot today about physical backups, and I'm pretty excited. And number 4 here is supported by Percona. I believe it is extremely important for big companies, for enterprises, or for companies who are very careful with their data, that you can be sure that the product that you use is supported by some company or by big community, In our case, it is both. So we're open source, and we have our engineering, our global services team, which are ready to help you to implement and enhance Percona Backup for MongoDB in your environment. Good. So this was just super generic information. Let's see how PBM looks like inside, right? It is the architecture of PBM. So there are three main components that you need to be aware about. First one is PBM agent. PBM agent is just a process that runs on every MongoDB node within the cluster or replica set. And this process actually performs the backup and the restore operations. So it's just a daemon running on each and every node in the replica set. When I say replica set, I also mean, for example, configuration server replica set that you have in a sharded cluster. Another component, PBM CLI, command line tool, or command line utility. This is the tool that you interact with as a user, and it interacts with PBM agents running on MongoDB node. A single PBM agent is only involved with one cluster on non-sharded replica set, and the PBM CLI utility can connect to any cluster it has network access to. So it is possible for one user to list and launch backups or restores on many clusters. This actually enables you to run a machine somewhere which would orchestrate the backup and restoration of multiple clusters that you have running somewhere, right? And another important piece is PBM control collections. These are the special collections that we use or used by PBM, and they are stored in your MongoDB cluster. This collection has all the information about the backups that were taken by PBM. And both PBM CLI and PBM agent use these collections to check backup statuses in MongoDB. And we also use these collections for PBM agents to communicate with each other. Because when you take a backup, it's very important that there is a consistent messaging happening across PBM agents so that they know which one is uploading the data and so on, or restoring. Right, so these are the three most important components in PBM that you need to know about. This is the quick comparison, because there's this quite a popular question, like how PBM is different from MongoDB. And I understand that MongoDB is pretty cool. I really love it. It's a good utility, MongoDB and MongoRestore. But if you compare PBM and MongoDB, these are the three key components, right? So, So first one is sharding. MongoDB does not support sharding. This is version 4.2, I think, and PBM does. MongoDB does not have any CLI, which means that if you need to check the status of your backup or list the backups, you need to do it with some other tool or go to the storage directly and figure out where is it and so on. But PBM provides you this information through the CLI. And obviously physical backups, even in PBM, it is in tech preview, but it's going GA soon. So, and MongoDB does not have it. So this is it. Going forward, let's talk about logical versus physical. This is going to be a quick overview. So if we talk about logical backup, what it really is in a nutshell is that you read the data from your database, from in this case, it's MongoDB, and you take this data that you read, you convert it into some binary format, you compress it, you can put it into some archive, and you store it somewhere on some storage, S3 compatible, for example. And then when you do the recovery, what you need to do is you need to get this data in this binary format. You write this data into the database, and write is the critical word here, because you really writing this data, you're inserting it back into the data through your database protocol, or like it's similar like executing a command through Mongo shell. And in the process of this recreation of this data or writing this data, you need also to recreate the indexes and synchronize all your nodes. Like imagine you have a replica set with 3 nodes, and you are restoring the backup to one of the nodes. You are writing the data, you're creating indexes, and at the same time, you need to sync the data to other nodes in the same replica set. So this is what's happening, and this, again, super high level overview. What's happening with physical backup? You do not interact with the database here. This is the key difference. You take the files from the disk itself, from your file system. In the case of MongoDB, it is White Tiger files. And again, you store them somewhere on some storage. And during restoration, you just take these files and put them on the disk and start MongoDB. That's it. So you do not interact with the database when you talk about physical backup. So database layer does not take any part in the backup and restore process. Well, it takes, but we'll talk about it a bit later. But it doesn't do any heavy lifting, so it does not consume your resources. It does not slow you down. And when I talk about slowing you down, we did some tests, and we recently wrote a blog post about it. I will give the link to it in the end of this talk. What we did is we created a test setup. We took a MongoDB cluster with 3 node replica set. We spun it up on DigitalOcean. There were 3 machines, 16 gigs of RAM, and 8 CPUs each. So 3 nodes, 3 machines. We decided to upload our backup to DigitalOcean spaces. And the data that we generated was randomly generated. I think it was MongoGen or something like that. And it's like 1 meg documents. So it's randomly generated data, some rubbish. And the results are the following, right? As you see here, physical backups is in green, physical backups and restore is in green, and logical is in red, let's say. So, and on the left scale, you have minutes. On the left, on Y scale, you have limits, and on horizontal scale, you have the data. And as you see, for like 20 gigabytes of data, the difference between backup and restore is not significant, right? And even sometimes, no, logical in this case is not faster, but it's a bit slower still, but it's not relevant, right? So for this amount of data, it doesn't matter. When we move to 400 gigabytes, so it was 20, now we talk about 400, we see that backup time is 35 minutes for both logical and physical. So it's similar, it doesn't change. But when we talk about 400 gigabytes and restore, then we see that logical took 156 minutes versus 36 minutes for physical. And it is a significant difference, right? It's 5x in restoration time, which is a lot. And when we talk about 600 gigs, we see this similar situation that backup time is similar. It's 56 versus 52 minutes. Well, give or take, doesn't matter much. But restoration, wow, it's like 57 minutes versus 325 minutes of logical time. So the growth of logical restoration time correlates with heavily, linearly, almost linearly with the size of the data that you have. And but the time that it takes to back up and restore with physical capability is not changing. It's almost flat, right? Definitely, once you have more and more data, you need to face networking issues. You need to face or limits, and you need to face disk limitations, like how many IOPS you can write and read. But it's not that of a dramatic change, right? Because 325 minutes versus 57 minutes is almost like 6 times, right, difference, which is definitely a lot. So these are the results. And now let's look into the details, what's happening underneath. So physical backup tech peek. I'm going to go pretty deep into the technical implementation of physical backups in Percona Backup for MongoDB. I will talk about the internal functions that we use in MongoDB to address some of the consistency issues and so on. And I will also provide some good blog posts that you can read so that you would understand what's happening in more details within PBM and within MongoDB when we take the physical backup and when we restore the data, obviously. So let's start. So the question is, what do you need for physical backup? The answer is extremely simple. You need the list of files to copy to some storage. But at the same time, the critical aspect here is that you need to ensure cluster-wide consistency, which means, okay, you can copy the data from some random node in replica set, but how do you know that it is the latest data? How do you know that once you restore this data, that it is going to be what you really expect, that it is consistent with what you're expecting, right? So these are crucial items, and PBM is addressing this cluster-wide consistency problem. So let's see how we do that. So first of all, what we do first is we need to get the files. How do we get the files? Is we use backup cursor. Backup cursor was introduced in Percona server for MongoDB, this version 4.4.6, and it is the function, right? But it's not the function that you would use to query your data. It's the function for DBAs. And everything in White Tiger is a cursor, like the same way everything in Linux or Unix system is a file. In White Tiger, everything is a cursor. So what does backup cursor does? It just returns the list of files that you need to back up. So you just say, hey, my MongoDB node, please tell me what files do I need to back up to perform a physical backup. And backup cursor does this exactly. But not only that, it also returns some timestamp. We'll talk about it a bit later on the next slide, but keep that in mind. And this is an important note here, that PBM physical backups work with PSMDB only, Percona server for MongoDB. The reason for that is backup cursor is the functionality that was implemented in Percona. And what we are trying to do, we're trying to implement the same APIs and the same functions that you have in MongoDB Enterprise. And as you know, MongoDB Enterprise is closed source. What they have in community version, we use it, but on top of it, we build some enterprise grade functionality, which we open source later on. The same goes with backup cursor. Backup cursor is not available in MongoDB community version, so we had to re-implement it. We had to come up with our own solution for that. But we're trying to implement it in a way that it is compatible with MongoDB Enterprise, but we cannot guarantee its compatibility. So when I say PBM physical backups work with PSMDB only, maybe it's not. Maybe it would work with enterprise version of MongoDB, but we cannot just guarantee it, because some implementations might be a bit different and we cannot guarantee it. So if you're going to use PBM physical backups, please use it with Percona server for MongoDB. So this is backup cursor example. Let's see what is happening here. There are two important things that I want you to look at. First one is this backup ID. We'll need to use it later on, but it's fine. Another one is this one, important one, oplog end. This is the timestamp which indicates the latest transaction written on this specific node where you run this command, right? Aggregate backup cursor. So this is, again, this is the timestamp on this node that indicates the latest transaction written or the latest data written on this node, the latest oplog produced, right? And then we have the list of files. So it's white tiger files with the full path to them. These are the files that we are going to upload to our storage as a backup. But first, we need to ensure consistency. And to do that, we need to understand what is the latest time that we can use for our backups, right? And this is this oplog end time. This is the timestamp that we use. And in backup cursor, once you query, it returns this the list of files, and we get this timestamp once we execute this command. And we do it on all the replica set nodes. And the latest timestamp, so the latest time that we see, the biggest one, is the one that we're going to use as our backup and recovery timestamp. We're going to call it common backup timestamp. So it's common across all the nodes. And here again, you see it. I put it here as an example again, oplog end. This is the timestamp that we're going to use for our backup. So all the nodes on when we're going to take the backup on all the nodes, we're going to use this common backup timestamp as the time of a backup and the time of restoration. And how do we do that? We're going to use another function, which is called backup cursor extend. And what it does, it gets two parameters into it. It gets backup cursor ID, the one that we ran before, and it gets the timestamp. And once you ship these parameters to this function, backup cursor extend, it just waits till the node reaches this common backup timestamp. And once it reaches this timestamp, it just returns the list of journals since the cursor was opened. So now you have the list of files that you need to back up that backup cursor returned you. Now you have the timestamp that you agreed on that you are going to use across the cluster to take the backup. And now you have the list of journal files since backup cursor was opened. So you have all three components that you need. So you have the list of files, you agreed on the you agreed on the cluster-wide consistency time, and also you have this journal files since backup cursor, so you're sure that you will not miss any file during the backup process. So to make it simple, this is the example of executing backup cursor. So first you execute this backup cursor command. You get the list of files into the variable. Then you extract the metadata. And this metadata has backup cursor ID, and it has the timestamp of the last oplog. And then you execute backup cursor extend, and you provide it with backup cursor ID, backup ID, and you provide it with the timestamp as an input. And what you get is you get the white tiger log files. So you get these journal files. So now you can upload the backups, and now you can upload these files to your storage. So this is just an example of how it works under the hood. As you see, you can try it out with your MongoDB deployment and execute these commands and get some result. But what we do in PBM, we kind of automate it, so you don't need to interact with Mongo shell at all. So let's glue it all together, because I understand it might be a bit overwhelming. I will explain it in details once again. So what is happening is the first step. I believe I have not discussed that, but what is happening is that Percona Backup for MongoDB, PBM, chooses a backup leader in the replica set. So you have multiple replica set nodes, and I'm going to show one only here, but what is happening in PBM is picking one of the nodes in each of the replica set as a backup leader. We want to interact with one node only, so PBM agent is going to do all the work on one of the nodes in the replica set. We don't want to interact with other nodes because it doesn't make any sense. We are going to synchronize the data. So what is happening? We are opening backup cursor. So PBM says, hey, replica set node, open backup cursor. Backup cursor created. Now we get the list of files that we are going to back up, and we also get the metadata, which has an important information. It has backup ID, and it has the timestamp that we need to agree on. We choose the latest op log timestamp. So we chose it across all the nodes that we use. We chose the latest timestamp. And now we're going to open backup cursor extend or execute this command. We provide backup cursor ID and the timestamp. And what replica set node does, it returns us the journal files. And now what we do, what PBM does, it uploads files and journals to external storage. And that's it. Now we can close the cursor once the backup is done, once files are uploaded, and that is done. Right now we have files and journals on our storage, and we ensured consistency because we pick the common timestamp across all the nodes in our cluster, across all the shards, not all the nodes, but all the shards. And that's it. And it happens for each and every replica set in your cluster with the same common time. So that's it. Backup is done. Backup uploaded. Let's talk about the restoration process. Restoration process, I would say, is a bit easier, but it has its own quirks. So there are some problems. First one is sometimes it is possible that in your backup, once you upload all these files, there will be the data which is beyond your timestamp that you chose during the this conversation with replica set. It is possible that you will have some chunks of data that are beyond this common backup timestamp. This is problem number one. Problem number two is when we do the restore of the database, we need to shut it down because we cannot allow anyone writing to the database when we are restoring data on a physical disk, because that would corrupt it, that would do I don't know what, but we are shutting down the cluster. That's another problem, and I'll explain why this is a problem on the next slides. And another thing that we had to brainstorm a bit is, do we want to restore our data on only one node? So you have 3 nodes in the replica set, let's say. Do you want to restore your data on one node in this replica set and then synchronize it to all the nodes? Or do you want to restore your data on all the nodes, put it on all the nodes on the disks simultaneously, and just start up the database? So we had to think about it a bit, and we'll discuss it. And as I said before, on problem number 2, we are shutting down the cluster. So the cluster is down. Do we want to bring it up? Do we want to start up the cluster? Do we want to do all the heavy lifting with starting up Mongos and so on and so forth, or not? So these are the 4 problems that I want to discuss for restoration. So first one is super simple. So yes, we have some data which is beyond this common timestamp that we chose, but gladly there is a function to limit oplog. So once you restore the data, you can set some oplog truncate after point value. We set it in the local replica set database. And once you set this, then the restoration will not go any further. And that's it. But you just need to be aware that there might be some data which is beyond your point. That is how we address it. We just cut it. After this point, no data is going to be restored. Just keep this in mind. Communication with the database. So yeah, so we shut down the cluster because we don't want anyone to interact with the database when we're writing data to the physical disk. But the problem is that PBM agents, they communicate with each other. If you remember, I told you that before, they communicate with each other through MongoDB collection. So it is one of our components of PBM architecture. We have a collection in a MongoDB cluster through which PBM agents talk to each other. So, hey, I'm doing a backup, hey, I'm restoring, or whatever. And when we shut down the database, no communication is happening. So what should we do now? What we decided to do is that PBM agents are communicating through storage. We have a storage now where we have the backups and so on, and the agents can communicate through storage as well when they restore. Why do we need this communication? For example, you need to check if data is restored. How do you know it? You don't know, right? So PBM agents, they need to talk to each other and verify, hey, PBM agent on node 1, have you restored it? Yes, I have. Have you restored it? No, not yet. I'm still uploading the files. Have you restored it? No. So they need to talk to each other and verify. And this communication is important because it would allow us to provide you with the information if the backup is done, if there are any errors, if something is going on during the restoration, because database is down physically, right? You cannot check it and you need to sit and wait. So PBM CLI can provide you this information, and it talks to PBM agents through the storage, which is pretty awesome. So this is one of the problems that we solved. And yeah, this is just the solution. It's not the problem anymore. So what we decided is we want to restore data on all nodes as it is much faster. So you have a replica set with 3 nodes, and you have PBM. And what we do, we take the data from the storage and we start putting it on the disks of each and every replica set node simultaneously. So we restore to all nodes simultaneously. And the reason why we do it, imagine if we would put data on only on one node. So node number 1, we put it there. We start MongoDB process, we create the replica set, we format and so on. What would happen next is that MongoDB would start the replication process. And imagine if you have terabytes of data or petabytes, then it would take you again a lot of time to have your cluster up and running, to have your cluster ready. And instead of doing that, we decided to go with this simultaneous restoration so that it is much faster. Once you are done with restore, the data is similar on all the nodes. You just fire up MongoDB and your replica set is up and running, and data is synchronized across all the nodes. That's one of the decisions that we made. And another decision here is we want users to bring up the cluster after the restore. So the user executes the command PBM restore, it shut down, it kills the cluster, it starts, wipes the data on the disks, right? It starts uploading the data from the S3 bucket or from something else to the disk. And once it is done, PBM agents can report to PBM CLI that the backup is there, that it's finalized. But we do not want to go into this story where we need to start the replica set nodes or MongoDB processes, that we need to verify if they are up and running, if that we need to go to the balancer, to Mongos and start them as well. So it's a lot of work, and there are a lot of questions that we need to address if we want to go that road. And we just don't want to do that because it is much, much simpler for the user to do that. And also what we are going to do, we're going to automate it with some of our tools. Like we have Percona Operator for MongoDB. It is our Kubernetes solution to run our MongoDB distribution and PVM on Kubernetes. And we already have this backup and restore automation in the operator for logical backups. What we are going to do, we're going to introduce physical backups and restoration automation as well there. So operator is going to do all the heavy lifting of spinning, stopping the nodes, studying the nodes, because there are multiple restarts that are happening during the restore process. It's well described in the blog post. I'll share it on the next slide. So feel free to read it through. It's very interesting. Our tech team, engineering team wrote this blog post specifically about physical backups in MongoDB, and it talks about how restoration is complex. Yeah, and another thing is we're going also to provide the automation in Percona monitoring and management. It is our solution for observability and database monitoring and management. And one of the capabilities that we have there is managed backups. For now, it's again only logical, but we're going to introduce physical backups there. And once you click a button, backup and restore, it's going to do all the heavy lifting for you, so you would not need to do it manually. But for now, if you're using PVM, you'll need to restore the data and start up the cluster manually. I think it's not a big step because restoration is not that common task, specifically for physical backups where you need to restore like terabytes or petabytes of data. So yeah, that's it. So we covered backups, we covered restores, we talked about the problems with restoration, we talked about the technical details of backups, and these are some links that I encourage you to look through and read. So first one is our GitHub repo. Remember, we are 100% open source. Another link is for our documentation, and there are 2 blog posts, backup, cursor extend, and Percona server for MongoDB. This is the very technical, detailed blog post about the internals of Percona server for MongoDB and how we implemented this backup cursor functionality so that to enable this physical backups in PVM. And the second blog post was written by our engineering team about physical backups in Percona Backup for MongoDB. It has lots of technical details as well, how it works, what is happening under the hood. So yeah, I encourage you to look through these links and please let me know if there is anything. Yeah, so this is the last slide. I really appreciate your time. Thank you all for joining. And if you have any questions, please ask them through email, through Twitter, or you can also reach us out on our community forums or Jira, for example, if you want to submit a bug. So thank you, everyone. I appreciate your time. Have a good day.
10, 9, 8, 7, 6, 5, 4, 3, 2.
Hello everyone, this is Wei Gu from the VSoft. I'm super excited to have you here in Percona Community Live to share a Nebula graph, an open source distributed graph database. I am Wei Gu, or in Chinese is Si Wei. I come from China, Shanghai. I am an open source believer and DA of the Nebula graph. And I used to work on OpenStack before graph database. So you can find me in GitHub, Twitter, and this is my website. And my slides will be presented in this URL too. So feel free to reach out to me if you are interested in anything around graph database. Agenda today, I will quickly go through the basic concepts or topics around the graph and graph database. So after that, I will introduce you the Nebula graph from the basic concept to some more deep dive. And finally, I want to share you some demos. So let's start with why graph database. One of the reasons that I think we need a graph database is in the workload or the use cases that you care so much of the interconnection between data. For example, we can module, when we're thinking of this module, that you have a person and cooperation, and you want to query the relationship between them, and you have to define them in your database, right? When we are going to persist those information in a relational database or a tabular one, we have to create a bunch of joins that of the intermediate tables between the table that represent those starting point and destination point, right? That's doable, but that's actually quite anti-pattern of the graph pattern. Instead, in a graph database, you can directly mind dump what you are thinking of the relationships module into the schema of a graph database. So that's quite different, and that will make your life much easier when you're dealing a bunch of different relationships here. So another point is the query language. So graph database is only without those burdens. It's designed for the beginning to deal with the relationships of the data, but its query language was designed so too. So if you want to query 3 jumps of data, for example here, player served team, and then from the team to reverse it to all the served players, so this is the 2-hop jump. The equivalent query in Circle in a tabular database will be something like this. You will have nested, you have join things. So this is only 2-step jumps. So imagine your workload refers to multi-hoops of that. I will show you some queries like that. It will be a join curse for you, but still you can make it work, right? So then we come to the third reason, which is the deal maker for many cases, is the performance. So we have found that in a typical graph queries, when it comes to high throughput concurrency queries in a slightly large scale of data, the return time could be easily differentiated from the graph database towards a non-graph database. So the difference could be either it's an online system or an offline system. So that's a deal maker for many use cases like fraud detection. You want to stop this fraud transaction immediately instead of figure out after a couple of hours later. So that is why we need a graph database. So this is the point that I shared with you already. It's a query language. But underlying why the performance differs. So I'm old enough to play with the Snow Brothers. So if you are not familiar with this game, so you are the Snow Brothers. You want to jump from different stairs, and you want to shoot snowballs to the monsters, and then you walk there to kill it. So this is this is in some level similar to when we are doing the relational queries in the tabular database. That you have to scan a lot of data, just like you're walking here, until you know its next jump in a join. But instead, when we are doing so, for example, we can create different indexes, but the index comes with cost, right? Like you have this blue bottle, so you can run faster, but still you need to run between the stairs, right? But instead, in graph database, you will have this green bottle of magic. So when you get this bottle, you can fly directly to your next jump, directly in O1 effort. So that makes graph database quite differently. So I know this is an improper metaphor, but I want to make sense of the difference of different scenarios here. So later you will have more ideas on how it differentiate underlying in the system design side. So then let's move on. So what is a graph database after all? So I'm quoting the definition from the Wikipedia here. So basically, graph database is a database that will persistent graph in a graph structure, and also semantically query the data in a graph pattern. And when we are saying graph, we are actually talking about the nodes, the edges, and properties. We already know that in math, graph refers to the vertex and the edges. But what is the properties? It's actually just key and value attached to them. And I will dive into that later. So I assume that we all know what is graph and what's a graph database. But there are some graph databases out there already. Why do we need another one? Why do we need Nebula graph? And here is why. One of the reasons is that Nebula graph is designed from day zero to handling the large data volume of data. And I want to quote this tweet every time I want to share something about Nebula graph. That we all have the memory that like 1 year before, we have this ship. I forgot the name. It's called green something. Stuck here in this river, and that it takes us, it takes the world like a couple of months to make it work, to make it go through the river. It's very hard, and the world is waiting for the ship. But this is another one. So it looks quite similar, right? It's a smaller ship with a couple of guys, and this one man just pushed the ship, and the problem was solved. So the problem here is that we all know that the problem that we are trying to solve can be quite different when it comes to different scale. And Nebula exists because it's designed to handle hundreds of billions of vertices and trillions of edges while providing millisecond level latency. So that's why Nebula graph was designed. And here are some data provided by our community user from Tencent and Meituan that in their comparison and benchmark, that Nebula excels in the high volume data in high throughput rate and write. So when a data volume comes into a huge level, in Nebula it stands out. And here is why. So then hopefully I want to give you some brief introduction of how it was designed, and you will have more idea on why it excels in the large scale volume of data. So this is the brief architecture of Nebula Graph, and actually underlying, we have only 3 types of processes in Nebula Graph core. So one is the query node, the other is the storage node, and the third one is the meta node. And the name is quite plain and straightforward. So we actually have the computation layer and the storage layer separately. And in that case, you can scale different roles of the workload based on your traffic patterns easily. And another thing that we design Nebula is share nothing architecture. That means our query engine are stateless. So you will have the ease of the scaling. You don't have to put all the query engine in same spec, and you can specific different types of query engines for different workloads in one cluster. And it also comes with more ease of the fault tolerance, of course. And another thing is auto sharded. So we all know the modern distributed databases have this design pattern as all. And actually, we we shard data based on the hash of the key. And we implement our own implementation of the raft, both in the storage side and the metadata side. So, and that's the bird view of Nebula Graph. So let's dive into a little bit. So before we are diving into the storage and the query engine, I want to give you some brief introduction of our data module. So remember, we are talking about the graph database. It's modeling the data in a property graph. So what is property graph? As I mentioned, it's actually just the key and the value attached to the vertex or node and the relationship or edge. So for example here, in this graph, we have cooperation type of node or vertex, and inside the vertex we want to put more information, and it's proven that the property graph module is quite straightforward and useful. So we define a schema of this type of node with the name and location. So you can have cooperation name and cooperation location in the Nebula graph. And similarly, you will have the properties in the relationship or edges here. So here we have the person work as a role in cooperation. So the role name here could be CDO, the Chief Database Officer. And you can have another property called start year. So you work at the CDO since 2019. So this is the properties in the edge. So here we have the schema, right? So in Nebula Graph, we called the type or a set of properties of a given type of vertex tag. Quite straightforward. And similarly, we call the equivalent concept for edges or relationship called edge tab. So edge tab define a set of properties like this for edge, and it's distinguished one type of edge. And yes, we have the type of vertex as tag and type of edge as edge type. And how about the vertex and edge? Yes, for vertex, how we distinguish one identity of a vertex? We just use a vertex ID. And how we attach the properties? We just we create different tags, and different tags has different set of properties, right? And we can attach either 0 or more tags to given properties. For example, we can have someone called Tom Cruise, so we can attach a single tag for Tom Cruise, and also we can attach an actor tag to Tom Cruise, and you can do it in the same time. And so how about the edge? So in Nebula, this is quite unique that we define or edge in a full tuple. So this is different to a lot of most of other graph database. So in this full tuple, it's quite straightforward that you have the source vertex ID and destination vertex ID, and you have the type of the edge. For example, it's as row or hold share or is branch off, right? And also we have the fourth field for identify one edge. It is called rank. It's quite strange for the fresh users, but I want to give you more insight on this. So rank is just a number that you want to distinguish of one edge between two nodes or two vertex. For example, think of you want to use the edge to represent a purchase activity. So when people can purchase from one shop in multiple times, so in that time you can put your purchase order ID at the rank. So it will, in that way you don't have to use two legs and add an actual node in the middle to represent this one transaction. So this is quite unique to Nebula graph. And other fun facts are that the edge type is actually not related to the type of vertex or the tag of vertex. If you notice here, only the vertex ID are existing in the tuple of the edge. So that's one point to be highlighted. And then we will have more idea on how the data is persistent in the underlying storage node, and we will dive into that now. So this is a diagram that's showing you how we persist the vertex and edge in the underlying storage node. So as you can see, it's actually quite looks like KV storage, right? And underlying, we actually are leveraging the RocksDB as our local storage engine. So here the yellow one is here refers to one vertex, and the red one refers to another. So the green line refers to direction, the edge, starting from the yellow one to the red one. Yeah, and underlying, we are persisting this vertex as one with given tag. So if you have multiple tags, that's multiple lines of KV here. So if you notice that we actually have a duplicate lines of one instance of edge here, and this square refers to different shard or different partition. And actually, we are sharding or partitioning the data based on the hash of the vertex. So you can see that we hash the vertex ID, and we will have the result refers to different partition. And here it is the yellow one is hashed into partition X, and the red one is hashed into partition Y. And the other, how about other fields? This is the partition ID, right? Why do we need a partition ID? Because we don't treat one storage instance as single partition. We actually divide, we introduce way more partitions or shards comparing to the storage number. For example, if you have 3 nodes as a storage node, you can have 100 partitions or shards. And they can, so one node will have like more than 30 partitions. And with that design, you can have data being balanced in a better with our observation. How about the nature of the graph data? We know that, as I mentioned, that when you're doing the graph traversal in a graph database, that is basically O1 cost when you're doing the, want to get all the edges from one single vertex. And basically, graph database are persisting those data in the adjacent adjacency list. But how do we persist the adjacent list in a KV storage? And here is why. You can see the fields of the key is the type of data, the partition ID, which is determined by its VID, and then we come to the type of the data. Either it's the type of the vertex or the type of the edge. So from this design, we already know that everything, the key is persistent in the LSM tree, RocksDB. So it's already sorted. So that means given vertex and all its relationships are sitting closely together with the locality feature, and that's actually slightly equivalent to adjacency list. And yes, but why we choose to use KV to storage, so it's so structured storage to persistent the graph data. So the reason is the KV storage is quite mature, and it's really easy to implement a distributed system with Raft on top of that. And also there are so many best practices, papers, and engineering optimizations out there, so we can leveraging them. And yes, so as I mentioned, that vertex are sharded by the hash vertex, and the edges are located with the vertex, so that's why it's a adjacency list. But why it's duplicated? So actually, in a distributed graph database, you cannot put everything in one node. That's a most ideal situation. But unfortunately, in the data volume in today, you have to distribute them. So either you cut your edge or cut vertex. So in Nebula, we cut the edge. So that means you have two replica of the data, duplication of the data in both sides of the vertex, both sides of the vertex. So the gain from this design is that either you want to traversing from this point or traversing from here. You can have this. You can have the destination information just in O1 is co-located. So yeah, and that's basically the design of the storage node. And you can be noticed that the serialized value is actually the value of this KV. And we store the value in a binary pattern here. And one thing to mention is that as I mentioned, that there are a bunch of optimization on RocksDB or KV. For example, we can leverage the Whiskey design, the KV separation, and we have already bring that in 3.0, and it bring a certain performance improvement. That means if you turn the KV separation here, so in certain cases, some of the value can be persistent separately in another places. So that will be helpful when you have a bunch of properties. And that's only one case of the KV theories that we can leverage to improve the storage. With all of this design, when we are doing a graph query, so when you query the given vertex underlying in KV, it's just the prefix 6. And when you want to, for example, get neighbors, get all the next jump of one nodes, that will be underlying in KV. It will be the prefix scan of the edges in KV. So I hope you have more idea on how it's designed in underlying in the storage level. So then we come to the computation, the query level. So we also call the query node a graph node. And frankly, the query engine is designed quite similar to all the other or traditional databases. Mainly, we have four parts of the query engine, which is the parser, the validator, the planner, and the executor. And literally, the parser is handling firstly handling our one of the query, and the query will be translated into AST, and they will be passed into your initial execution plan by the validator. So it will translate it into plan and validate your query if it's allowed or not. And after it's validated, it will be passed into the planner. So planner will transform your original naive plan into a more optimized one. For example, here, you will start with the get neighbors to traverse all the data. And then you want to filter like where specific property is smaller than another value. So actually, we can already make it more optimal by push down the filter to the get neighbor query. So the get neighbor query is actually an operator that will be executed from the graph node and calling the remote storage node. So if you put the filter in this single query, you can fetch less data and it will be much more performant. So this is only one of the optimization role. So that's what Planner is doing here. And finally, with the optimized, there are a bunch of rules, and after everything is applied, you will have optimal execution plan, and the executor will initiate the meta client and the storage client. It will call your distributed storage engine and to get the data needed and make the further handling in other operators. So think of you are doing this query. You want to go from 1 to 3 steps from this single point over all type of edge types bidirectionally. And this query will go into parser, will be passed into AST. Then it will be validated and translated into a plan execution plan, and then it will be optimized in the final plan, and then it will be executed by executor. So executor will call the meta and the storage part of the system when it's needed, and then return the result to the end user. So this is the a query lifecycle in the query engine. So now we have some ideas of how Nebula Graph is designed. Then I want to share you more information on our query language. So actually Nebula have evolved for a couple of years, and we evolved from the original design to a quite different version now. So we define our native graph query language called NGQL first place. So basically this is all the queries that you can do in a graph. And this is first one is a Go that I already show you a lot of times. So you can traversing from given point in different patterns with Go. And another pattern is lookup. So lookup is a different query that you don't know exact ID of your starting point of your graph query, but you know some of its conditions or filtering conditions, like you can describe. So find all those with the property name called Tony Parker. So lookup will do that for you, and underlying is leveraging an index of given properties. And also you can actually directly retrieve the properties with the fetch prop. So you can fetch all the properties from given vertex ID or edge, the full tuple of edge. And another two are a little bit more complex, but it's actually quite native, a native graph query that you can actually find paths. So you can either find shortest or all paths or no loop paths if you have specific different parameters here. So it's basically find a BFS from 2 points. So one is here, 1 point is player 102, another is the team 204. So it will find the shortest path between the two data over all of the edges and return the path. So another one is the subgraph. Subgraph is doing everything that's traversing from one single point until you reach out your end condition. Here, we want to limit it to 5 steps. And yes, it's literally means you will get the subgraph of the whole data starting from one point here. And finally, the interesting part of the NGQL is we bring the pipeline as we have in the Unix shell, that you can put different queries connected with the pipeline. For example, here you want to traversing from this point over this pattern, and put the destination ID here in this query as the output of this query, and then you can go from this last step of the traversal and moving on, and you can compare. You can put the lookup and the fetch and lookup together to have a more complex queries. And that's the most of the NGQL part. And since version 2.0, Nebula Graph bring the support of another popular query language called OpenCipher. So it's initially brought by the great Neo4j. And with the Cipher support in the DQL, we can have more patterns, more complex patterns like this. So in this pattern, you want to match something starting from a property name with name Tim Duncan and this outgoing relationship to v2 and a reverse lag to v3, and you want to return the v3s. Similarly, you want to find a query that's matching all the vertex with tag player, but the condition is all those v player content v not connected with other vertex, or we call it orphan node. So similarly, you want to query this pattern with the ID of v2 in list of this, and you want to, in this pattern, you want to query, return the v here. The reason that we choose to design our own pattern of query is that the original team of Nebula Graph come from specific domain or industry that's mainly on the fintech. That in their scenario, previously they designed another graph engine to handle their specific industries problems. NGQL is quite enough for describing their patterns, and before we introduce Cipher, there are already a bunch of teams leverage Nebula NGQL, handling their quite large data volume. For example, the WeChat team leverage the Nebula Graph just with NGQL. So it's the most performant query. And when more of the users joining the community, we figure out that many of them are familiar with the Cipher. So we decided to support Cipher as well. And some of you may already know that there is actually a standard organization there that we will have a ISO GQL standard, and we already even have one draft there, but no vendor is already actually supporting that, and Nebula Graph is working on that. So in next major release of Nebula Graph, we will be fully compatible with the future ISO GQL, the graph query language as well. So that's all of the query language part. And then we come to why yet another graph database. So I think from my point of view, it's open source. Nebula Graph is open source and Apache 2.0. And with the help of the community joint effort, we now are quite mature that we have our first production user in 2019. We open sourced in 2018, and in 2020 we have our 1.0 GA, And in the beginning of this year, we have 3.0 GA. We brought a lot of new optimizations to the ciphers and the push down. And we bring a lot of more tooling chains in the ecosystem. And so as our community users, and until now, we have more than 300 users in record in different teams. And some of them are startups and some of them are tech giants like WeChat, like Meituan Akulaku, Huawei, etc. And if you are interested in more use cases, just visit our website here. There are a bunch of sharings, articles, and the best practices on their adopting and migrating to Nebula Graph. And so the last reason that I want to emphasize about why Nebula is Nebula Graph comes with a rich ecosystem. So if you're looking at the red part, so this is our core part of the Graph database. So we have a bunch of different open source projects surrounding the deployment, the observation, the cloud native, and regarding the graph algorithm, graph analytics, we have a bunch of projects. And regarding of the data visualization and other graphic projects, we have some of them out of box, and most of them are open source as well. And we have different clients out there. Some of them are mainly maintained by our team, and some of them contribute and donation and actively maintained by the community. And our ETL toolings, our data utility supports a bunch of different data sources. And you can, we also have backup and restore utility and integration with the Elasticsearch. So I want to give some of them in a more close look. So one of them is Nebula Graph Studio. It's an open source GUI console of Nebula Graph. For example, in real world, you want to in 3 depths of the host share relationships of given node here. And you can do that in a command line, right? But if you are doing that in the console of the studio, and you can choose to render it in a visualized way. And the studio can also support to, you want to import data in the import here. You can select the definition of data in a visualized way. And you can define the schema here visually. So next one is called Nebula Graph Explorer. This one is enterprise only. It's not open source offering. But one of the sweet feature I want to here show you is that we are doing it quite good in the visualization on other level. For example, this is a feature called Visual Query Builder. That you have noticed that in the real world, your graph pattern query can be quite complex, and to writing a complex graph query can be we can make it push it further with the query builder. So for example, here I drag the nodes here and I drag the connections between the nodes, and you select the filtering conditions here, and then you can generate a query with this. So it's quite sweet feature. I really love it. And regarding the visualization in the Explorer, is more powerful here. So you can do a lot of more things. And one of the things that I want to share is 3D rendering. Nebula Graph is one of the first team that offering 3D mode in the graph data visualization. So it's quite cool, right? And next one is the Nebula Graph dashboard. So it's another graphic tool, but stressing the ops domain. So in Nebula Graph dashboard, you can out of box have all the optimization, the lifecycle management, and the alarming and some provisioning works in one single tool out of box. So we have an enterprise offering and another open source version too. So on the SRE and the cloud native domain, we actually have open source Kubernetes operator. We have our Docker Compose and Ansible offering. We have our projects on Grafana, Prometheus, Stats Exporter, and Backup and Restore. So it's agent-based. You can run it as your sidecar. So one thing to mention is Nebula Graph is cloud native, and we are enriching cloud native landscape in the database category. So you can see in the category here. So this is the Nebula Graph. Yep. And also our team is maintaining a managed service on different cloud providers. And the AWS version will be offered in upcoming weeks. And you can, for now, you can already search Graph Database in the Azure marketplace, and you will find Nebula Graph Cloud there. So feel free to try it. And regarding the data import domain, we have a bunch of different toolings helping you ingest data from other sources to Nebula Graph. So we have an importer, which is a Go binary file that consuming the CSV files. We have the console that consuming your query strings. And also we have a tool called Exchange. So Exchange is a tooling running on top of Spark that you can exchange different kind of data sources from the different type of databases, from the MySQL, Kafka, and the Postgres, and from the other sources like ClickHouse and etc. Besides the Exchange supporting different data sources, Exchange can write into Nebula Graph in two kind of ways. One of way is a server based, so it just make the writing DML queries towards Nebula Graph. So the other way is to ingesting the underlying SST file. So when you're using this type of capability, you actually sideload the data. You offload the underlying sorting compute power of the Nebula Graph cluster. Instead, you are generating the underlying SST file from your Spark cluster. So, for example, as we know, WeChat is using this capability to do their T+1 huge data volume ingestion. We also have a bunch of different clients and connectors, like we have Spark connector, Flink connector, and different languages, etc. And now we have two languages of ORM of Java and Go. And recently we just have the Spring integration open sourced by one of our community user. So then we come to the graph analytics and algorithm. So we have two projects surrounding this domain. One is called Nebula Algorithm. So we have a bunch of de facto graph algorithms supported out of box here, and it's also open sourced. It's based on the Spark infra. So the good point of this is that you can leverage your existing stack capability and stack competence to play with Nebula, so you can run different graph algorithms that consuming the graph data sitting in Nebula Graph. So if you care more about the resource utilization ratio, so you can choose to leverage Nebula Analytics. So it's based on another open source project, but it's an enterprise only offering. So underlying is written in C++. And feel free to check out in our documentation on the Nebula Analytics as well. So finally, I want to share you something, some playable demos. So before that, I want to introduce graph use cases, so make more sense of how it should be looks like. So I want to quote one of our users, which is Meituan. It's a Chinese giant app equivalent to the Yelp. So they are leveraging graph database, Nebula graph, for like more than 50 different scenarios in their systems. So one of them is they are using AI agent, but underlying the data will be queried in Nebula graph. So for example, if you are asking the agent that is there any McDonald's nearby the street food bar, so underlying Meituan will query the data in the knowledge graph. And another one is more interesting, is related to the explanation of a recommendation system. So how do they leverage this? So the end user will see this. They will when you are searching your favorite restaurant nearby, so there will be one line of explanation of this recommendation. For example, those whom from Beijing enjoying Korean cuisines said this restaurant is great. So this is one of the reasons that why we recommend this restaurant for you. So how could this be done with the graph? So it's quite straightforward. Actually, they put all the different profile keywords of different users and different dishes and different restaurant, and they put them together in this knowledge graph. And when they have a user and a recommended item, they just use a find path in this knowledge graph, and they find one of the paths that's ranking the high, and make this path into this line. So it's quite interesting use case of the graph on the recommendation system. So graph database it excels in many and proven in many use cases. For example, the social network, you can, for example, in LinkedIn, you will have some n degree common users you may know. So this underlying is powered by graph. So fintech or other domains, risk control. So when transaction coming, so you can detect if it's done by a fraud graph pattern online. So public security have similar use cases, and the knowledge graph can be stored in a graph database. So in that case, your query pattern involving complexity, multi-hoops, it will be much easier in this way. So there are some graph-related machine learning works. So you can integrate machine learning, the GNN, towards the graph database, and some of our users are doing that. And so many other scenarios, they're carrying so much on the connections between the data. So if you are doing that massively in large scale, so it will be a perfect fit on a graph database. So, but then I want to demo you something here, and we don't have much time. So the first one is my side project. It's a toy project called Nebula Corp Rail Search. So everything is open source here. You can fetch it here. You can run it on your local environment. So let's start with the graph modeling. That's why we are doing graph database projects in the first place. How you want to persist everything in a graph. So it's very familiar that I already showed you this graph, right? So in this small project, we have two type of nodes or vertex. They are person. Person will come with the property of name and age. So person can be relative with other person. Person can working as role of other corporation, and person and the corporation have the hold share relationships, and the corporation can be a branch of another one, right? So with this graph schema defined, we can query from one corporation to know all the related shadowed persons or corporations related to this single corporation. So it's a quite normal use case in this domain, right? And in Nebula graph, you can do this. With this query, you can find this node is our starting point. Then we will know underlying there are so many other relationships with this single company. So isn't that quite cool? and then how it's built, and everything is actually on the GitHub. So in short, it's just the system will come with the front end. It will help us to render the graph, and the back end is just a web server that's handling your query. For example, you want to query one point. This point will be sent to the server, and in the backend server, it will compose a graph query for you and call the graph to the graph database. And everything is just connected in this way. It's quite straightforward. I'm not going to dive into more details, but you can see here in the backend code, this is actually underlying a match query that it want to query from this point to with all type of edges from 1 up to 3 jumps of the relationship. And afterwards, I want to demo you. And it will finally look like this. The UI of the system is just this. Is quite naive that you can fill the entity here and give an enter to make this analysis query. So it looked like this. You give the name like C132 and enter, and everything will be rendered here, and you can actually see it's calling the backend, and I'm not cheating. And from the result, you can have more insight in the interface, that you can know a bunch of other cooperation is related, and behind this cooperation there are a bunch of other people related. So isn't that interesting? And then we come to a final demo. So this is actually another open source project called Amundsen. This project it was initialized by Lyft and donated to the Linux Foundation. So you can find it here in the GitHub. So it's an open source project that doing data discovery or metadata lineage management. So you can have more information on its website. But how it's related to graph database, and actually Amundsen is underlying powered by graph database as its storage layer. So it persists. What Amundsen is doing is to handle all the metadata in your data lab. For example, you have your Postgres, Redshift, you have many data warehouse and databases, and you have your pipelines. You want to manage those metadata, so you don't have to make people fan out information in your Slack group or Slack channel. So Amundsen make it possible to make all of the metadata stored in graph database as the source of truth. And you can query them either from API or in the fancy front-end service that I will demo you later. So and this demo is based on Amundsen running on top of Nebula Graph. So this is the you want to search the table metadata with test, and you have a bunch of different schema or tables. So you click one of them, you will have everything around the metadata of this table, owners, frequent users, tags, and descriptions, and you also have everything around these columns. Metadata, you can have more data around the column level, and the more interesting thing is around its data lineage. For example, in this table, you have upstream, one upstream and 2 downstream, and that's the data lineage there. And also you can query the lineage in a visualized way. So this fancy system is quite usable by many teams, so they can have this single view to have everything connected and managed. So it's quite a good use case of the Nebula Graph. And underlying, if you are running a Manson on Nebula graph, you can also have the ability to query the information from the visualization provided by the Nebula graph already. So that's another benefit that we want to persist some data in a graph database or Nebula, because most of the graph database is offering your graph query plus the graphic console, and the graph console itself can be either for the query language can be a flexible DSL of your metadata system, and this query system itself can be leveraged by your domain expert to get more insight directly from the graph data. For example, one can easily have more insights in the graph database like this. So in this view, you will have everything connected easier, right? Remember when we are doing the Manson web page, underlying it's a huge graph query like this, and this is the code, and the query looks like this, and I didn't explain you the pattern of multiple match, and in this single query you actually query the table with the ID of this ID plus a lot of more connection queries, like 10 of them, and each of them are querying to different data types. You can query so much pattern in one go and in really short time. And that's all of the demo. And actually, the support of Nebula graph in Manson is still working in progress. And I'm putting this RFC in the Manson community in this issue. So if you are interested, just check out this issue. So let's do a recap. So basically, we have know what is graph database and why we need it, and what is Nebula graph. So Nebula graph is a linear scalable, performant, and the Nebula graph comes with a strong open source community with a rich ecosystem with a bunch of different projects offered around Nebula graph. And thank you for your time. So if you're interested in Nebula graph, feel free to check out our GitHub repo here. And this is Wei Gu from VSoft. And thank you, everyone. Thanks, Percona. So thank you.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, everyone. Thank you for dropping by. Good morning. Yeah, it's because of you this session is happening, because of you three people. But good to have you here. My name is Hamid Akhtar, and I'm part of Percona's Postgres engineering team. Today, I'm going to discuss about Postgres query performance insights. So this is kind of an attempt to look at what's available and how query performance can be analyzed using the tools that are available. So a few things about myself. So more than 2 decades of professional software development experience. I've been programming long before that, actually. So I'm part of Percona's Postgres engineering team, and I've been part of Percona for more than a year now. You'll see some of my talks as I was in a technical product management role prior to this, but I preferred an engineering role, so it's been a recent role switch for me. So prior to joining Percona, I was with Hygo, which is a Postgres company, and prior to that with Enterprise DB, where one of the things that you might have used were Postgres official one-click installers. So those were managed and done by my team. And for OS X and Windows, and previously we used to have them for Linux distributions as well. And occasionally we used to work with Devrim, so some of the RPM packages and changes like PowerPC related and SUSE related were kind of exchanged with Devrim as well. In case you need to reach out to me, here is my email address. LinkedIn, you can always add me on LinkedIn and message me there. I'm more responsive there. Skype handle is available as well, though I'm less active on Skype these days. You can also reach out to Percona. So we have a pretty good open culture, and this is a community forum where you can drop any message and rest assured that it'll be looked at by the teams. And we get bugged by our community team to respond to certain questions. So, and you can come and talk to us about any Postgres related, MySQL, Mongo, PMM, or PGStat monitor related issues. You can also look at our GitHub. Anything that we do is open source, and it has reasonable licenses as well. So in case you want to contribute, you can always do that. And finally, feel free to share the word. Percona Live is the hashtag. Let people know you're here. And let's carry on. So some initial thoughts. So observing query performance, when I see it, I look at it from a holistic picture. So it's not just about what the Postgres server is doing or the database server is doing. It's also about the ability to track that request to the actual eventual execution. So it's about connection information, how that connection was made, whether there were some things configured during connection that we need to know. And so it's really important that you have the capacity to trace back to the application, because different applications might be issuing the same query, but there is a possibility that it can be executed rather differently. And I'll explain later why that's important. So the first and foremost is the ability to know or the application that's executing the query, the connection information, and then the query text. So query text, in cases of Postgres, certain extensions, what they do is the constant string literals or values are replaced with placeholders. Now that becomes a challenge if you want to rerun that query, because you have placeholders and you don't have actual values. So it can be any value that, and the result, say it's a filter clause, and the results can be drastically different from 1 to a million rows, but depending on the value that's being passed. So really important that you have the capacity to look at what the actual query text was. Then it's about execution plan. So what was actually how it was planned to be executed. So that's important because you want to know how the server reacted to that query, how it understood it, and how it kind of evaluated and defined an execution plan for it. Obviously, you want to know the planning and execution statistics. And execution statistics are really what will then help you understand and tune your Postgres setup as well. Block reads, whether you're reading from the heap or the relation, or whether it's an index being hit. So what kind of blocks are being read? Are you missing the cache frequently, more frequently than not? Is there a lot of I/O happening? So again, that's critical if you're evaluating query performance. And then it's about wait events and locks. Is something holding back query from executing? Are there any steps that are being blocked? So really good information to know what's happening out there and what's causing the trouble. So let's start with the very basics. Let's start how the Postgres will evaluate a query. So explain and analyze are the two magic words that'll help us understand. There are 5 components to query processing job. So when a query is received by Postgres, it starts with parser, analyzer, and rewriter. Parser and analyzer are really making sure that the query is written correctly. There are no issues, syntax issues. And then rewriter does some transformations on it. So it kind of think of it more in terms of refining that query tree, because the query it needs to be optimized for then planning. So there would have some transformations in there, and then that refined query tree is passed on to the planner. So the planner now needs to then break it down and see how that query can be best executed. It will evaluate comparative approaches. And based on certain parameters, it's going to then identify how that execution should eventually take place. The executor just follows orders. Whatever planner has told it, whatever it's been decided and written for it, it just needs to execute that. So moving on, so it's about then understanding how that plan got generated, or what are the artifacts and how we can analyze plan generally. So that is where the explain command comes in. It tells us about the query execution plan. From a very basic point of view and very basic explain command output and the simplest form, we see that the explain command presents us with certain values. So it tells us, for example, that it's going to have a sequential scan on tank1 relation. And then it presents us in brackets a couple of 4 values. The first is cost, and then ellipsis followed by another cost, then total number of rows, and width. The important thing to note is that the explain command does not actually execute the query. So the query has not been executed. The startup cost is the cost that will be incurred before we can start emitting rows to the client or to the next node. So in this case, it will go out to the client. So there is no startup cost, which means that it can start emitting rows immediately. It doesn't have to wait for it. It would have had to wait had there been, say, a sort operation. So you can't just emit rows immediately. You would have to sort and make sure that the sorted rows are then presented. So there would be some initial startup cost in that case. And then the second cost parameter tells you the total cost. This is the cost is an arbitrary kind of number for effort, and it has no real world association. So you can't really say that it's like time or anything. It's just arbitrary number that is there for comparison purposes and then evaluating that in context of multiple approaches if they're available. Finally, it's a number of rows. So the query has not been executed, but we still know the number of rows. That's coming from the statistics table. And the statistics table may or may not be up to date. So if you've not analyzed it recently, it might be out of date, and there might have been a few operations, and this number can be very wrong at times. And then you have the width. That's the expected number of bytes per row. So that's an average kind of estimate. So multiplying the rows and the width, you can basically get the total number of bytes that are going to be returned as part of this query. So this is what the basic explain command tells us. As I've mentioned, cost is an arbitrary unit. So it has to have some kind of real world association, not with any units, but in some way or form, in some actions. So that in this particular case, in our case, it's cost when by default is set to 1 for a sequential page scan from disk. So when you read one page, which is by default an 8K page for Postgres, that's evaluated to as a cost 1. Now, all the numbers are then evaluated in context of this cost. So it's basically further. So basically, you set a unit, and then according to that, you basically evaluate whether you're going to incur double the effort, 4 times, or half of it. So that's how it works. So page cost can be sequential or it can be random. Sequential page cost is 1. Random page cost by default is 4. So you're going to incur 4 times the effort if you're going to read random pages. Why would that be? Because you're not really optimizing it for cache. You're not really optimizing it for OS. So that random access would basically be jumping back and forth potentially. So it's not an optimal way of reading. So if you are to read a page, a table or a file, you're better off reading the entire file sequentially rather than reading random blocks, because then you're not really benefiting from any optimization that the kernel or the hardware may have. And the cost of 4 was originally set for mechanical disks. With SSDs and NVMEs, you can set it to lower, and normally the recommended is 1.1. So it's very close to the sequential scan. Then you have CPU costs, and there are multiple types of CPU costs. So the operation for CPU is either you're processing a tuple, you're processing an index entry, or processing an operator. How this gets evaluated, I think, if I remember correctly, the cost for tuple, processing a tuple is 0.01. So it's one. It's basically, I think, 100. So 0.01, and then index entry is half of that, and operator is half of that. So that's how those costs are evaluated, and they, in the overall cost calculation, they are based on the number of rows estimated. These costs are then multiplied, and overall value for the cost is then calculated. There are parallel costs, whether you want to engage parallel workers, but the catch here is that there would be some overhead, and that's a significant overhead for parallel workers. As you spawn parallel workers, you're going to incur a significant cost. So I think more in terms of like a 10,000 cost parameter. So you're going to add that much if you're going to incur or initiate parallel workers. Because spawning those workers would have a significant overhead, and if your transaction is, or overall the cost is very small, then it doesn't make sense to have parallel workers initiated. Like for one, if you're going to fetch one tuple, you're better off maybe having 1 worker rather than 10 workers. A little more complex query plan looks something like this. Some complex keywords. So you see, for example, materialized. You see the bitmap, the index scan, bitmap index scan. You see joins. So what the planner has done is it's very smartly optimized some of the operations here. It's a join, so what it's predicted is that it does not have to read both tables every time for every row, but rather it can materialize one, and it can loop through the other one. And as we were discussing about the index scan, so indexes aren't really, while a relation, if you create it, for example, it doesn't really matter how that data is maintained, because once you go to the disk, you're effectively going to read sequentially most of the time. But indexes, they get updated over a period of time. so does relations, but for index, the key is, or the challenge with indexes is that you are reading in a random order. Tables, when you go to the disk, you're effectively going through a sequential scan then. So you're going to read multiple pages, but index you expect to read 2 bytes, and they can be far apart, or you might be hitting the same the same page twice. So a page may contain multiple tuples. So an index entry 1 can be on page 1, an index entry of 100 can also be on page 1. So there, for example, there was an update, or there was an insertion, another insertion. So you've added another value in there. So what this what the planner has done, it's created a bitmap heap scan. So it's kind of built a bitmap, kind of a list of pages that it needs to fetch, rather than fetching them immediately. So it's kind of delayed that fetch process, it's organized them, and it's kind of then made it more of a sequential access rather than a completely random access. So now you have a list of pages that you need to fetch, so which means that you're not going to fetch pages multiple times, the same page many times, but rather you're going to fetch it just once, and it's less back and forth movement then. So query plan is a tree of plan nodes, and the bottom ones are the scan nodes always. And there you can have a sequential scan, an index scan, a bitmap index scan. You can have an index only scan as well. And you have non-table row sources as well, where you can have a function giving out a set or value clauses. Now, the explain command can be prepended with the analyze keyword. What that does is, while the explain wasn't really executing the query, analyze does. And that's what really helps us kind of tune those costing parameters, because now you have a real world association. You have the actual times, so you have a time and a cost parameter. So you can see, for example, that actual time is 1.777 milliseconds, but the cost was 0. And similarly, you have a total actual time and a total cost. So this is where you can basically see if the numbers are skewed significantly, and you can then optimize or update your costing parameters based on your hardware environment. It's returned pretty similar information. So total number of rows is returned. It tells you about the loops and also the planning time, which you can also get if you do verbose with explain. So, and just what I've previously explained. So explain, analyze tells you, it basically helps evaluate those arbitrary cost numbers with real world values. It provides with the actual execution time, and it provides us with a lot more kind of real world details. You can add buffers, and you can see how the buffers are being hit as well. So you can understand it from that perspective as well. The tools. So these are the tools that are freely available. So no restrictions, but they serve a different purpose. All of these, and they complete the entire picture in terms of traceability of that query from the application to the eventual execution. The first one is a view, pgstat activity that comes with the Postgres core. You don't have to do anything. It's just available out there once you install Postgres. The next is pgstat statement. It's the most commonly used extension in Postgres. It's basically a huge list of statistics. It's a massive set, and those numbers at times do provide a challenge interpreting what's going on. Then it's auto-explain. Auto-explain is pgstat statement and auto-explain are both part of Postgres core, but they're available under contrib. So you're not going to have them available if you're building from source, just the Postgres. You'd have to build these extensions separately, and if you're installing it from packages, you'll see a contrib module separately. The installer will carry both extensions by default. Then PG Badger is kind of the odd one out. It's not an extension, it's not a view, it's an external tool. It has very good useful information, that's why it's here. And it's free, again, no proprietary solutions here. Finally, PGStat Monitor. That's the product that Percona just released this month. For Postgres, the version 1.0 is available. Looking at PGStat activity to start with. So it's a view in a PG catalog schema. It tells you really what's happening in Postgres right now. So it's the current picture of the server. It has one row per connection, and that information is very useful because it has a lot of details that are valuable in understanding what that backend is currently doing. So it starts with connection information, which includes database, anything that you need to know about that connection. So it has a database name, username, client, IP, host name. It can have if you've enabled log host names GUC. So otherwise, it would not be translating the host into host names, the IP address. Since there would be a slight performance impact, that's why it's disabled by default. It does have port, and it does provide you with application name and the backend type. So you can see the server backend processes as well. The application name is good to have, but under some cases, that application name might get obfuscated with if you have a pooler or a load balancer in the middle. What this really helps with is understanding the aging transactions. It has details in terms of timestamps. And those timestamps are connection and state and transaction related details. So when was the state last changed? Is this an idle connection or is it an active one? Is it an idle in transaction? So it provides you with that state of that current backend. It also tells you if it's waiting on something. Is that backend waiting on client read? Is that waiting for the server to do something? Is that waiting on a lock? What exactly is it waiting on if it's waiting on something? So it does classify in very detail the events. So PGStat activity tells us about the connection and application details. The things of interest is if the state is idle in transaction, have you configured idle in transaction timeout properly? Should this backend still be here, or should this be terminated by Postgres? The other thing is, although it seems like this shouldn't really be here, idle in transaction aborted. That's a backend that we should expect to go away. But in case you have save points in your transaction, it could possibly mean that it's fallen back to a save point. So these are also of interest because something has gone wrong and that connection is still there. State change, when was the state last changed? That's a clear indication whether this connection is actually doing something. Again, it's about client read or write, whether the client has opened this connection and not done anything and we're just waiting on client to issue a query or do something. So aging transaction, why are they important? Aging transactions are basically the worst thing that can happen to a database server. I've given 2 talks previously, and every time I discuss aging transaction come in, whether that's replication, whether that's high availability. Aging transaction in any environment are going to cause issues because they're going to hold back key resources. They would not let, for example, the vacuum clean up things. They could be holding locks, and they can hold locks for any reason, good or bad, which means that they might end up building a queue. They could even hold back, create index concurrently if you're trying to save or if you're trying to avoid exclusive lock on a table and you're issuing an index create with concurrent keyword, aging transactions can still hold that back. Any wait events that are not null, those are to be investigated further. Unfortunately, where it misses out pgstat activity is that it's the current state. So if the connection came and went away, albeit it took 10 times more time than it should have, that information would not be there after a while. So that information has disappeared from the records. And you would have to go to log files if all the details are, if log parameters are enabled. So it's the current state and it doesn't maintain a history. pgstat statement, this is the most popular contrib module that's out there. It has huge number of statistics information. And it tracks queries, it tracks planning, it tracks execution, it tracks anything that's being executed by the server. So it's not database-wise, but it's server-wise, really, the implementation. The thing to note here is when you, as part of the extension, what happens is that any extension that is supposed to be preloaded, once that's preloaded, it basically becomes part of the server. So it doesn't matter if you've created the SQL extension for it, but that preloading means that it's injected and added its functions into the hooks, and it's going to be called. So it's going to maintain information. So SQL extension creation is not necessary. It's still going to capture that, and it's still going to cause a performance degradation. So if you've added it just to avoid a server restart, you might want to consider that. Prior to version 14, what it did was it generated a query hash. Now that query hash needed to be generated without the constant string literals, because even changing of ID from, say, ID is equal to 1 to ID is equal to 2 should not really be considered a new query. So what it did was it replaced those constant values with placeholders. So it replaced that ID is equal to 1 to ID is equal to $1. And what it did not tell the user as to what values was replaced. It's basically per query based accumulation of statistics over time. By default, it maintains 5,000 queries. And as those more queries come in, it recycles. So it gets rid of the old queries. So it's very careful in terms of not consuming too much space. You could do a reset. Prior to version 14, there was no information as to when this view was last reset. So it could have been that data could have been a month old, a year old, but now that reset information maintains how many times deallocation has been done and how many times, when was it last reset. So you know exactly when these statistics were gathered. With PG14, and that jumble query mechanism has been shifted to Postgres core. And it's now as part of a GUC, which is a compute query ID. If you have it enabled, Postgres pgstat statements will work and it will collect the data. If it's disabled, it's not going to collect any data. It has a huge number of columns, so 33 columns, and most of them, pretty much all of them are numbers. So it has min-max values, it has standard deviations, it tells you about blocks, it tells you about read and writes, it tells you about times, it tells you about the planning time. If you have track planning enabled, by default it's off because again that does degrade performance a wee bit as well. So it provides with a lot of these detailed information with planning times, and so you have a query ID. You know the query, you don't know the actual query, but you know the query with placeholders. And then you have corresponding execution time and the block read and writes. You have wall read and writes, and in version 15 that's about to come out, they've also added just-in-time compilation statistics as well. So you'll see that I think 6 or 7 columns additionally have been added to these 33. This is probably the biggest view outside the catalog. That's there. I think PG class has, or PG attribute has a huge number of columns, and this has significantly large as well. It also tells you about, for example, it differentiates between blocks, whether it's a shared, local, or temp block. So if a lot of temp blocks are being written, it will tell you that your work mem is not sufficient. That needs to be optimized. You need to increase that. If there being a lot of read and writes, you can assess whether you're reading from relation or index. That information is also provided. How many times a block has been dirtied. You can get some of this buffer information with explain analyze as well for per query basis, but this is an accumulation here. So it tells you about, for example, wall statistics as well, like full page images. And that's useful, again, if you're going to evaluate in context of replication. PG-stat statements info, that's the view that I discussed, where it keeps a track of how many times the allocation has been done and when was this last reset. So it gives you a context in terms of date and time since when these statistics were being collected. So, I mean, one of the examples that you'll find in the documentation is about hit ratio for this, and how you can optimize things then. So this is a query straight from the documentation with PG bench, and you can see that hit percentage from 100 to 98. It looks like a 2% drop, but in actual terms, it's a significant drop if we're talking about cache. Because the overhead of cache misses is far too much, and it's significant in its order of order of tens rather than single digit. So it does cause significant issue. The problem with PG stat statements is that, unfortunately, being an accumulation of statistics, it cannot tell you a time or time of the day or a window wise basically statistics. So if you have a load on the server, or for some odd reason you have a query that ran very slow and you knew why it ran slow, it will offset those outliers in PG stat statements. So the max will timing or the max values will now reflect that query which was expected to run slow because, say, a backup was being taken, or somebody was configuring something, or maybe you were debugging something. So it will have that challenge where that accumulation and that data gets offset, so you don't get an actual data based on time of the day and when the load was expected, but rather overall, unless you reset it, and then you lose data, obviously. It provides you with planning statistics, but it does not provide you with the plan. So it tells you, for example, how many times this query has been planned and how much time was taken to plan this query, but it does not give you the plan. So it's kind of like half the picture, not the entire one. The other problem with this is that it's offering you the query, but it does not really parse it to the extent where it can pick up the relation and views, and will help you facilitate in terms of identifying whether which relation or views are like the common element in all slow queries. You can do parsing yourself, but then that's an overhead for the user, and being able to correctly parse that query and write that parsing regular expression will take time and effort. It does not provide you with actual parameters. Why this is important? Because say if you have non-deterministic values, you have a random number and you have less than a random number. That can be 1,000,000, returning 1,000,000 rows, and that can change how the planner will actually then build the plan. Because if you have 1,000,000 rows in the relation, it's better to return the entire relation rather than do an index scan. But if that random value turns out to be 1 or 2, then it's just going to return 1 row. So that's why those parameter values are important. It does not provide you with the spread of timing data. That's one of my biggest concern with PG-stat statements. So, for example, although you have the minimum, maximum, mean, sum of variance, and standard deviation. You have these statistics and the timings. But you can see, for example, in these two tables, and looking at the bottom rows for those, standard deviation is identical for both. Query min is the same, query max is the same, mean is different, but with three numbers identical, it's very hard to evaluate what's wrong with this. So what it would not tell you is that, for example, PG statements would not be able to help you identify that this query ran slow and significantly slow 3 times. So you have time that's 1,000 milliseconds, another 1,000, and another 3,000. While looking at the second table, it's 500 and 3,000. So that's a significant drop in terms of issues. Next is auto-explain. So this is a non-SQL extension. So there's no SQL interface. What it does is it dumps the query plan in the log file. Now, when I started discussing the tools and the observability and the holistic picture, and one of the things I mentioned was that the plan can be different for the same query from 2 different applications. Why could that be the case? So in my personal experience, we were debugging an issue where a query was taking about 3.5 hours from the application. And that same query, when you copy from the application, paste it in PSQL, was taking in milliseconds. It was a huge table. It was like, I think that table had about 1 billion rows, but still, it was managing to do that. Now, what was happening behind the scene was that one of the JDBC driver was typecasting a value, a filter clause value, a column value, in fact, to what was not in the table. So it was typecasting that value, and that could not have been predicted looking at the application or copying, pasting that query. So what really auto-explain helped us with is that it immediately identified that for the application, we're having a sequential scan on the entire table with 1 billion rows. Whereas when we run it from the SQL, we're getting an index scan. And that was a huge benefit because what would have taken us ages to identify was done in minutes. So with that piece of information, we could then go back to the application and we could fix that problem there, which was happening. It's very similar to explain command. So it's very similar to dumping that output, and it has very similar configuration parameters. What it also has is a log min duration, which means that you can configure that if a query takes this much time or more than that, just in that case, log it, but do not do it for every query. So rather than adding that overhead and dumping that for every query, you could do that by configuring this to 0. But you can also specify that if query takes more than 30 seconds, I would want to know what was the plan for that query. And it gets dumped into the log. So unfortunately, it wouldn't have a SQL interface, and you'll have to go and pick up the log files. But it provides you with all the details, like with explain and explain analyze that we discussed earlier. So we get the plan from here. Yeah, so an innocuous query may look like, or an innocuous change may look like pretty safe, nothing to do with query performance, but might just mess up the entire execution. The problem is that you have to go outside the SQL interface, whether you're using pgadmin or whether you're using pSQL. You now have to go to the log files and log parsing. You have to initiate a log parsing activity to pick up the query plan from this. Now that kind of is a put off, but it's useful occasionally, but you can't do it on a regular basis then. PG Badger. This is a fast-paced log analyzer in Perl. It's just one huge file with everything included in it. So does not require any complex environment or setup. What it does is it very smartly picks up the information from the log files as long as you have those log parameters enabled. and it summarizes that information and provides you with all the details. So for example, it's going to tell you about the top 10 queries that ran for most of the time, the top 10 queries that held the locks most. So with this, you have to be careful about how much log you're going to generate and how much detail you need. On my laptop, with a couple of things, in 15 minutes, I could generate a 4 GB of log file with everything enabled. So the good thing about this is that it can process the log files with multiple cores. It has a -j option, which engages multiple cores and then processes that log file quickly. And it can generate multiple output formats. The HTML one is pretty reasonable, though it's not. And you could basically use it in a browser and see how it looks and get all the information you need. So with all the useful information, it can help you identify and tune certain gugs. For example, workmem is one that you can immediately identify because it tells you about the temporary files that are being generated. So this is what it looks like with menus on top, and you can see, for example, it's covering a lot of these details, whether those are session, temporary files, vacuum, locks, queries, or top X for that. Parsing log files can take time. You can set up a cron job which ships out the log files on a regular basis to another system, in case you don't want to do it on the log file processing on the same system as the server. What it does additionally is that it can pick up log file segments, so it can pick up a daily log file and generate a weekly report in the end as well. So it does facilitate and accumulating those files and generating a summary at the end. Unfortunately, the HTML interface is not responsive, which means that it will not reorient itself for your smaller screens, whether on a tablet or on a phone. So it's not really that nice. The last of the lot is pgstat monitor. This is an extension that we've just released this month, and I'll explain why I think this is a good extension to have. So it kind of analyzes query performance in a very different context. If you're familiar with SAR on Linux, which basically gathers statistics over time, and you can query it for time windows and assess it when, say, based on time of the day or week, and get the load information. This does that in a very similar way. It carries all the data from pgstat activity, from pgstat statements, and it picks up a lot of good information from pgstat activity. So it has the connection information like pgstat activity, and it also has the statistic columns of pgstat statements. Furthermore, it also has the capacity to show the actual query plan, just like auto-explain. So it can tell you about the connection, it can tell you about the statistics, and it can also give you about tell you about the plan. So it's like a combination of all three, and it gives you all of this in a SQL interface. What it does is that it has a time bucketing system, which means that it will save based on the information based on the time buckets. And these are configurable, so you can set as many buckets as you want. You can have like an hour, you can have bucket time for an hour, and you can have 24 buckets, which means that you'll capture that data for the entire day in 24 separate buckets, and that will really help assessing load, whether, say, at 3 a.m. in the morning, you can assess what kind of load you had in case you want to run some backup. If you want to take a backup, you know that whether you should do it at 2 a.m. or 3 a.m. or 4 a.m. You can analyze those query performance patterns. By default, we've configured it as 10 buckets of 1 minute each, and buckets get rotated. So it's a kind of like a circular queue. So once it goes past 10, it will reset the first bucket, and it will start using it. So you can configure the amount of shared memory it's going to consume, and so it's not a memory hog in any way. It's reasonably safe. So what it does is that the overall traceability of that query, it picks up on the key attributes. pgstat statements was accumulating data based on just query ID, the query hash that was being generated. What pgstat monitor does very differently is it uses bucket ID, it differentiates a query being run by a different user on a different database from a different client, and it can also tell you about whether a different plan was generated for this. And it can tell you the application name as well, and whether this was a top level or a nested query. So it can tell you a lot of those details as well. And it's basically this grouping that differentiates that, and that helps debugging process. Because say you have the same query run by the same client, but the plan changed. You would not know that with pgstat statements. But here, it will end up creating a new row. And you would know that a plan changed looking at all the other parameters. You'll be able to immediately identify why this plan changed, whether something was tweaked, whether somebody just tuned something. So it has more than 50 columns. All of the columns in pgstat statements are here, plus there are additional columns. And it does have a lot of other useful information, which I'll explain in a bit. Similar to pgstat statements, you can turn off the planning part, because planning always means that you have basically initiated another process in the query processing job, which will slow down any query. So you can turn it off. I think it'll just slow it down by 2 or 3%, but that's significant if you're not really using it. If it's turned off, all the planning related columns will have empty values. That's, I guess, understandable. So application and client information. So you know, for example, you can have the application name, you can have the port, and all the details that you would want from client in here. What it also does is that since buckets are being recycled, so it does not just maintain kind of a reference to the top query, but it also maintains top query text as part of the query itself. Because that top query could have been executed and could have been part of a different bucket that got recycled. So this also ensures that you have that complete set of information with you. It provides the context in terms of relations and views as well. So it has a separate column that has a list, and it tells you, for example, what this query, what relations or what views this query actually touched. So now you can look at it from a table or a view perspective, and you can analyze the statistics based on that. Whether there's a common culprit in all of those slow queries, and that's one relation that needs to be vacuumed. Additionally, you can save metadata. So similar to a SQL, Google SQL commenter, you can save the comments in your queries, and they will be preserved in a separate column. Now, why is that useful? It has very specific benefit as well. So you can, for example, save specific information. But what it also does is it can look through any intermediate layer, whether you have an HA proxy or a connection pooler, PG bouncer, or PG pool. The application can identify itself through a SQL comment, and that information will be maintained. It can identify its IP address through a SQL comment, and that will be preserved separately. So rather than you seeing that same IP address of HA proxy or a connection pooler, you can now pass that information through. It provides you with a histogram. So this was one of the concerns with pgstat statements, that it does not provide you with the spread of that data. This maintains a histogram. And it can tell you, for example, the first query ran in 0 to 3 milliseconds twice, and then it ran between 10 and 31 milliseconds once. It's on a logarithmic scale rather than a linear one, because you would want to capture the data over a longer period of time rather than creating a huge number of slots. It was released this month, and it's available on Percona.com as part of our distribution, and it's also available in yum.postgres.org. It's available currently for version on yum.postgres. It's currently available for version 12 and onwards. They're fixing one issue with version 11. Just to summarize, so the use case really is, if you want connection information, you have stat activity and stat monitor. Stat monitor preserves that data, stat activity does not. If you want query text, you have PG Badger, you have PG stat statements, and you have PG stat monitor. PG stat monitor will expose query, not just placeholders, but actual constant literals as well. So it's going to provide you with parameter values, which can then help you execute that query. Then you have the execution plans. You have auto explain, PG Badger, PG stat monitor. Planning and execution timing statistics, PG Badger, stat monitor, and stat statements. Query timing execution histogram is just PG stat monitor. Block reads and writes, it's the usual suspects, Badger, statements, and monitor. Wait event and locks is PG Badger and stat activity. Unfortunately, this is where it's very hard to accumulate that information. So you can't really pick up that wait events and locks in stat statements or monitor. And finally, SQL interface, which is stat activity, monitor, and statements. One of the values we really share is that we want to keep our source code open, and we want to keep it flexible so that there's always that freedom of choice for people. Thank you so much. Let me know if you have any questions.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
My name is Hamid Akhtar, and I'm part of Percona's Postgres engineering team. So today I'm going to discuss Postgres replication conflicts and some pitfalls. This talk actually kind of focuses on some of the internals as well, partly for how that conflict evaluation is done by the Postgres server. So we're going to start with basics, and then we're going to start digging into how the PG stat database conflict view, which maintains a counter of different type of conflicts, is maintained by the server itself. I think you've seen a lot of the branding already with regards to Percona's Postgres, Mongo, MySQL, PMM. So let's get on. So a bit more about myself. I have more than 2 decades of professional software development experience and in different fields, whether it's AI, telecom, but I have more than a decade experience in Postgres now. So in different roles, different capacities. I've been with Percona for more than a year now. And one of the things that stood out for me at Percona was an amazing, very welcoming and warm culture here. Prior to Percona, I was with Enterprise DB and Hygo, both of which are Postgres-related companies. And at Enterprise DB, one of the core focuses of my team was to deliver the Postgres official one-click installers, which you might have used in the past for Linux and Windows or OS X now. And at times, we were working closely with Devrim Kunduz for the RPM side of things in the Postgres community as well. At Hygo, it was more about an in-memory database setup, so an extension of Postgres access method, and an ORC FTW that I did. If you want to reach out to me, here are my personal contacts, my email address, LinkedIn, and Skype. I'm generally available on all 3, but more active on LinkedIn. So feel free to get in touch with me. I'd be happy to talk. If you want to reach out to the larger Percona community, we do have open community forums where you can come and discuss anything related to Postgres. So there's no license involved here. It's just open free community thing. So feel free to discuss Postgres, MySQL, Mongo, PMM, or pgstat monitor, which is coincidentally the extension that was released a week ago by Percona. So it's a query performance observability extension, similar to pgstat statements, but different and enhanced in multiple ways, eases off some of the pain points. And you can always look at our GitHub, which is, again, being an open source company, GitHub is critical, and all our work can be found, and you can come and share and contribute there if you wish to. Feel free to share the word, Percona Live, hashtags. So let's start with some initial thoughts. I think with replication, as is the case with query performance, it's really about you set up an environment, you think that it's configured optimally. Over a period of time, the performance starts degrading. And what do you do? How do you manage it? In terms of databases, the only trigger points are really the queries, which then change the state of that system and then can lead to different kind of performance issues. So it's, again, query monitoring at the core of it, looking at the statistics and relations and views that are available in Postgres by default, that's a lot of information. I think Postgres 14 has more than 50 relation and views in the statistics setup. So, and then obviously with replication, you would want some cool failover, switchover handling. What kind of tool you would wish to use? Again, it's very use case specific. And finally, it comes down to understanding and mitigating those risks. And those risks are really what this talk will focus on today. So those risks are whether those are replication lag, but this will focus more on the conflicts. Presentation outline. So we're going to start some initial discussions on locks, look at the concept of wall, then a bit of history of Postgres replication, how it got implemented, types of replication conflicts, and finally how the server then identifies those. One of the reasons why I took up this topic was because Postgres in itself, with more than 50 statistical views and relations, there's just one view that addresses replication conflicts. You could, and that's the PG stat database conflicts. You could say PG stat databases also has it, but it just has one field, so it doesn't give you any insights. So in all of that, a critical component, and that's very kind of undervalued in Postgres. Locks. So there are multiple types of locks. Some are light, some are lighter. And they're actually, for this talk, I'm just going to discuss 3 locks. There is actually another type of lock, but we're going to skip that. Spin locks, they are the lightest form of locks that are available in Postgres. These are not user-facing locks, but these are just internal locks. In terms of their lifespan and how they are meant to be used, if hardware atomic operations of test and replace is available, then that's what it really relies on. But it's a spin lock that spins, consumes CPU time, but the background is that it's intended to be used for a very small set of instructions. So you would want to, this would be used for something that will just occupy maybe a couple of dozens of instructions, not more than that. So being that lightweight, it's not having any kind of overhead in terms of, say, deadlock detection. It does not release on error. So there's no niceties with this kind of lock. It's just a simple lightweight lock that spins, that's just waits. And it has a timeout, which is 1 minute, considering that it's supposed to be used over just a few instructions. That's a long thing. Then you have the lightweight locks. Lightweight locks are for internal data structures, so controlling or basically the gatekeepers to that data structure. They allow read-write access, they allow shared access to the data structure, so they're basically controlling the internal structures. What you cannot do with them is not allow a process to error out and still hold that lock, because you want to access that buffer. You want to access that data in memory. Since there are different types of locks and it's not like an exclusivity on this lock, hence it's basically automatic release on error as part of this LW lock. So elog error would basically release this log. Again, no deadlock detection, not meant to be. It's small and you wouldn't want that overhead to be there. So it basically relies on sysv semaphore when there's a wait involved, and the wait is then managed by granting the locks in the arrival order. So no priority queue there. Finally, and more relevant to this talk, are the regular locks, the heavyweight locks. These are as heavy as you can get. They're for table or even for user specific initiated locks. So they have deadlock detection. They're basically attached to a resource manager as well. We'll see why that's important and why that can lead to some other issues in replication as well. But these are heavyweights. They occupy a lot of, basically they consume a lot of CPU. They have a lot of processing involved. It's just lines and lines of code that handles locks in different forms and ways. Write ahead logs, wall. I was hoping that I could get a wall headbang GIF in there, but I couldn't find one that had an open commercial license, free license. Replication is about playing catch up, and that's where the wall comes in. So replication is all about the primary server and the standbys catching up with the primary server. WAL was actually introduced in 7.1 back in 2001. One of the reasons why this was implemented was to prevent data loss. Previously, the processes were just actually writing on the disk directly. So this was one way of logging and maintaining what was being done on the data. So you record the actions, you record the changes, and that's what really builds up the WAL record. It ensures the D, which is the durability and ACID compliance, and that's also obviously very important. Version 9.6 and below, this was called pgxlog, and a number of users simply wanted to remove all the log files that they could find in the data directory, which obviously did not leave the system in a clean, runnable state then. So this was changed to pgwal in version 10 and beyond. So you will obviously come across a lot of data structures internally that may refer to xlogs, but it's now been changed. I think version 10 had an option in configure. When you're building from source, you could configure the WAL segment size, but now that option is available as part of initdb as well as PostgreSQL.conf. So when performing initdb, you can actually specify WAL directory and the WAL segment size. And it's not just about relations, it's also about indexes. So anything that is meant to be stored on disk data files needs a WAL record, because that's when you want to be able to recover from a potential issue. So basically, the thing that happens is that you don't want to write immediately once a change comes in. You don't want to basically save that page on disk. Why? Because that would obviously create a lot of overhead. Imagine a page containing 300 tuples, and that 8K page would have to be written every time a new tuple comes in, would have to be written directly onto disk. This prevents that. So not just that it provides durability, but also improves significantly the performance, because you don't have to do those IO operations immediately for all those pages every time a new change has come in of that scale. So it kind of improves significantly, and then it also provides you with a recovery point from where you can basically run the log, since those pages in memory would have been lost if there was a crash, a certain power shutdown, or any other major issue that would lead to data loss. But that's where the WAL comes in, because you now can recover from it and replay the WAL and basically come to avoid that data loss. So when you do a checkpoint, PG control writes that information, carries that information. So it carries that information about the LSN and the checkpoint details, and it also then provides you with that option to redo, or the point from which you can redo that recovery. After a checkpoint, WAL will contain a full page image write if that page is changed in memory. That again helps significantly in ensuring that there is no data loss. In case of data corruption, you have a full page write after a checkpoint, so you know exactly the state of that page. And WAL file nomenclature is pretty odd when you look at it. It's a long file name, a 24-byte file name with the first 8 bytes. The ones in the blue are basically your timelines. Then it's the next pair of 8 bytes, and the one after that are basically LSNs based on LSNs. So they're calculated with a very simple formula, nothing too fancy. It's just a division by a number of LSN, and then you're modding that. So LSNs are log sequence numbers. Why they're critical? When we discuss the replication, you'll understand why I'm discussing this. And you have a data type in Postgres of PG LSN. It's an 8-byte unsigned integer, and it's represented as a pair of 4 bytes each, and separated by a slash. And that's exactly what the value you can pick up and understand where in a WAL file this LSN resides based on a simple function that's available. So it's pretty useful. So you can track down where that change resides in the wall. So replication in Postgres, the nomenclature might make you think that it's somehow related to global warming. It started off with warming up the replication environment. You had the warm standbys, which were also called warm standby log shipping method. It was introduced way back in 8.2 in 2006. And it brought in the concept of continuously archiving and continuously recovering. So you'd have basically on the standby a continuously recovering process, and on the primary, you're basically continuously archiving. You're storing and shipping away the log file segments. It was asynchronous. What we were really doing was that it's basically not immediately shipping any wall records. It was combining a number of wall records, creating a package, and then shipping onto a standby. Therefore, data loss was possible because something could happen in that time where things could break. You had the archive timeout configuration parameter, but then there comes the trade-off between bandwidth requirements and how frequently you want to ship that out. So this was Postgres' first step towards high availability rather than disaster recovery, because you now have a server that's up and running that matches the state of pretty much the state of the primary server. Streaming replication came in 2010 with 9.0 release. It brought in the concept of two postmaster processes. You had the wall sender and the wall receiver. So this is basically similar concept to continuously archiving and continuously recovering, but in a different way. Now the backend processes are there, which means that the core server can now respond to, on the standby, to queries and incoming connections. The responsibility of these processes were not just to ship the log files, but also to flush them on disk. So making sure that that durability is maintained, whether that's on the primary or sender or the standby. And this is where the first couple of functions in terms of monitoring replication came in, with receive location and a replay location. But the challenge remained, it was still an asynchronous replication method, and data loss was still possible. But that problem was immediately addressed with 9.1, with streaming replication coming in and making it a synchronous process. And it effectively, strictly guaranteed the data integrity. And that was like when you can rely on data to be identical on the standby as well as the primary. There were new configuration parameters added, not a lot of internal structural changes, but you could have, say, the option of you turning off synchronous replication, synchronous commits on standby. You could, so on the primary, by turning off that synchronous method in a transaction block at the start. So you could turn off and not make it wait if you had, if that could slow down things. With synchronous, obviously, you don't want to heavily depend on something and cause a bottleneck in the entire system and have a failure because of that. So the concept of quorum, the priorities, and then it being evaluated in context of active and connected standbys were also came in as part of that. I'm not going to dig in further, but I thought these concepts were important before we look at other aspects. Decoding wall for replication was introduced in 9.4, and there are other changes that have been coming in since. Replication catalogs and configurations. So basically, the three relevant views for this talk: one we have on the primary server, which is the pgstat replication. It contains one row per wall sender process. The wall sender process, or that row or that piece of information, is very similar to pgstat activity. It essentially provides you with the connection information. It provides you with the state, where pgstat activity tells you about the transaction times. Here it tells you about LSNs, and it also tells you about the intervals, the delay intervals. So it's very similar in terms of understanding how a standby in particular is catching up with the primary server. So you have for the standby, you have write, flush, and replay LSNs and intervals. So giving you an exact scenario of how, in terms of network, how far behind that standby is, but also in terms of implementing that or running that wall. So you can understand from those. The additional piece of information that it tells us about the primary is the sent LSN. So that's the other piece of information it provides. pgstat wall receiver tells us or gives us the same piece of information, but it gives us in a very standby context. It has just one row, so it just has one wall receiver, and it can only have one. And what it tells us about is the connection string with the primary server, but it does obfuscate any security-related fields. So it's not exposing any passwords or any other critical information. It tells you about replication slot that it might be using. It also tells you about similar statistics. And finally, the only view in Postgres that tells us about replication conflicts is pgstat database conflicts. It's a very small, simple view. It has one row per database, and it tells us why certain queries were cancelled. So it doesn't really tell us about the actual conflicts, but it tells us about when an abort or a cancellation has occurred because of a conflict. Not a lot of fields. It has dat ID, dat name, so just identification of the database, and then it has 5 big ints that are basically counters of different type of conflicts. pgstat database also has one field of conflict, but that's just one counter. Nothing, no insights, no other information. It's just an accumulation. The other thing is that this information is ephemeral. So if you restart your server, the standby, this information goes away. So there's no persistence here in terms of having that information. Now, digging a little deeper into the configuration parameters, there are tons and tons of configuration parameters that could impact replication. So you have max wall senders. That's basically, so max wall senders are your wall sender processes, but in terms of configuring it, say you want to configure it for 10 standbys, but if there's an abnormal termination of a standby process, then there would be a timeout before that connection or that slot becomes available for the next incoming wall sender. So what you really want is have that number just a little higher than what your actual use case suggests. You have replication slots, then wall keep size. Now that's a critical configuration parameter in terms of the standbys being able to track or acquire those log files from the server, from the primary server. It is basically defined in terms of megabytes and how much data the primary server should hold as the standby catches up. This defines the minimum amount of wall data that the primary server will maintain. It may maintain more than that based on the checkpoint and the status of any recovery process. So it's basically going to consume or save more data potentially, but this is the minimum that it will maintain and guarantee that this much data will be available for standby to catch up. The 3 terminologies here are sending server, primary server, and the standby. While primary and standby are pretty evident, sending is a term where in case you have a cascade replication implemented, a standby then becomes a hub which then transfers wall files onwards. So that's what a sending server is. Any server that's basically shipping out log files is a sending server. It can be a primary, it can be a standby server as well. For primary server configuration, you have the synchronous standby names. We've already discussed that in terms of how you can configure, and Postgres documentation has a lot of details on it in terms of how you can specify priorities and quorum for this. The other thing, the other parameter is the vacuum differ cleanup age. Now that's something that can directly have an impact on the conflicts. Why? Because in terms of number of transactions, it tells us, or it tells the server how many transactions, basically the age in terms of transaction numbers, before it cleans up vacuum or the hot chain pruning cleans up any dead tuple versions. I suspect there might be with PG14 with the duplicate version churns. It might also have an impact there, but I could not find a reference in the documentation for it. I didn't have the time to look up in the code, but that duplicate version churns may also be part of this, because it's very similar in terms of hot chain pruning and how that locks a page and then cleans up. On the standby server, again, there are lots of configuration parameters. But what are relevant for this talk are max standby streaming delay, wall receiver status interval, and hot standby feedback. We'll come back to these as we discuss further. So conflicts, why would conflicts happen in a replication environment? We have a primary server that accepts reads and write queries, and we have standbys. The standbys just accept read queries. The challenge becomes when multi-version concurrency comes in, and you have to have you have to honor multiple requests, which means that you now need to have locks in place to honor those requests and maintain that isolation. And conflicts only happen on the standby server, so it's not related to the primary server. No conflicts happen because, again, the MVCC takes care of all of that and manages those conflicts. So it's when you have a higher priority backend process that needs to implement some changes, and then there are other user processes which are holding back those locks, is when the conflicts happen. So you have a higher priority process on the standby. Why these could happen? Well, the transactions or the long-running queries, as always, are the usual suspects. So one of the surveys I did internally in Percona and discussed with DBAs as to how many of them have experienced replication issues. More than half, and this actually, if I was to add some weightage to those 55.6% who said yes, they had a lot more experience, and some of the ones have never, people who've said no, a couple of them have not even worked with replication. But the point being that it's a significantly large number in terms of how they've experienced or come across replication conflicts. Type of replication issues faced. Well, you can see from this graph, I'll just stay quiet for a minute, but you have replication lag, loss of wall files, you have problems with replication slots, logical replication conflicts, table space conflicts, lock conflicts, snapshot conflicts, buffer pin conflicts, deadlock conflicts, slot missing after failover issues. Well, replication slot missing after failover, I don't think that's a surprise for anyone. That's not a feature that's been implemented yet. But other than that, well, loss of wall files, that's a potential configuration issue. But then there are conflicts. The conflicts are something that can be avoided because those are potential with a better insight, with a better knowledge of how the server identifies those conflicts and then reacts to those conflicts. You can potentially work and configure server optimally to basically avoid those conflicts then. But looking at these numbers, 60% have experienced issues with locks and snapshots. So the type of conflicts that we're basically going to discuss, pgstat database conflicts collect stats for 5 different conflict types. There's tablespace. Tablespace conflicts can potentially arise from temp tablespaces where a temporary file, say sorting needs to be written, and that tablespace has been dropped or is no longer accessible. So that's where a potential table space conflict can come in. I've been trying to reproduce it from other scenarios, but it was pretty much impossible to do that. Buffer pins, buffer pinning is when effectively, say, a page has been pinned on the standby, and then it needs to be accessed, or a wall coming in needs to access that, and that's when it comes in. Then you have deadlocks, but all of these three are pretty uncommon, because how many times would you drop a table space, or how many times a table space issue would come in? It's not something that's changing that frequently. Buffer pinning again is delicate, but it's rare, not that common. What are more common are lock and snapshot issues. Locking issues are related to, say, transactions holding locks, queries holding locks, and snapshot is when you're trying to access tuple versions that are no longer accessible. Why, say, a lock issue would come in? Yeah, there are a couple of typos on this slide that need to be fixed. But you're querying a table for the contents. And that table, once you query it, it becomes part of your resource manager, your transaction resource manager, and it becomes basically linked with that. Now, even though you're just simply querying that in a transaction block, you do have an access shared lock on it. And you're maintaining that until the lifespan of that transaction. What happens now in the background is that wall receiver has received a file, and now it needs to process, say, that table needs to be altered or it needs to be dropped, but you're holding a lock on it. And that's when the conflict happens. How the server reacts to it, I'll explain in the next few slides. Similarly, snapshot is when, say, the vacuuming has happened in the background or is needed to happen, and you're just holding those locks, holding those tuples, and the server cannot get its way through. There are other types of conflicts, but I've not seen many of those. So the environment where I tested out these things, and you can test it in your environment as well. It was a server 14.1 built from source on a CentOS 7. So I was running a primary and a standby server and attempted to generate some lock conflicts. To generate a simple lock conflict in a replication environment, so it was streaming replication that was set up, no rocket science involved there, just a very simple streaming replication. On the primary side of things, create a table, populated it with 100 rows, and we have a table. On the standby, I begin a transaction, I query that table. The moment I query that table, the resource manager now identifies that this transaction has queried this table, and it's basically going to put a lock on it. It's a shared lock, but still, it's a lock. I drop that table on the primary server. On the standby now, it waits for max standby streaming delay, which is by default 30 seconds. And until that expires, if the transaction has not let go of that lock, querying will cause a server process termination. And it gives a very specific answer why this has happened. You're holding a relation lock for too long. The wall receiver process had to implement some changes, and it could not do that because you're holding a lock. And this is what the pgstat database conflicts would look like. It has incremented the lock counter by 1. So what happens in terms of the code flow? So it starts with the postmaster, the main process, but after that, it starts with startup xlog. That's when it is starting to receive the log and then trying to redo that log on the standby. it wants to acquire an exclusive lock in this particular case. So what really it wants to do is acquire that lock, and it goes through a huge set of code, a lot of functions, a lot of stuff, and it tries to acquire that lock, and eventually it waits on it. It identifies the backends that are holding that lock because it needs to know which ones are. Finally, it sleeps on that lock based on the streaming timeout delay that has been configured. So it sleeps on it, it waits for it, and if the transactions have by then let go of their locks, and it's free to do it. Otherwise, it's basically going to generate a signal asking those backends to terminate with a specific message of locks, and hence you see a very precise error message on the client side. This is all on the standby. So this is when it receives a wall file, a wall record. It starts to process now, and this is where the lock, basically the error, the conflict generation would happen. Also, I think worth mentioning that in terms of the amount of code of locking that it goes through just to check this, I think it's probably in thousands and thousands of lines that it just goes through, looks at resource manager, it looks at the portal, it looks at a number of data structures where the locks are being maintained, and then finally waits on the lock and generates that message for the backend to terminate. How you can possibly avoid or at least mitigate this case is again looking at the locks and stat activity in combination. Stat activity will provide you with the connection details, and locks will provide you what locks are being held on what relations. So combining the two pieces of information will tell you, for example, which locks are being held by which backends, and whether you want to analyze that, whether there's an application that's behaving like that on a consistent basis. That's the piece of information you can save and preserve. The other thing is you might want to configure the max standby streaming delay, because if you have long running queries and you've not configured it according to you've not configured your max standby streaming delay based on the lifespan, the expected lifespan of your queries, then there will be a conflict generation eventually. How frequently would that happen depends on the frequency of that query. And finally, it's about optimizing your queries. It's about optimizing the transaction blocks, making sure that there are no unwanted queries to relations that are not really needed. Because the moment you query, whether that's a select query, it came as a surprise when I looked at it, because I thought in a simple select, why would you hold a lock? But that lock is preserved for the transaction until the lifespan of the transaction. So the queries really need to be written based on that. Snapshot conflicts, so a little tricky to generate, but I had to kind of rely on a cursor to help me with that. Simple table generation, again, a few rows in that, declaration of a cursor, testing out, and then fetching from that cursor. Now, behind the scene, what I've done is I've deleted a number of rows from that table, and I've issued a vacuum command. I did not rely on the auto vacuum to vacuum that relation. So manual issuance of that command would mean that the conflict would happen pretty much immediately. The vacuum delay that can be configured otherwise would not trigger in this particular case. So manual vacuuming will enforce immediate conflict in this particular case, because my cursor would want to fetch new rows now, and the connection would get terminated again with a snapshot conflict immediately. And again, the error message is very explicit. It tells you about row versions being removed. And the good old friend pgstat database conflicts has incremented the counter. This one, sorry? You no. Postgres does not allow read uncommitted isolation level. So the default is read committed. It does not allow dirty reads.
So there's really nothing you can do besides terminate the back end or make the back end faster.
Yeah. There's
Even for like a roadblock, something like that.
Yeah. I mean, nothing you can do other than just.
Except adjust the stream.
Except just that. Nothing else you can do. If you have cursors that are open, you have transactions, or if you have applications that are, or client that's planning on fetching rows and it's not fetching the entire set, then obviously you'll run into.
Can I see two backends? Sorry, I didn't have much.
This one?
Forward, sorry. The vacuum, is that a good idea? Does the vacuum can actually delete?
Well, this was, in this particular case, I was trying to generate the conflict. But the vacuum will happen. You have trigger points for the vacuum, which are configurable, but the vacuum will happen, and you may, depending on your workload, basically.
I'm wondering if it's a good idea to like kick it off manually after maybe you delete like a bunch of data.
Well, if you know the state of the standby, then yes. But if you know, for example, there are queries running on the standby, and you run it immediately, then in this particular case, it's not going to honor any timeout delays or allow the standby to close those or end those queries. It's just going to cause that conflict immediately, which will terminate those backends. And basically, if you do that manually, you're taking away that flexibility away.
So if you don't do it manually, let's say right away, don't you have the chance for some sort of a conflict later?
Well, so later, perhaps, but it also allows you a bit of time window based on your delay configuration. It also allows that time window to take place and let those transactions finish and wrap up their work before they start cleaning up. Because you do have, in terms of, say, what you really want the standby to be able to do is not give wrong data, right? So you've not caught up with that, but at that point in time, you still have those pretty valid snapshots, which are basically going to return that data. What will happen is, yes, the data will not be up to date, but it'll still be valid in terms of the state of that data at that point in time in the timeline.
So if you just let it go and don't do the vacuum yourself manually, somehow you'll avoid this type of snapshot.
Well, if your delay is not configured optimally, it will occur. But but if you know the state of say you have a massive activity on your server, and you think that the vacuum will take huge amount of time on the standby, then you might want to do a vacuum yourself. But that would also mean that any running transactions you might want to abort those, or you might want to basically take that downtime hit just to make sure that you avoid any application issues.
Ordinarily, when you do like large batch deletes or updates, you want to run a manual vacuum. And particularly when you have a standby, you want to kind of time it so you don't get these conflicts. So when you trigger a manual vacuum, you're actually coordinating that work with the read workload on the replica. But then the other part of this is like if you have a high OLTP environment and you're constantly updating and deleting.
Yes.
The vacuum is just going to happen constantly, pretty much.
Yeah.
And if you have long-running queries on the standby, that's where you have to ensure that your streaming delay is set appropriate. Sure, that really makes sense. Like the streaming delay makes sense. I was wondering why you might not have the same snapshot conflict later.
You could, but I mean, you still have some margin to or give time window to those transactions to wrap up their work. Because right now what you're doing is immediately issuing a termination. If they're busy.
The problem is going to be an open transaction at the time.
Yes. Yes. In terms of how the code looks like for this, starts off pretty similarly. You have starts with xlog processing, and then you need to perform a heap operation. So it's not, and it's basically an access method operation. It doesn't have to be a heap one. It can be a ptree method where it's a cleanup operation for that specific access method. So that gets called. Again, the pattern is very similar. It tries to identify the conflicts, and if it's not able to do it, it waits for it, and finally it issues a termination for the backends. So vacuum differ cleanup page, not honored in case of manual vacuum. You have hot standby feedback. Now that's another nice one to have to know, and this eliminates query cancellations for cleanup operations. And it also works with, if you have cascade replication implemented, it does work with that, because that cascading then mechanism also channelizes that feedback to the primary from one standby to another standby, which simply passes on that feedback. I think some closing thoughts. Well, it's all about Postgres with all the configuration parameters that it offers. It's all about configuring it for your workload. You have pgstat replication as a view, but it's tricky. Monitoring the replication lag is tricky. It also relies on certain configuration parameters. So in terms of how much lag you can afford, whether it's a high intensity workload time window, when you you have a bigger lag, and whether the server will have some time to catch up when there's lean load on the server. So those patterns are hard to understand, and they, right now with the current environment that's available with Postgres, they're very tricky, and I think it's very difficult to build a pattern on that. In fact, this is one of the problems we've solved, not in the replication context, but in the query performance context with pgstat monitor that we've released over a week ago. Again, yeah, and one of the configuration parameters for the standby is wall receiver status interval. That's the interval when the minimum time that after which it sends a confirmation of its status to the primary server. So if you have set it, this interval is large, then you might be getting a replication lag indicator that may not be accurate, because the standby has not updated its credentials or the details with shared the updated details with the primary server. So again, this configuration matters. It gives you an exact picture of the lag. Replication slot management, well, failover is still a challenge. It's not been implemented, tried many times. People have, the number of patches have been attempted, but there are some corner cases that could not be resolved. So hopefully in a year or two, you might have something in here. There are other options that are available that can possibly solve this. Percona has come up with one option, or you can have some manual mechanism where you're archiving the wall files and then have those available later on. And long-running queries are not your best friends, whether that's replication, whether that's query performance or the server performance. Those are the killers. Well, Percona, we're an open source, completely open source company, so no strings attached. Our distributions are not in any way tied down somebody. So we're on-disk compatible if you want to use any Percona distribution for Postgres. And thank you so much.
What was that feedback in the cascading replication feedback?
It basically it tells about what's running on the standby. So when you have so in a normal scenario, you have a standby that's talking with the primary server. But you could set up a cascade where, say, for whatever configuration, maybe it's geographical distances and you want to reduce that lag. Linking a standby to the primary would be slower than linking it to a standby. So you basically set up a cascade replication where a standby then becomes sort of like a primary, not really a primary, but a sending server for that standby. So it receives wall files from the standby, from the intermediate standby, but the backwards communication then happens also through the standby, and that's where the feedback comes in. So if it wants to report about it's actively running queries to the primary server, then it comes through that standby as well. So the cascading replication does not break that feedback channel.
So what's it telling? Like process list kind of?
The queries, yes, yes.
I have a question about auto vacuum. Does that create locks in the database?
Auto vacuum will need specific locks. So whether, say, you were talking about, say, auto vacuum trying to clean up, or needing, basically it would need some exclusive locks on the page itself. So yes, but well, auto vacuum, well, you have an auto vacuum launcher, and then you have the vacuum processes that it initiates then. So auto vacuum by itself is not harmful, but it's going to trigger, and when the vacuum process kicks in and tries to clean up, that's when the conflicts can happen.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello, everyone. My name is Naveed Sheikh, and it's Percona Live Online today, and we are going to discuss about the preventive measures to avoid the locking issue in PostgreSQL. So let's start with the slides, and first of all, I'll tell me about myself, and my name is Naveed Sheikh, and I'm a senior PostgreSQL DBA at Percona, and I have around 12 years of experience, 11 years of experience, I can say, in database administration. And I did my bachelor's degree in computer science, and prior to joining Percona, I had worked other PostgreSQL companies like Jetawell Corporation in India and Enterprise DB. And it's now I'm a proud Perconian, I can say that. So let's start with the points which needs to be remembered to avoid locking problems in day-to-day activity. So first of all, let me give you the main thumb rule, a golden rule for PostgreSQL is when you add a column to a table in production, then never specify a default. And also I would like to inform as a note here, like as of PostgreSQL 11, adding a column with a default no longer rewrites the table. So the rest of the tips in this post are still valid and still good. And yeah, so for the who are using PostgreSQL prior versions like 9.5, 9.6, 10, then for that, it's very much valid that when you add a column to a table in a production, then never specify a default. And adding a column takes a aggressive lock on a table, which blocks the read and write. So if you add column with a default, PostgreSQL will rewrite the whole table to fill in the default for every row. So which can take hours on large tables, and which is very much hectic for any DBA. So in the meantime, all queries will block, so your database will be unavailable. So never do this while adding a column like read and writes block until it is fully rewritten, sorry. So like here you can see the command like alter table items, add a column, last underscore update timestamps default now. So read and write blocks until it is fully rewritten. So never do this. You can do, instead of this, you can do this, that select, update, insert, and delete block until the catalog is updated. It's take milliseconds. So alter table items, add column, last update timestamps, and select and insert, go through some updates and deletes blocks while the table is rewritten. So then you can write like update items, set last update equals to now function. Or better yet, avoid blocking updates and delete for a long time by updating in a small batches. That's a good thing. That's a best practice, I can say. So this way you can add and populate a new column with minimal interruption to your users. Also, the next point and the next slide is regarding the beware of lock queues. Always use lock timeouts. So every log in PostgreSQL has a queue. So suppose if transaction B tries to acquire a lock that is already held by transaction A with conflicting lock level, then transaction B will obviously wait in the lock queue. Now, something interesting happens here. If another transaction C comes in, then it will not only have to check for conflict with A, but also with transaction B and any other transaction in the log queue. That means that even if your DDL command can run very quickly, it might be in a queue for a long time, waiting for queries to finish, and queries that start after it will block behind it. So when you can have a long running select queries on a table, never do this. Like I have written this command here, alter table items, add column, last update timestamps. So what we can do instead of this, we can do like set lock timeout to 2 milliseconds. Then you can type the command alter table items, add column, last update timestamps. So what is the benefit? What will you take as an output here is by setting lock timeout, the DDL command will fail if it ends up with waiting for a lock, thus blocking queries for more than 2 seconds. The downside is that your alter table might not succeed, but you can try again later. That would be mostly succeed. And you may want to get query pgstat activity to see if there are any wrong running queries before starting the DDL command. That's a very good and that is very much helpful point, I think, before doing the alter table. Yeah. The third point here is create indexes concurrently, which is very much helpful here because it's another golden rule for PostgreSQL in PostgreSQL that always create your index concurrently. And creating an index on a large data set can take hours or even days. And the regular create index command blocks all writes for the duration of the command. While it doesn't block select, this is still pretty bad, and there is a better way. So create index concurrently. Always create index concurrently. I can say that. Always. Also, don't do this. It will block all writes. Suppose if you are creating the index, here is an example. Create index items value IDX on item using GIN value JSONB path ops. Instead of that, do this. Only blocks other DDL. Create index concurrently items value IDX on items using GIN. Creating an index concurrently does have a downside. If something goes wrong, it does not roll back and leaves as an unfinished or invalid index behind. If that happens, don't worry about that. Simply run drop index concurrently, items value IDs, and try to create it again. So I hope this will helpful for anyone who is using creating index. The next thing is take aggressive locks as light as possible. So when you need to run a command that requires aggressive locks on a table, try to do it as late in the transaction as possible to allow queries to continue for as long as possible. For example, if you want to completely replace the content of a table, never do this. I have given here the example like begin, reads and write block from here actually, truncate items, then long running operations / copy items from new data.csv with csv commit. So what it will do, here you can understand that instead of what I can try to achieve here is when you want to load the data in a new table and then replace the old table, take it this as an example like begin, create table items new like items including all, then long running operation like copy items new from new data CSV with CSV, read and writes block from here actually, drop table items, alter table items new, rename to items, commit. So this is an example to avoid deadlocks or to aggressive locks as late as possible. The third point is avoid deadlocks by ordering the commands. So here is an example. So if you are using PostgreSQL for a while, chances you have seen errors like this. Here, if you can see that there is a error like deadlock detected. And in the detail, you can see that process 13661 rates for share lock on transaction 45942, blocked by process 13483. And process 13483 wait for share lock on transaction 45937, blocked by process 13661. This happens when concurrent transaction takes the same locks in a different order. So here is an example. One transaction issues the following command. This is the command. So concurrent transaction begin update items, set counter +1 where key equals to hello, grabs loops on hello, update item set counter +1 where key equals to world, blocks waiting for world, end. Simultaneously, other transactions might be issuing the same command but in a different order. So you can see here the order: begin, update item, set counter +1 where key equals to world, grabs loop on world, update item, set counter +1 where key equals to hello, blocks waiting for hello, end. So what we have achieved here. So if this transaction blocks, the conclusion is if the transaction blocks run simultaneously, chances are that they get stuck waiting for each other and would never finish. And also Postgres will recognize this situation after a second or so and will cancel one of the transaction to let the other one finish. When this happens, you should take a look at your application also to see if you can make your transaction always follow the same order. If both transactions first modify hello, then world, then first transaction will block second one and the hello log before it can grab any other logs. So this is an example of avoid deadlocks by ordering the commands. So do you guys have any questions on these things? So you can reach out to me. You can reach out on forums of Percona. So we'd be happy to help you for that. So that's it from my end regarding preventive measures, and we can say to avoid daily kind of activities deadlock issue when occurs. We need to check these things so that it would be helpful for any DBAs in his day-to-day life. So these are the preventive measures to avoid locking issues from my end. Thank you guys. Thank you very much for your time. Thank you very much for your precious time. And we are happy to help you. If you need any further assistance or any kind of doubts or issues regarding locking issue, then you can reach out to me on Percona forums, or you can reach out to me on LinkedIn in my profile. Thank you. Thank you once again. Bye.